Everyone, are you ready to unlock the next level of your machine learning career? Do you want to build, deploy, and automate a real machine learning solution in the cloud, just like the top, let's say, AI startups and many others company? You are in the right place. This course is all about real skills, real projects, and real, let's say, job opportunities, and also end-to-end projects. So we are going to build a complete end-to-end MLOps pipeline on Azure deploying models with Azure Kubernetes and automate everything using Azure DevOps pipeline. So just you like to let's see profi teams. So, but there's indeed a deal. Before I go all in and publish the entire course, I would like to see who is really hungry to this knowledge. If you wanted to learn the skills that take you, let's say, from just another data science to a cloud machine learning in a demand. So smash the like button, subscribe, and let me know in the comments that you're ready to join the next generation of machine learning expert. So let me show you the journey step by step, hands on, and focus on what, let's see, the the industry or the companies really need. So the environment setup. So we will set up your account, let's say your Azure account, install all the right tools and configure your system. So you will be ready to build in a, let's say, in minutes, not in a days. And then automated cloud infrastructure with Azure DevOps pipeline. So in this section, you will be, let's say, a DevOps hero. You will learn how to use Azure DevOps pipeline to provision and also configure all your Azure resource automatically from resource group and ML workspaces, storage account, containers, and more. So no more manual. Let's say click. Everything is repeatable and scalable for the production ready. For this section here is Azure Kubernetes Service cluster setup. So deploy at scale, just like the top companies. So build and secure your own Kubernetes cluster connected to the Azure ML and get ready to launch models with from scratch. So in this section also I will teach you how to use Kubernetes from the Azure ML Cloud, and also how to attach if you have, let's say, a cluster from your PC. And the next section is secret management. So use a secret key and industry, let's say, best practice to keep your credential, API keys, and secret safe. Must have for any ML engineers. With the data preparation, okay. So there's a space. With the data preparation, work with data, upload, organize, and fusion your data sets for reproducible machine learning algorithms using the tool top, let's say, teams rely on. And the next one is experiment tracking. So no more random result. Track every parameter, every matrix, and every run. So visualize and compare your experiments to find the best model and also fast. And model, and the next one is a model training. So train smarter, not harder. So use Azure powerful compute to train your models, monitor performance, and debug issues like Pro. So in the training, we will try to train our model on a cluster or maybe in an instance, and also we'll try to do it in Kubernetes. For the model registry, control your models like professional. So register, version, and manage with Azure ML model registry. So it will be easy for you. Sorry. Yeah, so we will try to do this model register so we can get these models easily and deployed and even retrain the model. And the next one is model deployment. Go live for real. So after your training, you need to deploy your models as scalable APIs using Docker and also Azure Kubernetes Service. Learn the strategy. Let's say the strategy that I have been used, and also inference monitoring and model performance. So proof your model works even after launch. So sometimes you have a big problem. So for instance, your model is running in your PC, but for the real time, it's somehow it might be not working. So monitor traffic, latency, and error in the real time. Set up a dashboard and alerts so you always know how your models are performing. And for the data drift detection and auto retraining, so detect the data drift and automatically trigger retraining pipelines and keep your models accurate and effective. So maybe the data is a change over time, or maybe the environment is a change. So your model won't be, let's see, working, let's see, anymore. And the next one is responsible AI. So use Azure responsible AI tools to check for bias, fairness, and also transparency. And the next one is EBI securely. Secure your endpoints with authentications, encryption, and also network best practice. And the last, I think, one is the CI/CD pipeline for machine learning with Azure DevOps. So build a true CI/CD pipelines for your ML life cycle, automate training, testing, and deployment, all with Azure DevOps YAML pipeline, or maybe with a classic pipeline. I will try to do both of these. And this is the real, let's see, MLOps. So you are ready now to invest in your career and build the skills top companies, let's say, are hiring for right now. So let me know that you are in, like, subscribe, and comment below what you are most, let's see, what you are most, let's see, exactly to learn. If there's any, let's see, enough energy, I will try to release every lesson with the step-by-step demo, real code, and also answer your questions. So that's enough. Thanks for watching and see you next time. Hi everyone, welcome to this course. I'm so happy you are here because today we are starting something really special. You are we are going to learn how to build machine learning systems that actually work in real companies. This course is called Build Real Industry MLOps with Azure Machine Learning, PaDiM, and Azure Kubernetes Services. And I know that sounds like a lot of big words, but don't worry. I'm going to explain everything in a simple terms, of course, in this course. And by the end of this course, you will know how to build AI systems that big companies like BMW, Amazon actually use. And the best part, companies pay really good money for these skills. So it's your time. So if you are excited to start learning with me, please hit that like button. When you like my videos, it's really motivates me to keep, let's see, making more content like this. And also this course, I have also did a voting that, and also I found that figured out that many people that are looking for this such courses. And but first, I need to tell you a big, let's see, problem in EI. And here's the shock fact that 85% of EI projects fails. That means only 15 actually work. Why? Why do so many fail? So it's not because the AI models are, let's see, bad. It's because nobody teach you how to actually use them in real life. And most courses teach you on how to build demos, but demos are not the same as real systems that work every single day. That is what we going to, let's say, to fix today. And here, this is slide. He's showing why most ML pipelines fails. So first, we are not building a toy project. We are building something real that could work in actual factory. Second, we are using the same tools that companies used. These are professional tools, not a beginner, let's say, stuff. Third, we are learning about finding problems in a factory product. This is called anomaly detection, and it's super useful. So for this project, for this, let's see, course, I'm trying to use a real project, which is most of the companies, let's see, industrial companies, for the use it for the surface inspection. And but here's what I love most about this course. When you finish, you won't just know about, let's say, AI or Azure or Kubernetes. You will have built something that shows you can work with real business problems. The kind of project that helps you get a great job, of course, as we done, as I done indeed. And if that sound awesome, please subscribe and hit the bell. I have so much more to teach you. Of course, all of these we will I will show you all of these in more details, and I'm quite sure I will you will be able to build a real model using Azure ML. And let's see, let me just tell you about this story at this why this matter. So think about BMW, the car company. Every day, their factories make thousands of cars parts, and every single part has to be a perfect. Why? Because if one bad part gets, let's say, into a car, they might have to recall millions of car. That costs indeed a lot of money. And as you can see here, 1 minute is cost 1,000 euro. And right now, people check these paths by, let's see, looking at them with their eyes, but people get tired and they miss most, let's see, important things. And the computer, let's say, the system, the real system, could work in 24 hours, I mean, and 7 days a week. So it's not like a human. But what if I could use AI to check this part? This is what we learned. And AI never get tired. And it can spot problems that human eyes might miss. This is also happened to also to me. And that's exactly what we are going to build, a system that can find problems in a factory products automatically. And plus this, we will use Azure for automation, fully automated. And let me just go to this one here, and this is the complete the in the production ML requirement. We have to automate everything, so zero manual intervention from training to deployment using CI/CD pipelines, and also handle traffic automatically with Kubernetes services, which is called auto scaling. And also we need to monitor if there's any data drift, model drift, and this we will see in the, let's see, app insights. And we have to make all of these steps are secure and no one can, let's see, hack on this our let's see system. And if there's any, let's see, drift in a data or in a on a model, of course, if it's the model is there's some model drift, it's because of the data. And here we need to retrain the model automatically and try to test it on a subset of the, let's see, of the users, and see what is the benefit, and try to compare several models and see which one is outperforming, and we can, let's see, after that we can publish the good model. Okay, so And here's to complete MLOps solution. So let me show you here what we are going to build together. We start with a picture from factory. I mean, let's see, I will try to use some images from from a folder indeed, or let's see, we can upload it to the cloud, or we can open the camera, the real camera, and see if we can detect some defects from the for the images. And these are, let's see, real photos product that need to be checked. Let's see, this is the and this picture goes into something called ML Azure. And this way we train our model to spot, let's say, the problem. And we use a special method called PaDiM. I mean, this is the PaDiM, which we said it's anomaly detection algorithm, which is unsupervised learning. And don't worry about the name, just know it's real good at finding a problems with just few examples. And of course, I will show you. I'll tell some, let's say, theory part about this. And we also use a special method called, yeah, I mean, what is it, this. And now we will somehow need to track the model and also the parameter automatically, so we can use ML flow. Okay, sorry. And our model runs on something called okay, sorry. This we have to make this automatically using CI/CD pipelines, and then our model will run. Let's see, inference model, not training. Only the inference model should work in the Kubernetes. And we built also our API with fast API. This fast way, let's see, to let other programs still to talk to our AI model. So we will try to test. We will try to use this Locust. Locust, yeah, it's let's see, loading data testing. It's to test our model. If you have, let's see, send some traffics and see in the inside what is how the system is reacting to this, let's see, requests, and is it, let's see, scaling up or scaling down, and yeah. And we also use Azure key vault to keep our password safe, applications inside to watch how everything is working. And also, I said this low cost is to test if our model can handle lots of users. And this is the algorithm, of course. And this is, let's see, the complete system, the same kind that really real companies use. And the full stack that we will not, let's see, learn everything here in this pipeline, but we will use all of these tools, and we will learn, let's see, how to build AI systems that work by themselves. So no more doing by our hand, and everything will be 100% automatically. And we will learn how to watch your, let's see, your system and get alerts when something goes, let's see, wrong. For instance, if the data is different from what we already trained our model, or if the model is performing bad on some data, we need to check this, and we have to take a solution. Uh, I mean, automatically, not with a human. And also, we will learn how to test our system that can handle lots of users at once. And we will learn how to make our AI model to get better automatically when new data comes in. And also, we will learn how to keep everything secure and just like, let's see, of course, I mean, many companies like banks, let's see. And when you finish this course, you will have skills that companies really want. And this is what we will learn here. And we will have automated, as I said, and we will use Kubernetes, real system monitoring, and CI/CD automation. And we will test loading, retraining, and also enterprise security, and also anomaly detection. So when you finish this course, you will have skills that companies really want. These skills can help you to get a job that pay a lot of money. So So let me just, so we have here, let's see, we will have using, use our Azure ML, Azure ML Cloud. So don't worry if these names, let's say, sound confusing now. By end of this course, you will know you will know exactly what I mean how to use each of these, and but making these videos like it takes, let's say, much work to do. And please subscribe into my channel, like the videos, and of course if you have any question, just drop it down in the comment below, and I'm quite sure that we will have let's see a fancy and attractive, let's see, journey in this course. And I'm quite sure if you're following everything here, you will, I mean, in this course, you will do you a great job, and of course you will understand most of these these technologies that it's somehow ignored by some machine learning engineer, I will say. Or so yeah, then see you next time, and happy learning. Welcome back to my channel. So you are about to learn how to build a professional MLOps environment in Windows, on Windows. So we are going to combine cloud tools, containers, automation, and Python into one powerful system. By end of this session, you won't just understand MLOps, you will be ready to use what, let's say, real projects are using. And let's go to this journey. So before that, I need something for you. What I need is just like the video, subscribe into my channel, and just comment and write a comments in for this comment for this video. That's it. That's it. What I need. Okay, let's go dive into the slides. So here, what we will build. So you are building here, we will build complete enterprise level machine learning workflow. This is only how to set up your system. Before going dive into the Azure ML and DevOps. And by the way, I would like to be sure that you, up next video, you will try to install, you will try to register in MLOps. So let me just show you here. This is the MLOps, and I have already made a video last in the last course. So I will just put the link in the description below. And what I need is just you have account. Either you have it as a free account with 200 credit from Microsoft, so you don't have to pay anything. But if you already have this, let's say, free account, you have to create another account, or maybe just you have to go to pay as you go. So for instance, for me, I'm just paying for this course. So either you have to, if it's possible for you to create a free account. If not, you have to create a pay to go. And also, if you create this, for instance, this account, let's say I'm creating this account with my email, with my credential. Now, for the DevOps, also you need to create another. You don't need to create another account, sorry, but use the old uh, the username and password that created Azure ML to create as DevOps. So we will try to see, let's see, connect our PC, your PC, your personal PC or notebook, and connect it to the DevOps, and from DevOps we can connect to the Azure, and we did our training, our inference, our monitoring, and everything will be inside all of these threes. And I think that's it. And but please make sure that you will install this stuff. I mean, you will register in this stuff. I will put the link description. Is step by step how to register or how to create account in Azure ML. So because it takes much time and it's already done, so I don't need to repeat the stuff. So, and in this course, we will see how to create Azure ML, and will try now to install the Azure ML CLI commands in our in our PC, in our local PC. That's it's like a channel connection between our PC and the Azure ML, and we will try to see how to install Docker and Kubernetes. We will try to install how to install Python using PyInf and Butry. This is I will recommend you to use PyInf and Butry. If you have another Python dependency management like Anaconda or UV, it's up to you. At least just make sure that you can follow our stuff in the next coming videos, and we will see how to create. This is it's already if you create account, you have to create account for a DevOps that I have shown you here. This is we will create pipelines here to do the training, the inference, and everything. And also we will see how to what are the main let's see packages that will be able to track our experiments. Let's see we have uh, we have training our model, and we have to make sure that we have the track the parameters, the model, and everything, and also versioning, so that the next one, let's say the if you have any bug, and you can reproduce the result, and also the security and monitoring. And I'm just let's see, I'm guessing that all this process will take you 60 minutes. So try to install all, I mean, I will just show you what you have to install, and also I provide the links, the commands line, and everything you need. So you don't need to go and look in any channels, because for me it was really tough in the beginning to install all this and how to make it working for the first time. It was a big let's see journey, I would say. And what we need here, it's this is a complete solution architecture. You need I just divided into three categories. Development environment, we need Python 3.11. You need also a Git, but please make sure that you have installed the Git version. And also for the IDE, I'm using Visual Studio Code. If you use any other, let's see, like PyCharm or any other editor, it's up to you. So just make sure that you install everything. And for the Windows, we will use only Windows in this. So no Linux, no CLI, WSL, and I would say no headache. So let's just stick with this Windows terminal. We like PowerShell, and for the containerization, of course you need a Docker desktop, you need a Kubernetes cluster, and also you need a Minikube that will try to create cluster and interact with the cluster Kubernetes clusters. And for the cloud MLOps platform, sorry, let me just answer this call. Yeah, okay. And we said the Cloud MLOps platform, which is Azure ML, which is this website here. You have to register, as we said, and also the DevOps. MLflow will be installed with Python and Keyboard as well, and also app insights, so that to monitoring our model. Is there any data drift? Is there any model drift? Is there any issue? Let's see in our, let's see, time or latency and everything. And let's see here a prerequisite. So I'm trying to use Windows 11. I'm not quite sure if it's there still 10, but it will be ended, I think, this year. And try to have a RAM 4. I mean, I'm just using 8, but this is, let's see, to get to have a good running time, let's see. And also you need to administration privilege. So it's let's see needed to have to create, let's see, files to create to access, let's see, the Azure ML, and also adding some experiments, adding some. So if you are using the Azure ML, this one here account in your company, I think you will not have, let's say, the permission to create any resource from this. So the best way is to have, let's say, a private account, and just to be to follow. I'm not quite sure because in the companies they won't give you, let's say, a permission to create many, let's say machine learning workspace or Kubernetes or so, because it costs much, I mean a lot. And also we are not, let's say, considering WSL or Linux, and I'm not using Anaconda. Maybe Anaconda as a file. I will try to, let's say, to push for the, if we would like to create environment in our workspace. And I will show you everything in a more detail. Just stick with this plan, and you will create a good project, and improve, of course, improve your safety. And we have said that we need Azure account, Azure subscription, and DevOps. This is clear. And as I said in the beginning, this will take you 60 minutes to install everything here. So let's see this CLI. So sorry. So Azure CLI is your command line. Let's say command center to talk with the cloud. So say let's say we need somehow to create is the mouse. So we need to create a machine learning workspace. So instead of going to the website and creating this with this website, let's say we can do this via CLI command line, and I will show you how to do this without any issues. And I have also gave it the link to install the Azure CLI. You just need to copy this line, and put it here. And this will install, download the CLI. You can see here CLI version, because I have already did. And once you finish, just try to install it. I mean, there's no, let's say, magic. It's just normal installation. And after that, you need to check if you have access. Let's see, for instance, after that, you can see no, before this, PowerShell. And make sure that sometimes you need permission, sometimes not. But make sure that you run administrator. You run this as administrator. So, for instance, when I say uh, easy, just like this, easy, and it should give you some outputs. If not, if it's not defined, something is wrong with your site. It takes much time. Yeah, so now you can see here it is printing Azure and give you this. So after the installation, just try to add this AZ and in the terminal, and it should work. And regarding the installation, we will see how to install this next time, but you can also install this. It's just adding extension, adding the machine learning extension to the Azure. And why he is like sometimes you need to make okay. Are you, let's say, accepting this, or should we continue? This will save you time from asking. So this will install the machine learning extension, and if you would like to update, you can use your update. So let me just update. Okay, I have to copy this, and let's see update. So if it's already there, it will try to update it. If not, it will give you some error. Because here, let's just latest version of ML is already installed. So, and also you need to add this Azure DevOps. We will see how to do it, but you can do it. And because I'm using for the DevOps, I haven't used let's say the CLI. But in case you would like to use, for instance, creating pipelines, running a pipelines and everything, you can just use the CLI DevOps. And to verification, you can just see version. Just type this. easy version, and it will give you what is the version in your in your site. And also this is the CLI and the DevOps. This when you install the Azure CLI, you have to verify with this. If it's not working with you, please write a comment down and write a comment, and I will have a look. I read every comment. So if you have any issues in this, just try to write it down. For the log, so let's say you have account. Sorry, yeah. So you have account, Azure account. Okay. Sorry. So you have account here, right? And you would like now to get access between CLI command line into this. So what you have to do is you have to add easy login. Let me just clear this. Clear, clear. Oh. So easy login. Ah, log, not log. Easy login. So this will try to open a connection. You can see here, and this will, for instance, you have to select your account. Select. Now it will let you see what is the email. Let's see, deep dot at g. So this p is correct. pp. I forgot the password. Okay, cool. So it's working. Oh, select the subscription. No change. So you can see now I have access to the. So now if I write a command to create Azure ML, it will try to create this in this website. Let's see, and let's move to the thing Docker. To the Docker. Docker lets you package your ML code or any project into a containers portable, repeatable environment. So no more it works on my machine, but it's not working in your machine. I have no idea why it's this. So if you Dockerize your code, it has to work in any other system. Let's say any other computers, regardless which is Windows or Linux or anything. So how to install Docker? You just need to follow these instructions here in this. I think it's super easy to install. And after installation, you need to make sure that verify the installation with Docker version, for instance. Let me just show you here which version I'm using. Docker version. So you can see this is my version. So if it gives you any other different, let's see, answer, so it means it's wrong. So you have to make sure that you install it correctly. And regarding the Minikube, it's the same. I give you here the direct link. So when you finish, try to type this Minikube start, and it should give you somehow just get pulling the images from the Minikube website or Git, and it should work with you. So all of these we will see how to do it. I mean, after installation, please make sure that you install everything correctly. So next time we will see how to use this. For the PyInf, why I'm using PyInf? There's several. Why not, for instance, Anaconda or UV? So PyInf is try to use to install several Python versions. And let's see if you have several projects, and each project, let's see, working with different Python version. And for that, you can use PyInf. It will I mean, it's really easy. So just download this. I will make sure that you have this link, direct link. Just copy paste, and after installation, you need to add it to the your path. This has to be indeed it's needed to have to use PyInf, and after that you need to see, for instance, PyInf if it's working or not. If you see, I have, for instance, this PyInf version. It should give you a version here, and when you would like, let's see, after installing the PyInf. By the way, I have already recorded this video 3 times, and for every times I have either the time the sound is muted or I have no idea. It's really horrible. Uh, Python, you need to install Python with PyInf, just with all this only this command here. Python install and the Python version. And you would like somehow to use it as a default. Let's see. Let's just close this. And let's see, for instance, clear PyInf versions. So what are the versions I have already downloaded? And to download to install any further, let's see, install, let's say 3.12.0. So we can just download like this, and sometimes it will take a bit time, but it will install 3.12 in your PC. Now, if you open this and see what is the default Python version, so just type, or we can see Python version, and you can see it's 3.f, but sometimes you need to change it. You don't need 3.11 anymore. So you can just see pyenv global 3.9.0, and you can see now when I check the version, Python version, it will be 3.9. This is the easy, this is make your life easy, believe me. And let's see if the 12 is already downloaded. So now if you see what are the versions I have installed in my PC, you can see here it's 3.11. And to uninstall this, let's see, you need maybe to uninstall. You need to uninstall the Python. So you can see now it's super easy to uninstall, install, and I recommend you to use PyInf and Python. Okay, now let's see, the next step is Beauty, because this connection here, this connection PyInf, Python, and Beauty, it's a good connection. So I have also uploaded a video a long time ago. I will make sure that I will add it in the description. So the Beauty, you just need to copy this, and after that it will give you. This is installing in your code, and if you have any issues, please make sure that you have a Python version. If you have, say, Python version, it should give you something. Then this command will working. And after that, also you have to add this into your environment, as a parameter, as a variable. And let me just show you how to do it. Maybe it's easy. Okay, the Docker is eating the space. So to add it here, you need to go to Advanced System, Environment Variables, and go to Path, and you need to add it here. Just press New and add the link here. Okay, I think this is clear. This is how to add something in the environment. Now, after installation, how to use this in your Python code, in your Python. So in Anaconda, you can see Conda install blah blah blah, right? And here it's easy. Beauty add NumPy, Beauty add MLflow, Beauty add blah blah blah. And to remove it, Beauty remove NumPy, Beauty remove MLflow. And to activate the environment, you need to use this. And I mean, on in all my previous videos, I'm just using Beauty. So if you are following from the beginning, so everything is, I mean, not this course, the previous course, your life will be much easier. And the lock dependency as well, it will try to make sure that, let me just show you here. For instance, this will show you, this is the look file. It will be created. And if I give you TAML file and log file, you will install everything exactly what I'm using in my PC. Why? Because here you can see, for instance, matplotlib. It depends on this version, NumPy 1.20, and you can also see different. For instance, Panda is used 1.22, but he is using 1.20. So this is make it really easy and powerful, I will say. For the MLOps library installation, we will see how to install this. I mean, of course, as the same as you have added the Panda or NumPy or the same. So this is are the most important, let's see, package for Azure. And for the application insights, we have also installed this. But by the way, I have already uploaded in an empty repo. And yeah, see, you can see this is an empty, and I have a project YAML file, which is divided, which is include everything we need in this project. So when we need somehow another tools, I will just add it by add Beauty add the package name. That this is let's say to make our life easier. Now this is the verification checklist. If you follow and install everything, I'm expecting this will take you 60 minutes, let's say to 1.5 hours to finish set up this environment. And because next time we will try to start with the more serious stuff. And this is the verification. If any command of this gives you unrecognized result or something, let's say, unexpected, please write it down in the comment below. I will answer it and I will show you how to fix issues. Now the next let's say levels, or let's say modules, will be, I have written this, but I'm just was thinking before the recording that for instance, this is the Azure, Microsoft Azure or Portal. So it's a good to have, let's see, a small explanation what is what. So for instance, what is the machine learning, when to use it, what is the Kubernetes, what is the resource group, what is the compute and the storage account, and these things will be explained in the next video. And after that, we will try to create our workspace and our resource group, and set up, let's say, our data and how to upload the data images to our cloud. And the next module will be how to train, and the third one how to inference and monitoring. So this is let's say the short introduction of let's say the short set up your environment. So please make sure that you set up your environment. And I'm not quite sure if I already see this, because I have, as I said, I have repeated this several times. I have recorded this several times for some issues. So now you can see now the what you can see. I have no idea. Okay, so please make sure that I need only one support from your side. Only subscribe, like, and comment. That's it. And I this let's say makes me, let's say, motivated. And yeah, okay, then next time, see you next time, and happy learning. Hi everyone, welcome back to my channel. Today we are diving deep into Azure Machine Learning version 2, and I'm going to show you why this platform is, let's say, absolutely game changing for anyone working with AI and machine learning. So Yes. So, if you ever struggle with infrastructure deployment or just wanted to build AI solution faster, this video or this indeed this course is for you. We are covering in this video architecture concept and really world example. So, if you let's say understand what is the I mean the main concept behind this cloud or let's say architectures, you it will be easy for you to manage your work and build a more let's say robust and efficient MLOps systems. So if this helps you, please subscribe into my channel, like the video, and of course, if you have a question, just drop it down in the comment below. I have prepared this. It took much time for me, so and it's super easy for you just to click like. Thanks. Okay, so what is the new in the what is the difference between let's see between version 1 and version 2? And as you can see here, version 2, it was indeed a nightmare. It was multiple SDKs with inconsistent API, and it's let's say limited command line, and also pipeline code was so complex, so you need somehow uh, one who was really expert in this, or maybe implemented this by himself. So but what version 2, it's one unified SDK for everything, a powerful CLI, and actually makes sense to me to use version 2. So I have seen some videos, let's see, in YouTube, they are still using version 1, which is no idea indeed, but I will recommend anyone to use just version 2 because it's really more optimized. And as you can see, here is 50% less code, 33 times faster setup, and also it supported YAML file. And the next, just not clicking. Okay, and you can see now, before we going further, I know this diagram is just taken from the internet, and you can see here our workspace, or let's see the place where we'll put the training code and the models, and let's say we'll create some computes and pipelines, and this is called workspace. And let me just show you what's I mean by workspace. So if you see, this is the pipe, the sorry, this is the original, well, let's see the main page of the Azure. Now, if you would, if I mean, I will show you, of course, how to create the machine learning workspace. But this is, for example, our workspace. And if you see, if I create a workspace, several, let's see, services or resources will be created automatically. For instance, you can see here I have created a storage account. It's automatically. I haven't done this, but when I create a uh, workspace or machine learning, Azure machine learning, it's the same name. So it's not, please don't confuse. So let's create, for instance, Azure key vault and also Azure storage account, and we will see what is the benefit of this. Let me just move this down here. And as you can see here, Azure dependency check, for instance, this is the workspace, as I have said. The workspace is considered as central hub, and it's let's see connected all of these services, so it will be easy for you, for instance, to build your system. And I just want to see something. Yeah. Let's see top down the yeah. For yes, you know. And here's the our workspace, and as I said, it's connected to Key Vault, which will save, let's see, our passwords, our credential, and SSL files if we have, and also a storage account that will save our let's see data set. And for the assets, we have job which is let's see the training and the environment where we have the Python, let's see Python environment, and there are several Python environments is already let's see mounted, and you can just use it directly, or sometimes you have to let's see install yours, so with a Anaconda. And here you can see that the compute the components is for let me just show you the image itself. And let's just go to the workspace, and we can go to launch studio. And as I said, this workspace, it's the central hub of the stuff. And here we have a data. Our data will be saved in this let's see tab, or let's see uh, yeah, tab. And here's the data assets, data stores, and data monitors, and data import, data connections. We will see everything in a more details. So no worries about this. And for instance, the jobs we have now, no, there is no job, but here we can create a new job. But I will show you how to create this using Python SDK or CLI and pipeline. And you can see here, this is the components, and also the components and pipeline, and the environment that this is the pipeline. This is the environment that we will maybe use. For instance, here you can see this is the environment MLflow. This is the downloaded, or let's see installed by the by the Microsoft. So it's not mine. And you can see the context, and you can see the Docker file, the Conda dependencies, and this is included in this environment. And for some let's say reason we'd like to install yours, so I will try to show you how to do it yourself. And this is the models. There we will save our models in this well, let's say registers our model in this tab here, or this in this module. And this is the data itself. And let me just go to the just want to show you the compute. The compute also is connected to this. You can see here it's connected. And yeah, you can see here manage, and here's the connect. And this is the compute instance. This is the compute cluster. This compute instance, it's used, let's say, for Jupyter notebook, and somehow easy stuff. And if you'd like to create a cluster, compute cluster, which is contains maybe contain one or maybe 10 clusters, it's a bit different pieces. And here we will focus in this course with Kubernetes clusters, and I will show you how to create a cluster, how to use it, how to attach it to the machine learning workspace, and everything will be let's see practical. I promise you, indeed, I will promise you that I will show you how to create a professional system, or let's say MLOps, and try to also monitor. You can see here there's our monitoring here. There's a data labeling that you can would like to label your data, and the designer, it's also here. It's like, let's see, it's a drag and drop. Let's see here, custom. I'll just go here, and you can see also has the most relevant models, for instance, for LLMs and everything. So let's see, just go to design, and here you can, for instance, use create, and it's just like drag and drop. For instance, use your data and load the both the model and etc. So this we will not cover in this let's say in this course. And this is the notebook that you can use, for instance, is to check your code. It's easy to let's see, it's already connected to the workspace, and will be easy for you, for instance, to test some stuff. But we can do everything locally, indeed. And the automated ML, sometimes you have a data set, but you don't know which algorithm to use. And if you put it in the automated ML, this will give you a better, let's say, a model, and of course the better performance. And by the way, I just show you here. There's what's this? I think there's a CLI command, but I'm not quite sure where I can find it. But I think I have seen it before, maybe in the door. This one here. So it's like opening a terminal, and you can see connected to the workspace and the compute. So you see, workspace needs the compute. So we will see how to use all of these, and I'm quite sure that you will understand everything, even you have no, let's see, experience. So now this is the our foundation. Let's see the dependencies. So let's break down these foundations. Every Azure ML workspace is built on a top of the four core services. And understanding this, it's really matter. And to use these services, you need to understand how to. I mean, what are these components, and what are the relationship between these components and also the workspace. So it will be easy for you, for instance, to connect to this. So first, Azure key fault. I mean, this will be your, let's say, wallet, and all your secrets, API keys, and credential are stored securely. And there's no more, let's say, to hard-coded password or SSL keys, and everything will be saved in this, and I will show you how to do stuff like this. And the Azure storage, this is just a file storage. It's like your hard disk, and this will try to, let's see, keeping your data set. And I would say it's the backbone of your entire machine learning operation. So your data set, model files, experiments, logs, and everything will be stored in this storage account. And then we have some containers. Let's see, registry. Think of it as a Docker Hub professional. Let's see. And every custom environment, every deployment container, all managed and versioned will be in this containers here. And finally, the Azure Monitor, which is this is your, let's see, a platform to watching your models, tracking performance, and alerting you when something is, let's see, wrong happening. So this is, let's see, a beautiful, let's say, architecture. And when you create a workspace, all of these four services are created and set up and configured, as I have shown you in this one here. You can see, let me just go back, and you can see my, let's see, just see this one here, and you can see my workspace is workspace demo, right? 01. And you can see this workspace, this is storage account. It will be the first name, the name of the workspace, and random numbers with and also for key, it will be created as well. So you can see here W workspace demo 01, and generated random numbers. It's not so, but you also have the possibility to use your workspace and also your key vault and everything. So I will show you also this, how to create. We need to create our stuff with the right names and let's see, the right content and everything. So, maybe one question here: which of these services do you think is important? It's really important. So let me know in the comments below. So now let's talk about the star of the show. It's a workspace. So if Azure ML was, let's say, a spaceship, This would be the bridge where all the magic happen. I mean, this is the most important, let's see, I would say component. Why? This is, you can see it's surrounded by many stuff. And this is not just a folder in the cloud. This is your ML command center that track everything, and every experiment you run, every model you train, every metrics you log, it's all in this workspace, organized and let's see, searchable. So as I showed you, for instance, in this, where to find where to save the data, where to save register the model, and everything. Yeah. So and uh, and regarding also the security, I will show you how to make your stuff, let's see, more secure and also more organized. So this, I mean, workspace here, it's the most important component in the cloud. I mean, everything is important, but this is the central hub. Yeah, if you're learning something new here, please give the like the video and add your comments if you have, let's say, some ideas or suggestions. And let's go to the other resources, which is, as I showed you here, the computer resources, which is contains three different categories. Let's see here, or maybe in this one here, compute. You can see compute instance, compute cluster, and Kubernetes. And sometimes, let's see, you have let's assume that you have a PC in your company, and you would need to, let's say, hire a PC from Microsoft Cloud, because sometimes it's expensive, right? And what you can do is attach your PC into the cloud. And let me just show you somehow for the prices. I think it's show you here. For instance, if you use this PC, if you use this PC here, for instance, and it costs you let's see, 30 cent per hour, which is, I don't know, maybe it's too much, but I will just if you follow this course, I will show you many tricks and tips how to avoid additional cost. So for instance, here you have 10 cores, and you can have a data set between 1 and 10 gigabytes. And if you have more than 10 gigabytes, you have to use this one here. But the cost, oh, see, the cost is somehow, it's even cheaper than this one. I have no idea why. So, oh yeah, because here you can see this is the RAM. It's 32, and here's only 8. But anyway, we will see this in a more details in our practical sessions. Leave. And this is, for instance, the cluster, and I can show you here. For example, you would like to have a CPU or GPU. Let's see, for instance, we need a CPU, and you can also let's see, uh, next, and you can see minimum number of nodes, which is number of it's called cluster. And you can see, for instance, keep it always, if you use cluster, try to keep it 0. And number of maximum, you can just increase it to whatever you want. And so how for sometimes it's only 1, but I will show you how to do this stuff in the coming sections. So let's leave. And for the Kubernetes here, it's not directly easy. This is only if you want to attach the 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 Kubernetes here. Why? Because here you can see there is no cluster. I will show you how to create cluster, then attach the cluster into this workspace. Okay, let's be back here. We have already see this, and now your model, I also showed you your model was the trained model will be saved in the model itself, and the binary files, metadata, local, and also we will use MLflow to track our models, This ML will keep, let's see, serialize our model, the parameters, and maybe sometimes if you would like to track the inputs, you can also track the inputs. And the data assets, sometimes you are working with a data set, right? And this advantage of using data assets, it's versioning. So if you load any data set, it will have to have version, for instance, version 1. And sometimes you need to test another version of data set. It will be saved even the same under the same name, but different version. So sometimes when you have an issue, you will can just refer to which dataset I have been using for this, for instance, experiments. And the environment, as we have said, we can it's uh, I'm just focusing here on Python environments, which is let's see, our focus. Okay. Sorry, guys, I just jumped from this data stores, and data store are secure bridge to whatever your data live, and Azure Blob storage account, Azure Blob storage, data lake, file shares, and connect once to the data set, to the to the workspace. So it's the connection between data stores and data. Let's say storage account, and you have storage account, data store, and data asset. The data store is a connected connection, a secure connection between data storage and the workspace, and everything, let's see, is scaled automatically when you have, let's see, a big data set. And we will use this, for example, Azure Blob storage, which is it's, let's see, a scalable object storage for a large data set. Because we will use some images, I will use this blob storage account, and I will also show you also how there's some properties for the storage account. Would you like to make it, let's see, it's called hot, so it means I will access this every time I need. So this will add some cost to you, and if you have, let's say, less than it's not, let's say, hot, or let's say rare frequency, frequently used, it will list the price. But we will see this in the upcoming videos. Okay, this we have seen, and where is the jobs? Yeah, and here's the jobs and pipeline. Let's talk about both everything together with pipeline. And for the job, it's like a command, and you have, after, for instance, after loading the data set, after loading the code, after creating, let's say, a compute or Kubernetes. I will just recommend you to use cluster for training, because Kubernetes, it will be just used for this is my perspective, for only for the inference. And here we will see how to create a job. What is the job life cycle? How to let's see, add some traffic to this job. Uh, this How to maybe cleaning, deleting, and everything. I will show you here every single step with more details, and I will give you also the, let's say, the potential, let's see, errors, and how to solve this if when you have some issues. And the last one is deployment. Let's say you have created your model. Let's say you train a model. Now you would like to make it live, or deploying your model. And in this one here, endpoint, is that you will try to make your model is running infinitely. Let's see, just right now, infinity, and you can test your data, your model, for instance, whether is it okay, is it running perfect, what about the accuracy, what about the latency, what about the, and in the endpoint there are several, let's see, I will see predictions. So real time, which is like if you send, for instance, if you would like to have a result in real time, so for instance, web application, web app, if you, for instance, put your finger in the fingerprint, it has to give you a result instantly. And for instance, sometimes the batch normalization, it's like using, when you see the Netflix, it just recommend videos after, for instance, maybe when you close the session and come next time, you will have somehow new recommendations. This is called batch blocking, and you can see here the use cases. Let's see web applications. If you send, for instance, to the translator, and it has to give you the translation on fly. But if you, for instance, I have maybe just only one example I have came to my mind for the what's this? Netflix. This is the one I have. Or maybe you have a big data set. Let's say you need to process a big data set, and every time you will get one result. Every time you will get one result. Assume that you have. This is maybe not a right solution, but assume that you have 10 images, and you would like to detect the defects in these 10 images. So in real time, it will give you all these 10 images on fly. I mean, all the result will be available on the same time. But for the batch, it will give you the first image. Then after a while, it will send you the second image. After a while, this is the third image, and etc. So you can see here the latency. It should be less than 100 milliseconds, and it's also auto scaling. And for the batch, it's if you have a high data set, and you maybe here you can see periodical reports. So yeah, sorry. Yeah, and for the pipeline, it's your pipeline automatically triggered when you, let's say, you have a new data set arrived, or pre-process this, and let's say use it in any component, train multiple models. Sometimes you need to train multiple models, validate if which one is the best, and register it to the deployment, and well, and all of these will done while you are sleeping. So, and because everything is component based, you can mix and match, let's say, spaces like a logo. And the best part of the Azure ML handle all the dependencies, management, and resource allocation, error handling, and you have just to focus on your let's see work, your science. It's handle uh, it's handle everything, and you just need to focus on your stuff. So yeah, so this is, let's say, a final I think slide is, and we have covered all of these, and up for the next video, we will make sure to start, let's see, our practical implementation, and all of this, it's only information, and it's really needed for you. Sometimes I'm just I hating the theory indeed, but sometimes it's needed to know what are these components, and to use this component, you need to understand what this component is doing. For instance, I have compute. What is the compute? I have the models. What's this model? What is the endpoint? This is the concept. And for me, it's writing these slides is boring, and also collecting some information from different resources, just to make sure that everything is clear and correct, and it takes indeed a lot of time. So what I need from you is just your support. Is enough. You just subscribe into my channel, like the videos, and also comment for this video if you have, of course, any question, or maybe an idea or something like this. I think, as I said, next time we will see. Let me just show you this. Yeah, hey, this we have seen yesterday, and I hope you already configure your data, your environment. So next time we will start seriously with the MLOps. And let me just be back here. So we will try to create Azure workspace, configure compute instance, set up our data set, and also connect with the SDK Vision 2. And we will start all of these, and I will try to make sure that you understand everything and you can do it even not just with this project, and you will have to do you can do it even for a different project. So I will try to make it everything generally so you can. I also uploaded the data set here. I mean, not the repo, and it somehow now it's empty. So we will fill everything we need. I mean, step by step. So I will make sure that you understand everything, and yeah, that's it, I think. And yeah, please subscribe into my channel, like the video, and also you can share it with your friends might interested in this stuff. And you cannot imagine when I have this notification, it makes me happy. See, I'm serious. Thanks for watching and see you next time. Hi everyone, welcome back to my channel. So after covering, let's say, the most relevant components and theory parts, today we are diving into the practical example and how to create, let's say, some components. So as you can see from this graph here, it's I'm just assuming that you already have a subscription and you already install what we already talked last time about. Let's see, Azure CLI, Beauty, Python, and maybe the Docker is not. Let's see, it's more advanced. But hopefully you already prepare your environment so we can start today just to do some practical examples. So as you can see in this graph here, we have the subscription here, and for the resource group, it's resource group considered as let's say as a as a PC, as a computer, right? And your machine learning or workspace, it's called as a workspace or machine learning workspace. It's like your program that's running. Let's see, OS. I'm just an example. And you have here the storage account that you would like to store data that will work with the workspace, and you have a key vault application inside that will have tracking. Let's see, track the performance of this workspace, and we will cover maybe. Of course, we will cover it, but not today. The Kubernetes cluster, GPUs, and everything. So this is only let's see introduction, and before going to dive into the implementation, I would like to give you this really hint. It's really important for you to the naming. It's maybe you see it. It's easy. Just I will rename it. I will name it resource RG mine. Let's see, for instance, my resource group, my workspace, my storage account. But if you really would like to build a real system, the naming is matters. So please stick with the consistent resourcing name for production environment, and it will be easy for you to let's see to see what are the cost of this let's see resource group. And also you need to add, let's see, some tags, and these tags will even be better if you would like to, let's see, to see what are the cost of these resources with these tags, and it's really matter. So this is a big advice, and please try to focus on this. And as you can see here in the resource group, I will see resource group IG, and here's a project which is maybe industrial or maybe anomaly detection or maybe whatever you want. And here is the diff if you would like to use the diff or production or test and etc. And this is, let's see, is a container for all resource, as we have seen, if you have seen. And this is the central hub of all of the machine learning operations. And this is to store the data and artifacts and etc. Now, why we need to stay with the convincing name? It's easy to identification, and it's also for you. It's easy. For instance, if just imagine if you are working with several projects, and you create several resource groups and machine learning, and if you just use random naming, it will be hard for you to track and let's see use go inside the application inside for each one, and you have to do it manually and hard coded. But if you just follow this, it will be easy for you to track any resource group, any let's see component, and use this exact name. I will try to stick with this naming in this course, and this just to ensure that you are building let's see a professional environment. Oh, sorry, did I move? Okay, and this is one also requirement and constraint for each Azure components. So as you can see for Azure resource group, let's see, I'm just rename it like this, and it has to have alphabet dash underscores and period. And its case, mixed case, for instance, you can write small, capital, and etc. And the length of resource group name has to be one, and also not exceed 90. And it has to be unique in your subscription. So if, for instance, I have OD account. Now I would like to create a resource group. Resource group name has to be unique in the subscriptions, in the subscription. But if you have several subscriptions, you have to have the same, let's say, the same name in different subscriptions. But I don't know why you do this, but this is just to give you an info. And the workspace, it has to start with a letter, and the number of characters has to be 64. And the storage account is this interesting thing here. The storage account has to be lowercase, digits only. There is no dash, there is no underscore or dot. This is constraint came from Microsoft. It's not from me. So, and you can see here it's globally unique. So if you have created, let's see, a test storage account, that might be already reserved for any other users. So try to keep the naming relevant to your project, your team, and unique for you. And also so you can see here, this is the globally unique, and this is unique in resource group. Let's see here, this is unique in subscription, and this is unique, globally unique. So if someone in, let's say, in India or in USA or Germany has this name, for instance, test search account, I will not be able to use this. And if imagine you have a pipeline that will run automatically, and your name after a while you will figure out that, oh, I have crash here. Why? Because the storage account name is already taken. So take care of this, of the naming, and it will save you much time. And yeah, this sometimes it's case sensitive, and sometimes there's no so case sensitive. So what I have done, or what I'm doing, indeed, I'm just using small letters, and I'm following these instructions, these restrictions, constraints, and also the naming of this of each resource group. Okay, if you're still watching this, first of all, you are awesome. Now, listen, I just need a tiny favor to ask. This video needs just 20 likes. Just 20 likes. That's nothing, right? Even if it's small of you hit the like button, we are I will be, let's see, happy. It's really help the channel grow, motivate me to make sorry, motivate me to make more content like this, and it costs you indeed nothing. So go ahead, smash the like button. I'm counting in you. So let's hit that 20 likes goal together. And let's see, I will go to the next slide. And I'm just assuming that you already have everything installed. So please make sure that you already install everything from the last video. I will make the video in the description. So if you just run, let's see here, let me just show the PowerShell. And if I'm saying easy version, it has to give you something. It has to give you this version, for instance. And if you have nothing, so it means your system is not, let's say, proper, let's say, configured. So please, if you would like to continue with us, you have to make sure that your environment is really prepared. So here you can see sorry, Beauty also version, and it should also give you this version, or maybe a specific version that you have already used. But this is just to show you how to check if your system is already prepared. And these some commands will be really needed for the CI/CD pipeline. So please make sure that you will uh, prepare your environment. And now let's start with resource group. And I will show you also the cost of the resource group, and not only the resource group, and all of the, let's say, the all components that will cost you sometimes, let's see, much money. And here I'm trying to see if your money just follow this let's see tutorial and also the instructions. So as you can see here, the resource group, as we have seen in the beginning, it's just let's see a local container that holds related component, Azure components. So for instance, I have a resource group. It will contain my workspace, which is, let's say, machine learning workspace. And the workspace itself, it will contains computes, data, models, and everything. But all of these components and subcomponents will be in the resource group. And now let's just see the cost. And the cost of the resource group, it's really 100% free. But what does that mean, free? So imagine you have created a resource group industrial, for instance, diff. And now this is, let's say, a empty resource group. It won't cost you anything. But now if you start to add other resources in this resource group, you might charge for cost. For instance, here you can see no direct cost for a resource group itself, no limit on number of resource groups. I mean, you can create many resource groups as you want, but I mean, I will try to avoid this because you need to manage all of this, and it will take you much time. And also, no storage fees for metadata. Sometimes you have a metadata for this resource group. It's also free. And the cost benefits, and the cost will be affected by cost tracking. For instance, if you have monitoring spending by project, you will cost some money, budget a lot, and also resource optimization and bulk operations start and stop resource groups. So again, a resource group itself, it's empty and it costs you nothing. And for the resource group, I will show you how to create, let's say, for instance, I have created a resource group. Now it's only, as I said, it's let's say a container. And do I have the permission to add some other resources? For instance, uh, machine le- uh, machine learning workspace, or let's say workspace. Do I have the permission to create a workspace? Do I have the permission to create a storage account? Do I have the permission to create a key vault, and etc.? Sorry. So here we can manage and assign permission to, for instance, team to be able to create resources in this resource group. And as I said, this my big advice for you is to use a naming convention. So try to stick yourself with maybe this is, let's say, then you didn't like it, resource group ML industry diff. You can remove ML, you can remove industrial, you can just specific the project name and etc. So let's now jump to the example. Okay, this is the example, and you can see here, I will try to show you the CLI Version 2 and also Python SDK Version 2, how to create a resource group. And for the resource group, we have to use easy and group and create. As you have seen in this command here, let's start with easy, then the name of the let's say the resource and maybe the resource you would like, and then the action, for instance, create, delete, remove, update, and etc. So I have also created this one here, and let me just show you the account here. So this is now my account. I have one resource group, and this is my subscription. And also, by the way, you can see this is subscription here. You can see you have also top free services by using, and you have many. I have many free resources I can use, and for instance, storage tiered, which is you have somehow a specific storage account. Let me just see how much gigabytes we have. 1 gigabyte, for instance, and here you have 10,000 operations to read and write. And if you would like to see the cost of your spending, let's see, you have to go to the Azure account, then you can go to the subscriptions, and if it's not here, you can see it here, subscription. It will just showing here. If it's not, let's see, in the main portal, and you can here I have this subscription, and the ID here, subscription ID, it's not, let's see, a sensitive, but if you would like, you can hide this, but it's not sensitive. So if someone know your ID, he will not be able to do anything. And you can see here, this is the cost of each resource group. And for the tags, you need also to have tags. So let's see with the Python. So as you can see here, this is in our project, as we have already, let's see, discussed, and I have add this Azure components, and this component I will just give you, let's see, over background of each components, and if you are, let's see, need to, let's see, to react to a resource group or to machine learning, I will give you all the relevant, or let's say most important commands for this specific uh, resource, so it will be easy for you to just came here instead of seeing the website. So I have collected everything here, so it will be easy for you. So let's just go here. This is the we have already seen this naming, and the CLI commands. You have to log in into your account, and let's see, I have already account. I mean, log in, and if I see easy, show easy account. Well, it's easy. I mean, I already log in my account, so because the login it take much time. So if you already log in your account and just type easy account show, it will give you the relevant information for your account. And as you can see here, I have the subscription ID, which is this one here. This is the subscription ID, and this is, let's see, a domain name or my email, and the name and user, etc. So this is just to show you if you already created account. And here's several, let's see, commands, which is CLI commands. So here's how to create a resource group. So easy group resource, and the name of resource group has to be included, also the location. And let's see, let me just now create one. So I will just move it here and see the Python file, because I have added here. So I will just copy this. Let me just explain this. What is this? Here you have easy group, create easy resource group. You need the subscription, you need the name of this resource group, and the location, and where you would like to save this resource group. And it makes, let's see, sense to save it let's see, in any region that will be close to your to you. And maybe because if you'd like to retrieve data, and here as I said, it's adding tags. So tags, it will try to add some information to you, and I'm just guarantee that it will make, let's see, sense when you would like to sorting the resource group. Uh, so let's start copy this and put it in the terminal. And the terminal you can add, open it in any directory. It's not needed, let's say, to have it in this folder or this. I mean, just open it in anything if you would like to use Azure. So let's see, I have this create account, create a resource group, and after a while, it will just create our resource group in this portal here. So we will see if there is no error, it will show us. Yes, you can see here, create resource group with this name and successfully here. So let's have a look. Sometimes you can't see it in the beginning, but what you can see is what you can do is just go to the resource groups here, click, and it will show you here. This is the resource group which is created right now. I think it should give you a time, maybe when it was created, but I don't know where to see this. But yeah, this is the resource group, and here you can see here I have tags. This project industrial and environment and department is machine learning. And if you see here, I click this, and under this tag I have only the resource group. And if I have many others resource, it will be let's see, tagged in this. So let me just go to the other resource. So there are several important, let's see, commands. What are these commands? If you have many resource groups and you would like to see what are the resource group. So let's see here. I have two resource groups. So you can see easy group list. This you can see here, I can just use this easy group, but it will the output will be in a JSON file, which is not let's see, a good for looking. Let's see, and if you would like to use it for the as a table, you can just use O table, and O table, or you can see a double hyphen output. So you can see here I have the resource group and CLI groups, and sometimes you would like to update. Let's say to update the resource group. Maybe you need to update the tags. Maybe you need to remove the tags if you would like to remove the tags. And maybe you would like to export the resource group into a JSON file. What you can show you here, you can see here, this is the resource group. And here you can export this into, let me just go to the resource group. You can export this in a JSON file. So let's see, manage view. Yeah, for instance, open query. But this we can, I mean, if I think we will do it mostly using the CLI commands. So let's see, one important. So this is, you will not use, let's see, all of these commands, but in case you would like to use it, it's OD here. And sometimes, let's see, you need to move this resource group from one subscription to another. So I have this resource group. Everything is created here, and I have the machine learning, storage account, GPUs, and everything. Now I would like to move this resource group from here to another subscriptions. So what you have to do is use this command here. For instance, easy resource move destination, and this is, let's see, the name of the new one. And here you can see add subscription ID resource group, which is what we would like to use. For instance, this one here, and the resource provider, the new one, the resource group type, resource group name, and everything. But I haven't tried in this indeed to move between two different subscriptions. And here you need to also, you can also check if the resource group is there. So what you can do here, oh, anyway, I will just keep it like this. And sometimes when I when I use the using a CLI commands line, CLI, or maybe a DevOps pipeline. So first I will check if the resource group is already there, then try to add many resources. Otherwise it will crash. So that's why we have this command here to check if your your Python it's already there. And let me now move to the Python. And the Python, it's really easy. Let's see, you have to import. First you need to install this Azure management resource, but I have already, if you clone my repo here, so this one here, if you clone this, you will see the toml file here. And what you need to do is just go in Python. Let's see here, this is after cloning everything. And let me just clear. So open a terminal here. And what you have to do, if you just in the first time, you have to do beauty shell. Now you have already activated your Python, let's say, environment. Now the second command you have to do only in the first time, beauty install. So you need to install every package in this toml file here, and this will take much time if you have starting from scratch, because it has to install everything here. And you can see here now my package, it's created, I mean it's updated, and nothing is new. So to run this Python, I will have to use this command here. Let me just copy this, and I will put it inside this after activating this Python. Okay, sorry, so it's wrong. Exit, clear. So let's see, I would like to create the resource group. Let's see if we can create it with the same name. Let's try. So you can see as well, machine learning. Indeed, I have to beauty shell. And sometimes it's not working multiple lines, but I have already prepared this, so you can run this. So now I will try to create my storage account, my resource group with the same name, and we will see if the system will be complain. I don't think so. It will try to see it's already created and nothing is changed. You can see you can create it. Some components you are not allowed to, let's see, to recreate it several times, and this I will show you when it's not needed. And I think I will stop today in this stuff. And please remember that our goal is to have 20 likes, only 20 likes. And if you are not subscribed, subscribe into my channel. And I'm quite sure you will have a good, let's say, journey in this MLOps course. Thanks for watching, and see you next time. Hi everyone, welcome back to my channel. So in the last video we have seen how to create a resource group using CLI and Python SDK version 2. I have shown you what are the main, let's say, commands that could be applied to the resource group. And today we will continue with the workspace. And in the upcoming videos I will try to make all of these components, creating components, interacting between components, and only CI/CD pipeline. So don't worry when we have So I just wanted to be sure that you understand what it is the components. So please stick with this naming, and it's really important. And yeah, can you just make me a favor? So I would like to have for this video only 20 likes. It make me, let's see, happy, and make me to continue recording such videos. So thanks in advance. And yeah, we have seen how to create a resource group, and we have already created this resource group. If you see here, we have created this resource group. Now we would like to create the workspace, and the workspace, we have seen it as we see it, it's a central hub for machine learning operations and experiments. And if you see this figure here, let me just go to this, and you can see the workspace is connected with many components, and these components here in the, for instance, Azure key vault, storage account, Azure container, and monitor. This will be created automatically when we create a workspace. So, and by the way, regarding the cost, creating the workspace itself, it's free, and the cost will be come when you have the compute, when you create, let's say, a PC compute cluster, or maybe Kubernetes, and I will show you how to select the best price for you. And also the storage account, it costs you 0.052 dollars per gigabyte for every month. And to create, let's say, a resource group, I mean a workspace, sorry, I'm mixing between these. You have to have the name of the resource group, of the workspace, the name of the workspace you would like to create this workspace in or on, and also the location of the workspace have to be also identical to the location of the resource group. And you can see here the storage account and key vault, and some parameters. There are many several parameters I will show you now, and some parameters are needed, or let's say required, and some others not. So let's see here. So create account, I mean create a workspace. It has several parameters, and as you can see, only these three here are let's see required. You need to have a name, you need to have a resource group, you need to have a region, and for the other one are automatic, I mean not needed. But as you can see here, for instance, storage account, key vault, and container account will be created automatically, even when you see when you haven't let's see, sorry, provide the names, and we will see now. And to have to create a workspace, you need to have CLI. For the CLI, you need to download this extension. Hopefully, you already followed from the setup tutorial, and you need to have to log into your account, create a workspace, to create a resource group. This we have done last time. As you can see, we have, this is our resource group. Now we have this command here. We need to create our resource, our workspace, and let's have a look how to create this. We can clear this, and I will just try to create this. And as you can see, when we create this, it will try to create it inside this resource group. Okay, let's have a look, guys. Here you can see it's already created, and I will show you now what we have. We can see here, this is our resource group, and you can see we will need to create some many resources, but let's just focus on this. I will just remove this, and I will tell you what I got when I have from error. But let me just, I will do it now. So this is the new components here. So let me just, this is our components that created when we have created a workspace. You can see this is our workspace here, and these other components have been created additionally with when we create the workspace. And if you go here, you can see now the workspace. Let's see all resources. Not yet. Sometimes it's need to make so refresh. So is our Azure Machine Learning, or you can try here to see Machine Learning. If it's not in your stuff, you can just see it here, and you will see the workspace here. And this is our workspace now. And to launch a video, to launch a studio, not a video. And let's see just what is inside. Already inside this is already explained in this videos. So in the next time, in the upcoming videos, we will see how to create a storage account, connect, upload the data, and creating a compute, Kubernetes, and everything. And finally, I will try to build a whole project with CI/CD pipeline. And there are several commands which is somehow sometimes you need to delete the not this command I have updated. So sometimes you need to show maybe the list of the resource group, and let's see, have a look if we can. The name was just changed, and I will just give you one moment. I will give you one hint. Sometimes it will get trouble with this, but I will show you how to fix this. But let's see. So try and always on a table, to show this on table, because the JSON file is not readable indeed. So you can see the name with the name and the application inside, the display name, but it's not now organized. But anyway, this is how to create a resource group, workspace, and some other commands. Let's see, you need to list all the resource group in your stuff in your PC. You need to update maybe the tags and the description and everything, and you might need also to delete this resource group. And by the way, if you now try to delete this resource group, where's the resource, our resource group? Yeah, you can see now machine learning workspace is here. So now if I delete this delete this resource group, everything inside this resource group will be deleted. So 999 components will be deleted. I mean, all of these will be deleted. So be careful to this. And if you would like to delete a resource, only a resource, from this you can just see select and delete this resource from here. Okay. Okay, so I think this is all the clear. Yeah, by the way, regarding the Python, I will just it should work. I have tried it several times. And one hint, please. So sometimes, let's see, I have created this resource group, right? And let me just do it again. Uh, Let me delete this and try to show you again, because it's really helpful. Or maybe deleting it takes much time in my PC, so I will just give it you as a info. So sometimes you have created a resource group, and now if you delete this, it will not be, let's see, deleted if from the PC right now. So permanently, please, it will be in a soft delete, and to delete it, you have to go to recently delete and select the description, the location. Let's see, OSA, and you can see there's no group. So if you have any groups, let's see, in this, and the deleted, you can just have to either to recover or permanently delete. So this is the one hint that might be needed for you, and you need also to have it as the admin here. Okay, so I think that's it for today, and please subscribe and like. I just need only 12 likes. Thanks for watching, and see you next time. Everyone, welcome back to my channel. So last video is we have seen how to create a resource group and workspace, and now we need to see how to create a storage account. Someone will ask why I need to create a storage account while it's already created when I create, let's say, the the workspace. And let me just show you here when I see the all resources in this resource group, and you can see here this is the storage account. You can see here storage account is already created. And why we need to create another one? Maybe it's just for somehow for organizing, and I don't like, let's say, this name here. just adding letters, and now I need to do my stuff. So why we need indeed the storage account? The storage account is needed to store the data set, the experiments, models, and also data versioning. And it's really needed. I mean, of course, without any data, it's not possible to train any model. Now, in the regarding the cost, which is I think really important for you, I don't want to let's say to maybe to spend much money in this. So that's why I have added in each section I have added the cost. And if you see here, and there are three different categories for this for the storage account. There are hot tier, cold tier, and archive tier. And the hot one is, I mean, just if you see here, if you have 100 gigabytes, it's almost you have to pay. If you save your data in this section here, in this hot tea, you will spend you mean you'll about $2, which is I think it's nothing, but it depends on indeed in you. But if you are really working with the industry and projects, I mean, don't care about the cost. Everything will be covered by the company. But this is only for if you follow this course. So try to use whatever it's perfect for you. And because in the next sections we will try to see how to create a blob containers, and also uploading not only files like iris dataset or something. We will try to upload real data sets, and the storage account you can store sensor data, vision data, and also production logs, and also trained model. And we will see how to create this in a CLI Vision 2 and also Python. And you can see here I already provided this commands here, and for each component I have added this uh, presentation, which is already added in the GitHub, I think, of yesterday. I think I have uploaded everything. Let's see. You can find it here in Azure Components. So now why I'm doing this? So the project itself, the goal of this project is to make everything automation, CI/CD pipeline. But the CI/CD pipeline is the component of the CI/CD pipeline is these Azure components. And if you don't know what are these components and how to create, how to handle, how to, let's see, delete, remove, maybe update, so it won't make any sense. That's why I'm just trying to give you a short introduction to this, how to deal with the storage, I mean the components. So now you can see here I have this commands here. You have to be logged in in your account. Of course, you have to have a resource group that we have created in the last videos. And now to create a blob storage account, you have to see it will be this. But let me just show you here. You have to see this it's a blob storage, and here this is the access tier. It's hot. So in your case, you can change it to let's see. Let me just show you how to go to the commands. Indeed, go to the general, let's see, environment. Let's see here. We can see how to create. Now you can see here all of these, the parameters. You have many parameters, but these are only the required. I mean, I'm just giving you the required one. And here you can see access T. It's cold, cool, hot, and premium. And I'm using this one here. And if you would like to save, let's see, some cost, you have to use cool or cold. And as we have seen in this, it's hot, cool, and archive. Cold, it's archive. And most of these I will say might be needed, but maybe for instance this one here it's a blob storage, block, file storage, and storage version 2. And everything here it's me I will say it's really explained. Where's the third one? This one here. Which let's see standard safe, let's say BC, standard CFEs. So you can see each parameters is really explained here. And for instance, you can see require for storage account, we kind blob storage. The access is used for billing, and premium access to is a default value. I mean, yeah, the default value is premium, and you have to use, let's see, whatever you want, indeed. And here also there's a command line how to create. So hopefully this is clear, and let's go started to create our storage account. So I will just copy this command. I'll put it here. Nice. Uh, DevOps, it's not create. Resource group name, it's wrong. So let's see. This is the resource group. Sorry. So I have changed the name of my resource group. As you can see here, this is my resource group. And I will just hit enter, and you will see. When it's creating, I will show you some properties of the storage account, because the storage account, it's, let's see, really protected and high security, and you cannot, let's see, create any containers or upload the data unless you have the key. And I will show you how to get the keys, maybe today, or maybe if when we create the container account. Let me see bar. Storage account. Right. See, we have our storage account here. Now let me just move this. This is the property of the storage account. And here you have the keys and also the containers. And the containers here, it's I will, let's see, just consider for sake of simplicity. The storage account is like your hard drive, and the containers is like any folder. Let's see, industrial, for instance, PaDiM or anomaly detection. And each key, I mean, each storage account has a keys. So to upload something into the containers here, you have to have uh, these keys here. And I will show you next time how to use these keys either in CLI or Python. And regarding the Python, I will not, let's say, because I have already tested this. Everything is tested. So already also uploaded here. So you can see storage account presentation and storage account create. And with this information here, you will be able to create. So why this is not storage account? So the storage account with SDK. Yeah, we need to add the storage account. Okay, so let me just add this. How to do add this? Let's see. Is this storage account? Also, the name is false. Storage account. Now, what's wrong now? Okay, so just copy this, and if you are not sure, let's see what you have to do. Just go to the Google here. It's easy. So, but I can just show you how to download this. For instance, you have to add this here. But how do we add our stuff here? So just copy the name, go to your project, the Python code, and here you need to add, as you can see here, in the TOML file, we have no this file here. But what you have to do is beauty add and then storage account. I mean storage management storage. So this will try to add our stuff. I mean the libraries into this file here, and we will see in a moment, because I'm using different environments. That's why it's not installed here. But you can see here it's here. But for, let's see, for more organization, I will just put it in here. So st key pages. Now, if you see now, I can run just with debug, just to show you how to do things. I'll just see it's now should create the resource group, and I will not create this with Python. Try it yourself if you would like to do it. And you can see here, for instance, with the storage account create, begin create, this one. Let's just see what are the parameters. So you can see what is the resource group. It's resource group, but it's not here. I have to upload it here, to update it here. And also the account name, the storage account is industrial storage, and the parameters, it's, let's say, standard global storage, and etc. So yeah, maybe this one also need to be updated, and the resource group, this is our resource group. We have just to update. So I want just to make your life easier. So you can add it here in the resource group, and also you can run this, of course, as a parameterized. So I think you know this. If you just write Python and add each parameter here. So yeah, that's it. I think for today it's enough, I will see. And for this, I mean, try to keep the naming is consistent, and also if you'd like to use Python or CLI, this is up to you. And if you have any question, please write it down in the comment below. If you have any question in the previous videos, so because we are now, it's our stuff, it's accumulated. If you have done the previous one, you will kind of continue with our with the next, with this, for instance, tutorials. That's it, and thanks for watching, and see you next time. Hi everyone, welcome back to my channel. So, as we have seen, in the last video we have created the storage account, and the storage account is, for sake of simplicity, it's like your hard disk, and the containers or blob container, it's just considered as a folder, and the folder, let's say, is contain the files, images, and etc. So in today's video we will see how to create containers, and also how to create and how to upload files and maybe images and etc. So let me just show you this one here. So here we have created our storage account. Back to the storage account, and if we would like to create containers, we have to do it either manually, but or maybe not, or maybe, or CLI or Python. So we will just use CLI and Python, not the one, because it's need some, let's see, keys. And by the way, to use this, the files in the containers, we have to connect the containers with this access keys. And to have this access key, you have to copy this, or either you have to add, let's say, a CLI command to show or to give you the key. So let me just show you here. So I will just go to this file, I mean to this file, and copy the storage account key. So now I need the storage account key. Okay, yeah, I got it. So this in the command in the PowerShell we have to add for the variables we have to add this $sign. And as you can see, this is my key, and this has to be supposed to be a secret, but I will delete it after this recording. So try to keep your stuff secret. Anything in the Azure account has like a password like this, you have to keep it secret. And for instance, let me just show you some stuff here. For instance, my account, and you can see this is the ID account. I mean subscription ID. It's not hidden. Just but better to have it as a secret. But it's not needed to have. So if you know my subscription ID will not do can't do anything. Okay, so let's go to this one here. Now we need to create containers. So let's see, copy this, and you can see it has a container name, account name. Let me just change this here before I forgot the $sign. So yeah, so here the container, it has a name of the storage account. So we have a storage account. Now we need to create a container in this, for instance, storage account. And this is a container name. This is the key of the storage account, and the public key is off. So because it should be private only for me. So let's see here, create, not create, but copy, and let me just paste it here. Now this should create a storage account. Okay, so I already created the container, and we will see here we have now this is containers. Now there's two different steps. Either if you have only a file, only one file, or maybe sometimes you have multiple files. So in our case, I will try to upload several files here. So this is my destination. I will have used storage blob upload batch. So you can see the difference here is upload, and here's upload batch, which is upload several files. And the destination should be the container that I already created here, and the source file, the source of the files is the good, because you have to define for instance, I need to upload these images here, which will be used for the training. And you can see of course I will give you these files, or you can download it from the GitHub, from the GitHub or from the website. So I will give you the link, but when we just reach uh, the anomaly detection. But this is now how to just show you how to upload multiple files. And you can see here I have the account key, which is getting from this command here. And the buttons, I need to only upload PNG images, PNG files. And if there are any files, for instance, JPEG, PDF, Words, Excel, and everything, this will be excluded. I need only a PNG. And this is override if you would like to remove, or let's say override the already exist, if it's exist. And here you have also the tags. So let's see, just copy this. Sometimes the tags are not working, but let me try. So the idea now is to upload. See, I'm now, let me just cancel this. See, if you see now, I'm in the directory of the images. So if I see, I have the good file is here, and if I see ls good, it will show me the images. So you have to go to the directory with cd and blah blah blah. I think you know this stuff. And now I need to paste. You can see I need the source code, the source folder, which is good, which is inside this folder here. Okay, and inside the folders I have the PNG images. So let's try. Okay, yeah, as expected. Blob tags are not only supported in VS V2 storage. So what you have to do is remove this tags. So if you would like to use tags, you have to use the storage account V2. So let me just storage. Now let's see. This will upload our images into the website. I mean into the, as you can see here, this is a progress bar. And if I check now, I have these images. These images will be used for the training of our anomaly detection. So it depends on my internet, so it's fine to upload 200 images, which is in my PC it's not that huge. Let's see the size of this folder. The whole folder was yeah 110 gigabytes. Now everything is uploaded. Now we will see now next time how to create a data set from these containers, and maybe let's see. Not sure if this is yeah. Okay. So yeah, I will try to do it. How to use it in, or maybe just to keep the cost. Let's say little, or let's say ignore some cost. I will try to create a data set once we try to let's say start with training and inference time, inference phases. So and next time we will see how to create this stuff. And yeah, if you are liking my videos, please subscribe into my channel, like the videos, and of course if you have any question, just drop it down in the comment below. Thanks for watching and see you next time. Welcome back to my channel. In the last video, I showed you how to create a storage account and upload some images into the Azure ML. So today, if you are, let's say, focusing on cost and try to reduce the cost, please watch me till the end. I will give you some hints how to save money and to avoid, let's say, this big amount of charging. So, as I have said, it's a storage account. I have uploaded some images, and I will recommend you now is if you follow the last video, please make sure that you delete the storage account, because if you stay and watching till the end of this series, you will be charging for monies. So my idea is that I will just try to show you. I'm just trying to show you these, and because it will take some times just to finish the project, so make sure that you will delete the storage account and also the images. So once we have the end-to-end pipeline, I mean, we will do it in the next video to show you how to do all of these automatically in Azure DevOps pipelines. And for the Azure key fault, I will also create it because we have already one when we create the workspace, and also the cost is about 5 to 15 dollars a month. So I will try to skip this because I would like also to save your money and also my money. So this we will create it when we need this in the upcoming videos, and also for the insight, the application insight is already created, but I will show you. I mean, when I get in the full automated pipeline for the Azure container registry, because I haven't trained the model, and the registry indeed for each Azure it costs €5 a month, and they have you have, let's say, point oh 10 gigabytes per month. So if you have, let's say, 10 gigabytes, you will have to pay $1 a month. But this is only a hint. So I will try when I train the model. I will show you how to create the Azure container and how to use it. Also, how to create also the container itself, the code of the container, the Docker, and also after that we can register our Docker into the container registry. So for the GPUs as well, it's not needed, let's see, to have it right now, because creating this, it will cost you a lot of money. So I will not do it right now. But if you are working in a company and you'd like to let's say to investigate something, because the company will pay, or if you have a free version, so you can try to apply this commands. But make sure that sometimes the free version has some services are not free. So make sure that, for instance, as a container, it's not free, and Kubernetes, I think Kubernetes, yeah, and for the GPU, and also for the Kubernetes and plus ML extension, we will try to install we will try to create a Kubernetes cluster, and plus adding the ML extension in this cluster. But as I said, you have seen this is the cost a lot of money, and I would like to avoid this right now. So once we have the after the training our model, I will try to create a Kubernetes cluster. Then we can, let's see, save money, and I think this make sense. And there's also some cost optimization. For instance, sometimes there's some this one here. It's sports. So sometimes there's some offers. Uh, you have to, let's see where's the offers, and also sometimes for the second option you have to take, for instance, if you have created a cluster and try to make auto shutdown. If the PC is, let's say, idle, we have to shut down this PC to avoid charging. And this I will show you how to do so in the when we start with really implementing everything from scratch. And for the third option is to, when you reserved let's say a PC for 1 or 3 years, you will have somehow some discounts. So this, please, I would like to avoid this stuff, to upload, to create Azure, I mean Kubernetes, Docker containers, and everything, because this costs you much time and also me as well. So I will try to avoid this, and next time I will try to start with the DevOps pipeline. I will try to show you how to do all of this in a pipeline, and everything will be, let's see, end to end. And as I said, my goal is to teach you everything here, but also in the same time, I would like to save the money as well. That's it for today. And if you like the video, please subscribe into my channel, like the video, and if you have any questions, just drop it down in the comment below. Thanks for watching, and see you next time. Back to my channel. So as we have agreed that we will use a real, let's see, project, or let's see, industrial project in our MLOps. So what we already agreed that we can use anomaly detection. So today we are diving into PaDiM, which is it's a batch distribution modeling for anomaly detection. So imagine you have a system that can spot the tiny, let's see, defects, and faster than a human inspector. And that's exactly what PaDiM delivers. So PaDiM, it's, as I said, stands for batch distribution modeling, and it's not, let's see, uh, another AI buzzword. It's just a game changer for framework that combine the power of deep learning with practical industrial needs. And I think most of the companies are using this algorithm. And whether you are in a manufacture, quality control, or surveillance, this presentation will show you how the PaDiM is setting new standards in anomaly detection. Let's explore. Let's see how it's working. So let's start with the basic stuff. What exactly is anomaly detection, and why should we care about this? And as you can see in the anomaly, you are running, let's just as example, you are running a factory producing thousands of components every day. So among of these thousands, maybe just one to have defects. And how to find these defects? Finding these defects, maybe anomaly could work, right? But finding this anomaly manually, it's a time consuming, expensive, and also it's prone to human error. Why? So sometimes when you have, this is my experience, when I have a defect, I'm just seeing a defect, right? But also my colleagues have see some, it's not a defect. And he has some, let's say some argues, and they have some argues. And when you see, it's hard for a human even to recognize the defects because it's working with so PaDiM is working with pixels, and it's really impressive, and I recommend you to indeed to use it. So anomaly detection is this, I would say, is a superhero solution for such problem, and it's a process automatically to identify patterns that that didn't let's say doesn't belong to a good behavior. So as you can see here, so for instance, you have this behavior here, and here suddenly you have this behavior in this point here, and so you see, I mean, just you can recognize that, yeah, it's here something is not normal. Maybe something is happening here. So regarding the images, we have to detect, let's say, the pixels. If the pixels have, let's say, a different behavior from what we already, let's say, trained. So in the industrial setting, the technology is absolutely, let's see, crucial. It means the difference between two images, let's see, or two products is really making a difference. Imagine you have a building. I don't know, maybe a medicine, or maybe this pills of medicines, and you have to have to make sure that everything is covered correctly, and no defects in this, no scratches, and sometimes in industrial, let's see, an automotive, for instance, BMW, they need to make sure that the car's pens has no defects, and everything is consistently and without any defects, let's see. And there are, let's say, some key challenges here. Why? See, some guys will say, I can detect anomaly with supervised learning, but supervised learning, here we have one problem here: rare anomalies. So you don't have two classes. Of course, you have two classes, but the anomaly images, you will not have it as the normal images. So the normal images, you will have 10,000s of images, but the anomalies will be 10 or 20, which is imbalancing, which doesn't make any sense to use uh, supervised. And the second one is here, unexpected patterns. Sometimes you have a defect here, sometimes you have a defect in this point, sometimes you have a defect in this point, and it's unexpected patterns, and it's not, let's say, easy to see. Here I have a defect. This one is the defect. So it's not easy for even for a human, and it's also one class learning. So you have only one class learning, and also real-time processing. You need something really fast. And I will show you. I have optimized algorithm to run in a 5 milliseconds on a GPU, and maybe 50 millisecond in a CPU. I will show you all this, and also show you optimization. And let's see here, there are some limitation of the existing methods. Somehow there are several methods that try to detect the defects, or let's say the anomaly. And for instance, this autoencoder and gangs, it was working. I have tried also this one, but what is the problem with autoencoder? You have to, if you have many images, if you have new images, you have to retrain the network of the autoencoder, which this somehow takes, sometimes it takes a days to just to get the model. And then the second problem that I have seen, I have, let's see, faced, it was the generalized. So sometimes it's even the error, the defected images. When you try to reconstruct the defected images, it will try to see, this is fine. It's so that's why it's autoencoder is generalized method, and the embedding similarity with KNN and SPIDA. So this is also one of the anomaly detection algorithm. And the problem here is that if you have a big data set, and let's say, for instance, if you use KNN, and you have one image, and you have 10,000 images, just for sake of simplicity. And to calculate the KNN, you have to calculate the distance between this image against the 10,000 images, which is time complexity. And it's really, I mean, it's not needed indeed, and this is somehow the limitation of the existing algorithms. And let's see here, we need somehow a good solution, which is the PaDiM. And the PaDiM, it's let's see, use the pre-trained CNN, extract the features from the from the images from the several layers. I will show you in a moment, and use these features to uh, calculate the Gaussian distribution for each pattern, for each position, and then in the inference we will calculate the distance from the model itself, from the Gaussian distribution, against the image features, not as a KNN. And here we can see we have calculate, if we have a pre-trained CNN image, CNN, let's see ResNet. And for the ResNet, we have, let's see, 3 or 4 layers. And we can extract these layers, and here we can see, we can, let's see, guarantee that there's a semantic correlation between these features, and which should be a good for the localization. And as you can see here, it's, let's see, oh, so here, for instance, let me just when it's this one and one, we have the extracting these features from the trained model from different layers, and we have concatenated or embedding these vectors, and then added to the to the Gaussian distribution. And you can see here, this is vector concatenation, and then embedding collection. Then the next step is to use the the building the Gaussian distribution. And for the Gaussian distribution, you will need to have the mean and covariance metrics. For example, in the training, it will be, let's see, it will take much time, but I have improved the time of the training, and also for the testing, for the inference. And for the training, I have, let's see, 200 images, just as example. 200 images, it will take only less than 500 millisecond, or let's see, 1 minute. Regarding related to the training, it's not that matter. So the most important one is the inference. But although it save you time if you have, let's see, some issues, or so that maybe you need to add some images. The training process will take, let's see, I will just say roughly 1 minute. And for the anomaly detection, we will calculate, we extract the same features from the test image, and calculate the distance with Mahalanobis distance. And this Mahalanobis distance, it's not like KNN. It's calculating the distance from this point to g- uh, the to the for the Gaussian distribution. And it's really I also improved this much, and it was working perfectly fine. And what is the advantage of the PaDiM? Of course, there are several algorithms, and also several improvements of this, of PaDiM. And why I like this PaDiM? Because I don't need the, let's say, the defected image during the training. So I need only one types of images, which is okay. And I don't need, let's see, thousands of images. If you have only 100 image, 100 to 300 images, this will be more than enough. And time complexity is one. It depends indeed in the image size. And of course, I will show you now the data set. Before the dataset, let's say we are using MVTech dataset, which has 15 class, and each class has 240. And imagine if you can build a model and real model for inspection with only 240 images, this will be a great, let's see, impact in your, let's see, industry. And you can see sometimes you will get for such a data set, you will have AROC, I mean AROC 99%. And one disadvantage of this, I will say, is that sometimes, let's say you have new images, let's say for the, I'm not quite sure, maybe like just as example, transistors. But if we would like to use a ResNet, the ResNet itself hasn't seen any images like this. So maybe the features will be sensitive or maybe not okay. But for such, I mean, tried different data set, but it was working. But in case in your data set it's not working, you have to, let's see, build a model or train a ResNet on your data set to build a model, and just try to collect any different from different data sets, and this should work. And now let me just show you the data set. So this is the data set, and you can see here this is the 15, 1 2 3 4 5 6. Yeah, and you can see this is the objects, let's see, the inspection that it's used for this. And if you see now the PaDiM implementation, the original implementation, it was really slow. And I have also taken some codes from different repos and have also worked on this and optimized it. And I will show you next time, because this is really important, at least for this project, because we will use MLOps and Kubernetes and everything. We will use this to train our model, our PaDiM on the cloud Azure ML, and then we will try to making the inference and see the other pipelines. That's it for today, and thanks for watching. If you like this video, please subscribe into my channel, like the video, and also if you have any question, just comment, drop the question in the comment below. Thanks for watching, and see you next time. Welcome back to my channel. So in the last video, I have showed you, or let's say share with you the theoretical part of the anomaly detection. So I'm super excited here to share some, let's see, awesome update in my project AnomaVision, which is indeed, it's let's see, optimized and extended from this repo here. As you can see here, this is the one I have cloned, I have updated and optimized the algorithm. So if you would like to, let's say, to make a comparison between this and this, please do it. And the AnomaVision, it's, let's see, I have seen it as a powerful deep learning library built on this thing, make visual anomaly detection fast, super easy, and ready to use in the real world. So if you have, let's see, if you are working with anomaly detection, you can use this and deploy it in a very easy way. And this is the one that we will use in our project MLOps. So as I have promised, we will use a real project, I mean real time project, let's see. And sorry, and what are the, let's see, the features I have, what I have done here. It's lighting, fast, and memory efficient. So I have, if you run this and try to compare between this and this, and I'm quite sure it will save you up 60% of the memory and also in a post-hit speed. So the result will be quicker and in any hardware. I have tested in a CPU and also in a only GPU. I mean, I have no GPU here and but in a Google Colab. But yeah, by the way, and when we let's say create our MLOps pipeline, we will try to use CPU because it. I will just show you in a minute how it's really fasting in when I train the MA when I train it on my PC on a CPU, and also the inference will be on a CPU. I will show you the result, I mean the time. And also what I have done, which is really important, which is seamless or ONNX deployment. So you can see now is this repo here, it's supported ONNX, which is of course you know what is the ONNX, and it's really fast in the inference time. And also I have mixed precision magic, so you can it support floating point 1632 automatically. It just depends on CPU and also GPU and flexible, then the flexible modular. So I have uh, if you see here in this Anomaly text, I have just keep the same name. So you can see here, this is the feature extraction, this is the Mahlanobian distance calculation, and this is the algorithm. And I have just, let's say, refactoring the code somehow. And yeah, by the way, regarding the PaDiM here, and you can see in the evaluation, in the evaluate, I have one for memory efficient function for one memory if you have a big data set that you would like to evaluate on, and the one with fast, let's see, optimized memory. Let me just go back. And it's also, I will say, a zero frustration integration, so it's super easy to use. Just if you follow only this the following steps, you will do it free I mean without any issues. So how it's easy, so check this out: load your dataset, train the model, and just with a few lines of code export it to ONNX. Also try to run the ONNX, or if you would like to run the PyTorch model and predict the anomalies. Done. So this is, for instance, just examples. And you can see here, just clone this repo, go to this directory here, and run this command in in this directory, either with Visual Studio Code, or maybe if you would like to PowerShell, to use PowerShell. And here you can see here, this is our dataset. How to load the dataset. This is loading the data set, just path to the data, the good, only the good data. And here's this data loader device initializing the algorithm, and here training, and here they export the model. And here you can, for instance, do the prediction. I will show you in a minute how to run. And this is if you would like to use a CLI command. So you can see Python and just put the data set, the model path, let's see the directory you would like to save the results, which is normally is a distribution. But if you would like, you can just change it. And here's the backbone. You will use the backbone ResNet 18 or 19 or 15. And also there's another one, I will add it by the way, if you would like to contribute in this repo, please do it. And here's number, the features will be extracted from the layers. Sorry. And number of features we will, let's say, will be used to training the model, which is taken randomly. In the paper they said they have used principal component analysis for the feature reduction, that randomness was more efficient. And here's the patch size you would like, this is for the training, and also this is the model name you would like to name the model. And you can see here's the help. This is the project structure, so it's like any project. And here's the powerful, let's say, API. If you would like to use the PaDiM, it's just use this comma, this lines here. For the training you can use this. For the inference, you need to use model.predict with the batch size, and also if you would like to use Gaussian blurring or not, it's the default is true. And this is the exporting to ONNX model. And here's the magic key, the performance between the original one, which is this one here, and here. The memory usage is really high, and with AnomaVision is low. And the training speed baseline, and here the faster. Inference is really fast, and also you can see the difference when you use a GPU with a big data set. So you'll see it will save a lot of space, I mean a lot of memory, and also it will give you a very fast I mean inference time. And as I said, if you would like to contribute, please fork the repo, I mean, create a branch, commit, push, and of course, open a pull request, and I will see it and run it on my PC. Of course, it's need, let's see, some works indeed, but this will we use in our uh, MLOps. So as if you see here, this is our repos, and this our repo, for instance, for industrial anomaly detection MLOps. So this is our, let's see, main repo. So now we have two repos here, this and this. I will try to find a better way how to maybe to use a sub module in this one, or maybe subgraph, subtree, and I will see. I will do the best. And you don't care about this. I will do everything for you, and you just need to uh, clone any, for instance, this one here, and the anomaly detection will be here included. And the source will be, for instance, the training will be here. The code for the training will be here, and everything will be, let's see, easy for you. And let me just show you here what I see here. So, for instance, this is the PaDiM, and you can see here. Let me just go up and clear the output. Here you need to import training. Just add the data set, let's say that directory to your data set, only the battle. And by the way, you have to download data set from here, from this link here, and try to use, for instance, any class. So in my case, I have been using battle. And for the data loading data set, you have to load the data set, only a good data set. Batch size for the training is 2 because I am using a CPU, and the model building, I mean, initializing the model, I'm using ResNet. Layers, number of features, I just need in the layer 0. Let's see, the layer 1. This is the fit, and here's the saving the result, saving the model on this directory here. And here I'm doing the inference. I will show you in a minute how to do the inference. And for the make prediction, for the making the prediction, you can just use this for the classification. I mean, you need to make a classification for the pixels and also for the image to get the heat map. And the next important one, it's of course this is not relevant anymore. I will have to cut this because I have already evaluation here. So if you would like to evaluate the system itself, you can use eval function, eval file. So let me just go back, and of course this will be also deleted. And here is interesting stuff. You need to export the model, the PyTorch model, into ONNX, and this should work perfectly. And if you see here, I'm just trying to test the same dataset, the same test dataset, for instance, with the ONNX and also PyTorch, and you can see the same result. And this one is for, we will do this MLflow in our let's see, training in a pipeline. So let me just start now, and I'll just move, just jump to the training, and you can see the training itself. Let's see. You can see this is in my CPU. And for the training, we can use also a CPU, because a GPU it's costs much money. But I will show you also how to create a CPU and also use a GPU. This is also in a, if you see in a main file here, if you see, you have a dataset backbone, the the device. Okay, the device is detected automatically. And you can see now, let's see, just jump to the result. Yeah, by the way, see, I just have to had the to, let's see, predict several times on the same data set, and I have, say, for instance, 5 images with this size here. It took let's see, 400 millisecond, and which is it's really fast on a CPU and on a patch size. And let's see, for instance, you can see this is the image score with the PyTorch model. And if we see now, just keep this, just try to not to memorize it, but have a look, and we will see now this is the result of the image. So you can see this is a defected area here. It was selected exactly, and let me just go to the by ONNX, and I can show you. Okay, there's an error here because I have deleted the file. I have deleted the function of the pre-processing. Guys, sorry for this. It was changing this. I changed the dataset path uh, in the in one cell. I will just show you when. And this was a mistake because the images was not found. So I changed the data path to this, which is let's see, make our problems. So let me just go to the detect and do again this one here for the school. We can see this is, we have still have the same result. And for the ONNX, we have to run this, and you can see still have the same result. But of course, it's, let's see, not the same. Let's see, just copy this just to make sure. It's not, let's see, the same exactly with the same digits, but you can see here it's 3, just maybe to this point here. It's maybe 3 or 4 digits after the comma. So exactly it's the same ONNX and the PyTorch model. It are exactly the same. So now you have this file here just to make somehow play in this file here, Jupyter Notebook. And if you would like, if you are serious, just you can use this one here by running the. If you are in the same in this environment, let me just activate the environment. You can either activating the environment, or you can just use Putri run, then Python, for instance, main. Or if you would like to evaluate, eval. So the eval, let me just give you a hint. It's loading the dataset, and the dataset will be, let me just show you the structure of the dataset. This is the structure of the dataset, and you can see I have the training, which I use for the training, which is only a good images. Then let's move to the ground truth, which is for the defected area. Let me open, for instance, one, and you can see this is a mask of each defected images. And if we go on test, on test, you can see the class large, for instance, large defect. You can see this, and the mask it was in the ground truth. Now for the evaluation, you have to have the same exactly format: train, test, and ground truth. Test, for instance, you have to have one at least one defected area and also a good area, so just to make it comparable. And here you have the ground truth. For the good, we have no ground truth, so the mask will be black. Everything will be black. I mean, there's no white area here. And yeah, let me just go here. And to run this, for instance, you can see I have added two different methods, which might be, let's see, uh, if you have a big data set, you can use evaluate memory efficiency. And let me just see, run this one here and see the matrix, or let's see the evaluation matrices on this data set. I have, let's say, 83 images, which is defected and non-defected. And here's the progress bar, and it took 9 seconds. Okay, I just comment this line, which is indeed important to show us the evaluation matrix. And yeah, let's back to this, and you can see here, try to clone this if you would like, indeed, if you'd like to use anomaly detection and improve anomaly detection. So this is the result, and let's see here. You can see time, and this is the image level, and this is the no, this I have to close this. Still one, no. And this is the pixel level, you can see. And also it will give you a different result based on your data set. But if you would like to use it, try to use it. And this is the one we will use in our MLOps pipeline. Okay, then if you like this video, if you found this helpful, please subscribe into my channel, like the video, and if you have any question, please write it down in the comment below. And by the way, if you like this repo here, please maybe give it as a start. I will start now. It's fine. And if you have also would like to contribute, follow this, and I will get, let's see, a notification. If you have any question, drop let's see, in a this is my email, so you can use it if you would like to send email. That's it for today, and thanks for watching, and see you next time. Hi everyone, welcome back to my channel. So in last video we see how we have two repos, AnomaVision, which is the anomaly detection algorithm, and the industrial anomaly detection MLOps, which will be let's say running in the cloud itself, in the Azure DevOps and also ML portal. And but now we have the repos here, but we need to make it, let's see, duplicated here, or with any way we'd like to make it accessible in this DevOps. By the way, we can also work with the when we create a pipelines, we can work directly with the GitHub. But I would like to make it, let's see, safe and secret. So I would like to make a copy, or let's see, a remote. I will set a URL to this at origin from this repo here, and could be accessible in this directory here. So what I have to do in the beginning, I have to, let's see, for instance, just selecting this name. I need to create a repo with the same name, only empty repo. Let's see, create a repo, new repo, and we can see AnomaVision, remove this readme, add, and you can see now it's empty. And you should copy this URL, but I will just show you now in a moment. So if you see now, I'm in the my local directory where the AnomaVision, which is the repo of the GitHub, this one here, the original. Now I need to add all of these in the DevOps repo. So what I can do is first should see what are the remotes in this one, and you can see the remotes are the deep knowledge AnomaVision.get. And if you see which origin, and of course it should be the one that is GitHub. You can see GitHub. Now I need to make a remote, add remote to this, and you can see just copy and paste it here. Now if I am just adding another remote to this repo here. So if I see now just git remote, you can see I have the I have two remotes, remotes. Yeah. Now I need to push. Let me just see. I have here this, and what are the main, which is the main branch. So I need now to make this push into the git to the DevOps. And if you see here, I just add git remote add DevOps, and it's the other way around. If you have your repo in a DevOps and you'd like to make a remote from to the GitHub, you can see git remote add GitHub and your directory and your URL. Now let me just see this. I need to push these changes, and I will try to see if this will be pushed to the Git. Let me refresh. Wow, you can see now we have everything is in here, and also including every commit I have done. So this will save you much time. If you would like, let's see, to make another one. So in the other one, in the other repo, I will just go to here. The same way, just I just need the name. Just copy the name, add another repo from here. Just add new repo, call it with this name, remove the add or uncheck. And now you need also this URL, but I have already copied this. So it's the same, you just have to see, just let me just see what are inside this repo here. So let me just clear cd one directory above, now cd industrial MLOps. Now I need to see what are the origins and remotes, and so you can see the remote is only the GitHub, and it's also only a GitHub indeed. And now I need to add this origin here. So I have to add this remote. So what you can do is I just forgot, maybe I have seen that. Just copy this, and in here you just replace it with the with the URL here, just like this. And now you will add a remote to this repo here, and now you can see, if you see now the git branches remote, and you can see here I have it, the DevOps and also the GitHub. Now I will push the changes in this main directory, in this main, and as you can see here, so please make sure that in this branch I have its main branch. If it's master branch, we have to change this also to master branch, this one here. But here it's main. I will just copy and paste. Now it will make a copy, or let's see, a remote to this. And you can see here I have push to DevOps, and if it's the other way around, it's a GitHub, so you can just change it to GitHub. Now you can see I have these. It's including everything here, so it will be easy for us, let's say, to work with the pipelines. And another the next step is we have to do is that if we would like indeed. So now we have this, we have these two, let's see, not duplicated. Let's see that not duplicated. I would say no, it's not duplicated. But when I update something here, I have to reflect it to this directly. If you want, you can create this pipeline. you have to you have to add this pipeline into the DevOps. And this, when we have, let's say, some any changes, some changes, it will be directly, you can see here, add remote GitHub, and then it will be push directly to the main branch. And I think that's it for today. And if you like the video, subscribe into my channel, like the video, and if you have any question, just drop it in the comment below. Or if you have, let's see, any issues, problems, just let me know. Hi everyone. Now we start our, let's see, fantastic journey. So now we have this Azure portal, and we have the DevOps here. So our idea now is to build MLOps with the help of Azure DevOps CI/CD pipeline. But now you can see here you have different websites, and now we have to make a connection between these two websites. So how to do so? Let me just show you how to do this. If you go to the projects setting, and now go to the surface connection, and from here you need to add a new surface connection. So for this, I will choose Azure Manager, Azure Resource Manager, and I will just click OK. Now I have to, it will pop up a new window here, which is you have to, let's see, sign in. Deep knowledge. We have to sign in so we can see the resource groups. And let me see, already signed in, and you can see here now our subscription, pay as you go, and it might be in your case your subscription, and this is the subscription ID. If I go here, and I can see the subscription ID right here, you can see this one here. Now I have a connection, but let's see. So now I have which resource group I will choose, maybe this one here. Now the surface connection, we can call this MLOps anomaly, and this one will be optional, let's say. And here I need to give this permission to any pipeline. It might be I will create several pipelines, so I need to get this access, or let's say permission for this connection to any pipeline. I will just make save. This really, it's really important for you to understand this. Otherwise, it might be difficult for you to follow us. So now I have this surface connection, but do I have the permission to create any resource group here? So, for instance, I have this pipeline here. For instance, create a resource group, and to create a resource group, we need to use this CLI version 2 pipeline. I mean command. Now, is this one here has the permission to create this resources? I think no, because I have to add it. Service roles. Click here, service roles, and we can see now. Before this, we can go to the manage app registration. We need the object ID key, this one here. So I will just copy this and go to this, or you can just go back to the DevOps and click here. Now I need it will open now the resource group that I have created. I mean, not that I have created, I have connected to. So now I need to add a permission here, add role permission, and I will add this Azure DevOps as a contributor. So click here, privilege, contributor, next. Now here we have to add select the members. I have to select the one that I have created, which is not here. Let's see, manage IP. This object ID, we have to copy this, and let me just back again, select. Now I have here, see, anomaly. This is the ID of my service connection. So now you can see select and assign. So unfortunately I have error here. Fail to add as a contributor. The assigned is already exist. One, did I add this? So let's have a look in the access roles, and we have contributor. Oh, I think it's something wrong, but I will try again. So let me just close this. This is the object ID. This is we need. I will add a contributor, add a permission, add the object ID. Okay. Now select. That's strange. Let me just check, and I'll be back to you, of course. I just have seen this one here when I see the the a connection. I have here the ID. So let me just try with this overview. Let me just try with this ID here and add a permission, and let's have a look. We need to select a user here, and if it's not working, it's okay. It's not working. It has to be only this object ID, which is this one here. But I have no idea why it's not working. But of course, I will find a solution. But they are just complaining that it's already exists. And now let's just try to run something. So I need to create now a small pipeline, and for that we'll go to pipeline and create a new pipeline, and let's just make it classic. Okay, the classic it's not here. So what you have to do is just go to the project settings, go to the main project, here, and go to the organization, and for this we go to the pipelines. Where's pipelines? Here, general pipeline setting, and here you can see here it's with the classic, yeah, disable classic, disable creation of classic build pipeline. So we just need to disable this, and also this. We need all of these, let's see, classic pipelines. So now let's go to our organization, select a demo. Now go to the pipeline. Let's now try to create. Now we have the classic, use classic editor. Okay, so I will use my repo, this one here, continue, and I will just wait a minute. Start as an empty job. Now I have this up. I have also to select the default. Now here should be, for instance, Anoma, AnomaVision. So for the first job, we have to select the pipeline. We will see default, and I have also a videos here on how to create a, let's see, pipeline. I mean, a build agent. How to create a build agent so we can run the code and see that. So here now I need to add in the beginning Python, Python, Python version, and for that I need 3.11. The second one, let's see, Azure CLI. So run this, and here you see I need to open the connection. Our connection was MLOps, and the script I will see a PowerShell and inline. So here I will just copy this. It's create the Python. It's just adding the command here. Copy. Sometimes it's easy to copy, but sometimes it's dangerous. We need to add here ML. Okay, so now let's see. Okay, now I need another one, just to make sure that it's running indeed. CLI, and now here I would like to call this create a resource group. And for the connection, we need anomaly detection, script, PowerShell, also inline, and I will just copy this command. Okay, let's see this our command here. Now we have no location. Location, it will be East USA, and the resource group, let's see, let's call it def. Let's see, resource group DevOps. It's just for sake of simplicity. And now I have to save. Now I need also to go to my pipelines. So agent, let's see, open, run. So this will run another PC, let's see, which called agent pool. And when I run the pipeline, it will try to run it here, which is indeed in my PC, but it's like it's considered as a separated PC. Let's see, it's not a separate PC, but yeah. So now it's connecting to the server. Now it's listening to jobs. So if I now click queue, hopefully this is the right build agent. And if it's this one, we can see here some. Let's see. Let's have a look. Yeah, it's starting to running job one, and here we see it's running. Now we will see now if everything now is the connection, let's see, between Azure DevOps and Azure ML is valid. So in this case we can see perfect. We will continue. Let's see, we'll start with the 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 real, let's see, the real work, how to make the build pipeline, I mean CI/CD pipeline. So let me pause the video until finishing this. If I have any issue, I will let you know, of course, and we will see how to solve it. Let me. Yo, as you can see, I still have the same error here, and the pipeline was creating I mean, install the machine learning extension. Now, when I try to create the resource group, it was saying that I have no permission. So I will try to copy this ID here and try another time, and if not, I have another solution for this. Just try here, add a role, contributor, next, member, and hopefully now should work. Otherwise I can give you another solution, which we can make a permission in top of the subscription. So yeah, now it's not able to do it. So let me just go to resource group, select this access control, and add roles. And here we have to select contributor, and here I need to add this as a contributor for the whole, let's say, subscription, because I will try to create several stuff. So hopefully now it should work. Now it's perfect, it's working. So let's now try to rerun the pipeline. You can see, just run, click edit queue, and this will take, let's say, somehow 5 to 10 minutes. I will pause the video and be back to you. So I'm here. So you see, I'm trying to show you what are the errors and how to solve it. So please subscribe to my channel, like, watch the video, and if you have any question, just drop it down in the comment below. No. So now it's running. As you can see here, this CLI extension, install the extension. It was taking 4 minutes, let's say almost 4 minutes. Creating the resource group was only 15 minutes. And let's have a look in the Azure and see, let's see, have resource groups. We have called this, yeah, resource group DevOps. That's it. And from next time, we will try only to work with the Azure DevOps, and also we will see the result on everything will be reflected to the Azure ML. Okay, then see you next time. Everyone, last time we have seen how to let's say sync, not sync, to how to add a repo to one repo. So I have the same. I have a repo here. Let's see, AnomaVision, and I have it also here with with the same content, at least this point here. And if you see here, I can see the the remotes, and you can see here this GitHub, it's connected to the GitHub and also connected to the Azure DevOps. Now the default one you see git add and git commit and git push. The default one will be to the Azure DevOps. Let's say this one here. Now I have sometimes when I have done some changes, I have also to be reflected directly in this in the GitHub here. So what I have to do, I have also told you last time we need a pipeline, and for this I have created a pipeline here, and let me show you how this is working. So here this is a pipeline. I mean, why this is important? Because I would like to make sure that everything is running in your side when I start with the from tomorrow. I think tomorrow I will start with building a real MLOps pipelines. And here you can see I have the pipeline here, and you can see it's called let's see, sync to GitHub, and this is the most important stuff. Here you need to change to your email, so add your email and also the GitHub account name. This you need to do it yourself. Just you need to change here. And what I have to do here, because I have already add the remote, a GitHub remote to this repo. First I will remove it, then I will try to add it. As you can see here, it's adding get remote add GitHub, and you can see the name, and the name will be taken from the current repo. For instance, this is our repo here, AnomaVision, and the name will be here replaced by AnomaVision here. Now I will push to the main branch, which is, I will say, pushing to the main branch directly. It's not a good practice, but I will just I'm starting step by step to give you everything and everything. I will, let's see, I will update this and we will see how it's working. Now I have this pipeline here. So what you have to do is just go to the pipeline. I mean to now any changes in this repo here. Let's see, in the DevOps, it has to be, let's see, directly committed into the GitHub here. Now for that we have to create a pipeline and use this YAML file. And let me just show you how I did that. New pipeline. Then you need to select the repo you have. For instance, this one here, and it's in our case it's AnomaVision. Now I need to, let's see, select existing Azure pipeline. So I will see here, select the pipeline that we would like to run with every changes in this repo. And let's see, continue. I'm not quite sure what will happen because I have already created. Now you can see here, this will be directly running automatically when I have any changes to this GitHub. So let me just show you one example. So I will just go here. It's because I have already created this pipeline, you can see, and it will be running when I have any changes to this GitHub. So if I just go to the AnomaVision, let me just open this. And let me only remove something or delete. Maybe eval. This is just to show you what I mean by running automatically. So if I see here, this is to make a complete evaluation on your data set. And now if I just push this, so you can see change eval file, and let's see, git commit. I mean this is commit and sync the changes. Now if you see now the pipeline, let me just go to the pipelines, and a pipeline will be triggered automatically. As you can see here, it's triggered automatically. Now we will see the changes if the pipeline is running correctly. We will see the changes in the eval function. For instance, here's the eval function in a GitHub, and you can see it has nothing. So, but if the pipeline is working, we can see it in a moment. So let's just wait a bit. Yeah, by the way, this will be pop up, this window here. You just need to sign in and give authorization. I will say okay. Authorization successfully. Now let's see, close and see the pipeline. Now the pipeline is running correctly, and if I just go to the GitHub, make a refresh here, and you can see this line was added. Is it? Yeah. And you can also see the commit. So I think will be here 1 minute. See, change alpha. Change is for wrong word, but this is anyway. This is how to do so. So this I already did that for my AnomaVision. I also added to the other repo, which is this one here, and you can see industrial. Go to the pipeline files, pipelines, and I have here this, and you can see I have the same stuff. So you have to do this by creating a pipeline, because here you can see I have two pipelines only for this sync between GitHub and DevOps, and it's a good practice indeed to keep everything up to date. So why I have done this, because when I add something here in this repo, and it's directly will be moved, or let's see, committed in both repos. This one is private, so you can't see anything here, and the GitHub, you can see any changes I have done in this repo here directly. So it's just for you to make sure that you have access to everything I have done in my DevOps account. That's it, I think. And if you like this, please subscribe into my channel, share, comment, and like. And see you next time. Hi everyone, welcome back to my channel. So after creating the connection between Azure DevOps and ML cloud, or let's say portal, this portal here. So now we need to create some resources that will be created using DevOps pipelines, and we will see it in this let's see tab, or let's see page. And now, uh, after, as I said, we have to create a connection, and we have did that last time. And now I have to create some resources. These resources will be in the beginning a resource group that will contain all the resources in this, let's see, project. And the second one, which will be the machine learning workspace. This will be also inside the resource group. And the next one, we will try to create a cluster that will do our, let's see, training. Maybe we can try to use CPU or GPU, but in this case I will try to use CPU, because training the anomaly detection, it's okay to run it in a CPU. It will take, let's see, a few minutes, but it works. So we will try, because it's working in my side, I mean in my notebook. And the third one will create some containers, and like Azure Container Registry. This will try to save our Docker image, and with, of course, with fast API. And then we will create Azure Kubernetes Service called AKS. This will try to run the Docker image from the registry, will retrieve this from the registry and run it inside the Kubernetes. But before this, we need also to install something in the Kubernetes server. This will be, for instance, machine learning, and then we will try to attach this Kubernetes into the workspace, which is machine learning workspace. And we will try to, let's see, upload some data, and also creating environment, because sometimes we have, let's see, our independent, let's see, packages that we would like to use. Sometimes it's not, there are several packages in the Azure cloud, but sometimes are not relevant, let's say, to us. We need somehow to do ourselves. So we will start with defining some parameters here. As you can see, this is the name. And to create parameters, you have to go to the library. Now here you can see variable group. You can add this one here, then name it whatever you want. And here you add some parameters. Why we have done this using, for instance, using variable parameters? Because what sometime when I would like to use these parameters in different, let's see, pipelines, I will just create it once here, and I can use it wherever I want, just mentioning the name of the resource of the variable group. For instance, our group, I name it like this: MLOps Azure components. Now I will try to create, as I said, some parameters like Azure container registry, which is Azure ACR name, and this is the name. It should, let's say, reflect somehow what is the project you are working on. You have to be careful. Sometimes the naming is restriction. As you please, you have to go to the I think one or two, I don't know, maybe 3 or 4 videos. I have add this, what are the constraint for each component. So sometimes, for instance, here hyphen or dot or underscore as not, let's see, accepted. Not here, inside this Azure portal. Now I will also give a name for the Kubernetes cluster, also for the compute name for data anomaly directory. This I will give the directory to my PC, and this will upload the whole images in my PC. Also the the database name, which is anomaly AnomaVision images. By the way, you can also use I have see this repo here. I will try to use this for our experiments. So please try to use this, and also try to start or like this repo. Now also for the rest, it's somehow the same. And now let's go to the our repo and our to the pipelines. Now we will try to create new pipeline. What I have did done here, leave. Now we have to select our repo. It's now in our Azure DevOps, and of course you can use GitHub, any other, let's see, server. So I'm using this, and our my repo is this industrial anomaly detection. Now you can also use Docker, what's that? Docker image, or you have to build it in your side. And yeah, and here I will start with a startup pipeline. So I will just create this, and you can see here it's somehow empty. I will try to add here somehow infra infrastructure. Let's see, infra. It's enough. Now, why I have add this? So now this one, this pipeline will be only run once. So some creating a component will be only one time. Maybe in the beginning you have to do it manually. So this will not be, let's say, triggered automatically when you have any changes. Why? Because creating some resources, the same resources, sometimes some resources will not allow to create it if it's already exist, and sometimes the creating these components will take much time. So in our case, this time here, I'm guessing that these components will be created in at least 30 minutes. So creating this several times, it will just wasting time and resources. So we have to do it this only once. And trigger, we have this mean here, this the trigger mean. It means any changes in the main branch, this pipeline will be, let's see, triggered. But we don't need this. We have to only at let's see. Oh, it seems it's hard to, yeah. So only when we have to add the path, and here the path we have include, and we have infra infra. I have forgot this infrastructure. So now this pipeline will be only triggered when we have any changes in this pipeline. And of course, you can add the trigger to none. You can do this, but I will try to make it like this. So now we have to define the poll, which is already here, but I have my poll, which is name. I will just use default because I have also I haven't shown you how to create a build agent. Let's see, local build agent, but I have done it in the in one videos. I have already attached this last time. So please have a look. Be sure that you have already configure your set out, let's see, environment, so it will accept any stuff. So now this is my pool, and here I have variables. This or the variables I have created here. So you can see here this one. I will just try to copy this, and we can add group. So you can see this an indentation has to be done. For instance, here you have variable. Then the second, let's see, child will be one tab, and if you have any other, for instance, see, trigger, tab, tab, tab. For each one we have to make a tab. Sorry. Okay. Sorry for my sound. It's not, let's see, fine because I have somehow a flow. And he now let me just see. We have some steps here, and for this, I need somehow to define the stages. So it's only will be one stage indeed. Stage. I will show you next time what I mean by stages when we have several stages. So stages, it means if you have if you have several stages that will be independent on each other. For instance, if you have 10 stages, for instance, training, validation, deployment, and if there's any error in the stage, for instance, training, the other one will be stopped. I mean, it will directly stop because the other one, the following stages, it depends on the training. So we will see this in more details. Now I have to define the stage, and I will call this bootstrap Azure infra. Now we have to define here a display name. Display. By the way, you can see here there's some. Let me just remove this because here's some error. Let's see, display name should be install Azure components. Type array. Stages, yeah, this is correct. And stage, yeah. Now display name, then we have to, so you can see this assistance. So you can see some settings, but still not stages. Let's just continue, and we will see what is wrong. Install, and there, of course you can. There's some check the YAML file, so we will see how to check the YAMLs. Now we will add some jobs, and these jobs we have only one job. Let's see, set up, and for this job we need to somehow we need to add display name. So let's see, or this maybe he install Azure infrastructure. Maybe it's wrong. Structure. Okay. Now we need some steps. And the steps, we have also some tasks. In that steps, we have task, only one. So I have no idea why it is. Let me check why it's not. It's There's some error here. Yeah, it's somehow sensitive. So somehow if we need to add space here. So now we have some steps and we will create now task, 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 and we need Azure. Let's see, you can see here, search, Azure CLI. We have Azure CLI, and you can define it also here, and you can add it directly to this. So for instance, just add this, the the cursor here, and let's see, we need to have a connection. We have created this last time. Now the type of it's a PowerShell, and of course you can use whatever you want. And I will try to use inline, and here inline we will try to in the beginning we have to let's see what's that, install the machine learning extension. So what you can do is just type easy extension add name ML, and you can also use this with only one, but I just would like to make it more clear. So now you can see add. So now if I just press click add, you can see this will be created in this automatically here. Now what is wrong here? I hate this YAML steps, bad indentation of the sequence entry. Okay, here you can see setting. Now we have here the input has to be also indentation here. Now as you can see, I have the Azure subscription. I will use this subscription that we have already created last time. So just a recap. So service connections, I will use this one here. So this we have created last time. Please try to have a look. And I mean, without this creation, you will not be able to continue indeed. So now here we have created the I mean installing the Azure Machine Learning. Now we need also now to create another task, which will be also a CLI. And let's just go to the next line. Oops. So here you can also, yeah, either just you can copy this and change the name, of course. And we need also somehow to add display name. So you can see display name, because otherwise it won't be let's see clear. So I will try to see step 1, install the ML extension. Now you can see I have just to move it here. So Emma, you see now this is this name has to be here indeed. Yeah. And for this, because we have copied this, you can go also to setting and you can update this stuff here. So you can see script, PowerShell, inline, and the now we will try to create. Let's see, what's the display name? Strange. There is no display name here. Because without display name, I mean, it's not, let's see, a profile, right? So let's copy this. I mean, I will just do some stuff, and after a while, I will just pause the video and copy the, finishing this and show you, just show you the latest stuff. So as I said, here we have to create to install the extension. Now we need to create step 2, create the resource group. And here you can see this is the subscription PowerShell. This is fine. Here we need to add our command line. So you can see it's in line, but because I just want to make it somehow more organized, and I will just make it somehow multiple line. So group, now create, I have to add this. So now I will go down, double hyphen, name. Now I will try to use my parameters from this one here. Oops, so here you can see I have defined some parameters, and I will try to use some parameters. For instance, this resource group, just copy the name, only the name, not the value, because the value will be taken from when we see here. So $sign, you need to add this. It's important to add this brackets, otherwise it won't work. So now if you need any other different line, I mean, of course we need for the location, and of course I have a variable with the name location. So these are the most, let's see, important parameters for the creating the resource group. And now we will create a resource group with this name here, resource group ML AnomaVision dev. And you can also change whatever you want regarding this. So let's keep it like this. And for the location, you can see location, yeah, SUS. So also the location, try to select the close, let's say the close one to your location. And the third component will be, let's see, the resource, our third one, create machine learning workspace. So we need to create our workspace here. So these parameters will be, I mean, this input will be the same, but here we need to just choose ML. So if you ask a question why we have installed the component with it, yeah, extension. This one here, we have installed the extension, ML extension. Here we can use it. Azure ML. Now we need to see workspace, then create. Now some parameters, what are the parameters for this? We have several parameters, and in the beginning I will just use this name because we need it. So let's say the name is $sign, it's workspace, capital letters, workspace, yeah, just copy this. So this is the advantage of using a resource group. I mean variable groups. This will be used in a different pipelines if you want. So now I have defined this. Now this source group in which resource, I mean this workspace, in which resource group have to be created. So you can see resource hash group. Now we have this. Now we need also the location. As we have said, as I said last time in one video, that when you create a workspace, some other components will be created. For instance, a storage account, key fold, and also app inside, and uh, I forgot the last one. But this will be created once. So you can see if you just go to this, and you can just go to the source group. This is just see search create, and you can see here this is the command that related to the workspace. So here are the parameters that we need to uh, some are not required. For instance, resource group it's needed, and also the location it's needed. And as you can see here, this is required parameters. Okay, only the resource group. Interesting. Only the resource group is important. And as you can see here, this inside this brackets, it's not. It's only optional. And wait a second. Yeah, here you can see storage account, and also key fold, and container registry, for instance, and application inside. This will be created automatically. The default value is true. So you can see application side of application side is space. Not sure if it's mentioned here, but this will be created automatically in your side. So now I'm just creating the workspace. Let me pause the video, and I will show you what I have done, because the video is already 20, 26 minutes. Okay, so as you can see here, so please focus on this, because some parameters will be really important for you, because to save you save your money and everything. So please be I mean, watch till the end, and yeah, please like the video, and also subscribe into my channel. So as you can see here, this is the creating the I mean installing the extension. So this is for creating the resource group. This is for workspace, and here I have created this, and also comment this out, because this is if you would like to make a Kubernetes, let's say a connection between server, I mean Kubernetes to the Kubernetes is, let's say, secure. For that we have to create SSL certificate, and also SSL key. And for this you have to use this command. If you haven't already, so this command here you have to create let's see the key SSL key and SSL certificate. And you can see here this is the let's see the expire will be let's see 1 year. And this will generate few files in your directory, and these files will be, I mean, try to make it like this. For instance, what I have done here, I just add this as a directory here. Where is it? So you can see I have this certification is this one here, which is generated from this command here, and also added in the SSL key. This I will use it in the pipeline, and I have no, I don't need to, let's say, put this two files in a code, and because it's a secure, so we have to make it more secure. And also I just remember I have update, yeah, for instance, also the dataset directory is also added here. So when I run the command, the self agent pipeline, because this is in my PC, and I know where to find the dataset and everything. And if you have another PC, you have to also add these variables in the other PC. This will work as a build agent, and I think this is easy. Now let's be back to the workspace, to the pipeline. Here we have created a resource. I mean, container registry. As I said, this will be used for the to saving the image, the Docker image. And you can see this is the command, and also you can open it here if you want. And the next one is creating the cluster. So here's the stuff. So creating the cluster, you need to define the enable cluster auto scaler. So if you have a big load, this will be this you have to add this parameter here. So if you have a big load, the cluster, let's see, it will be extended automatically. If not, it will be down to the count 0. And for simplicity, I have minimum count, both minimum count 1 and maximum count is 2. And this is the virtual machine size, and this is enable, managed enable. You can use it also generate SSH key. So once you have created this in the cloud, and you can also access it with SSH command. And also here I have added load balancer idle. After if it's idle after 4 seconds, it will be let's say idle. So this will save you much let's see cost or money. And the next step is how to create. So now we have created this cluster. And the next step to work with this machine learning and running the Docker image and everything, we need to install some extensions. So these extensions will be Azure ML. So as you can see here, Azure ML, and there is a configuration setting. It's enable only the inference. So is it here? No. So as you can see here, I'm just using this Kubernetes only for the inference. No training in the Kubernetes because it costs a lot of money indeed. Just use it for inference. Of course, you can do it here. So, for instance, enable training equal true. You can do it, but the default value is the default for the training is false. And here you have to add a load balancer if you have to make a load balancer between these nodes. And here you can see I have SSLC C name is yourdomain.com. This was added in the command, so you can see. Just use this here. So I mean, of course, you can use your site, anything you want, but this I just use randomly. And here we can see there's also a parameter here if you would like to make it the connection is let's see insecure and unsecure. But for us, we need to, as I promised in the beginning, in the syllabus, let's say, that we need also to focus on the security, and for that we have to add these parameters here. So as you can see, these parameters it will be taken from the library. So where's the library certificate? For instance, you can see I have created a path, direct path to this file, and also for this file. So this will be locally in my PC. I mean, in the build agent, let's say, and it won't be, let's say, uploaded in a code or let's say in a public, let's say, way. So this is secret. So this will be only in applicable, let's say, accessible from my PC, and that's why we have this now here as a secure. You can also do it with non-secure, but I I will just recommend you not to do this. So let me just go to this command. There are a lot of commands in this extension here. So you can see, let's go to this. And here is no secure. Can't see it, but Griffin. I'm sure it's here, but I can't see it. Let's see. Secure. No. Strange. Wait a minute. I have to find it. I have checked this and I haven't seen any parameters. Let's see, maybe this in the version 2, version 1. But to make it without secure, you can just remove this line here, and also you have to remove this this word here. I mean this to me. And in this case, you will use it. Let's see, in unsecure. So now the next step after installing everything here, we need now to attach this into our work ML. Why we need to attach this to our work ML workspace? Because in the workspace we will do our training and also creating endpoint for the inference, also deployment in the workspace, in the machine learning workspace, and this cluster will be used, connected, let's say, or attached to the workspace, so we will be able to use it as, let's say, for the deployment. And next step here, so by the way, this name here, this name, it's the experiment. Let's see, you have created a cluster, or let's say Kubernetes, and this name here, what would you like to name this cluster inside the workspace? I hope it's clear, because here you can see you need also the resource ID, and for the resource ID I have also add this automatically, so you don't need to go to the Azure cloud and get the resource ID for the Azure, for the Kubernetes. So here you can see I just get this with this query here. Give me the Kubernetes show with the name of AKS name, and with the resource group, and this will return us, let's say, give us the resource ID. And here, if you would like, for instance, we have named this as AKS Anomaly cluster, and would you like to name it the same? You just can name it as you want. But this is, I just gave it a name which is what is this name? Should be here. Right, yeah, this one here. For instance, WS Anomaly AKS. And this name has a restriction, I think maximum 16. So please be careful. And after connecting this to a resource group, sometimes, not sometimes, we need, let's say you need this only the cluster, the Kubernetes, it's only for the inference. So you don't need to create it, or let's see, create the cluster and connect it to the workspace now. So you can also create another website, another let's see, YAML file, and also call this let's see, for instance, here infra, and I can call this Azure component, and let's say I can see training. Maybe is it big best name or not? No, I will just say Azure components. And for you, if you would like, as I said, the Kubernetes cluster, it's not needed to create it right now. So you can create another YAML file, and also after, for instance, after the training, you can also create it. But I just would like to show you how to create the stuff. So now here we have created, I have created a cluster, a compute cluster. So now there's a difference between compute cluster and also Kubernetes. Kubernetes, it's a it's a it's a Kubernetes, and it has several, let's see, PCs, and also the compute cluster, it also has different components. But here we have some loader balance, and auto, let's see, auto scaler and everything, but here not. And also I give you shutdown image. It should be, let's see, uh, no, it should be 20 minutes. Maybe it's good. Here I'm creating a cluster with the, let's see, minimum 0 and maximum 1. And if you see here in the Kubernetes, you have to add the minimum one, so it has to be one, and the minimum instance, and the idle time before scale it will be 20 I think 20 minutes or 20 seconds. Let me be just quite sure. Idle time, if we just see here, so it's easy also to do it yourself. And let me just go here, and I would like to make let's see everything clear. So any with it, idle before, idle before down, what is it? So idle time before scale down, I can't copy paste time, it's in seconds. So let's just keep it like this. So our it will be 120 seconds, also 3 minutes. No, 2 minutes. And you can see here, when I create a cluster, you have to also identify the workspace and I mean resource group and also workspace. Now for this, uploading the dataset, we also need this for the training. Before doing the training, we need to upload some datasets. And this I have showed you last time when I created the storage account. And good good point here. So as you can see here, I haven't created any no storage account, no container, no data assets, nothing. So what I have done, only using the default value. When you see here, when you add command, this command ML, I mean easy ML data create. This will be I mean will create data assets directly in this in the storage account of the workspace. So as we have said in the beginning, when you create workspace, storage account will be created, and this will take the default one. And here you can see I have added the path, and the path it's also in my PC, and I just add this yeah here. So this will upload the whole let's see the whole folders, if it's inside the folders. And here, this is, let's see, more important let's see component. Why it's important? As I said, in the Azure ML, there are several environments, but they might use different stuff. So maybe we have used OpenCV, which is not, let's see, in this. Maybe the version that we would like to use, it's not supported in this environment, and etc. For instance, I'm using Torch 2.2, and maybe in the other one it's different. Maybe Panda is not. I mean, as just as a conclusion, you will not find any environment in the Azure including all of these dependencies. So it might be also not needed, but let me just see here, deployment, and here you have created only a short environment stuff. So as you can see, this is our dependencies, which is develop for the development. For the environment that we would like to create in the Azure, I'm using this dependencies. So some of this maybe will not be used. For instance, payload, I'm not quite sure if I will, maybe I will just remove it. ONNX might be needed, because I will, after that I will convert the model. As you can see, I will convert the model into ONNX file. Let me just go here. So I have done some experiments here, so feel free to have a look here. And as you can see here, I have add these lines here. This will be, this will create I mean will track the model ML using MLflow. Will track ONNX model, and will try to create some ONNX model parameters, register everything, and this will be uploaded directly into the workspace. We will see it, of course, in the next videos. And here you can see we have to create our environment. So it's really important to register you. I mean, to create. Let's see, create a training environment. And you can see here image. I have used Ubuntu, and the Kunda file. You can see it's in the directory, the build, the main, let's say, directory of the resource of the repo. For instance, this is the main directory here, this one here, and from this you can go to the development and take this file here. So you can see development and environment, and this one will create our environment. The environment will be used in the training cluster to train our stuff. So this is let's see how to create these resources. And if I save, and I have to save this now, not to run, only save. And of course, now if you would like to run this pipeline, you just need to click run pipeline, and you can see here it's trigger only in the infrastructure directory, and from the infrastructure directory this will be inside, and it will try to run. So I will try, because as I said, it will take let's see, at least one half an hour or maybe 1 hour, depends on the PC and the build agent and everything. This will take time, and I'm just guaranteed that this will work in your side. And if you have any issue, please write it down in the comment below. I will investigate and tell you what is the problem. Thanks for watching, and see you next time. Hi everyone, welcome back to my channel. So, as you have already seen, we have prepared two repos, one for the industrial anomaly detection MLOps, and this one here, AnomaVision. So I don't want to, let's say, to mix this. Sometimes some guys, they would like only to use AnomaVision for something, and the other guys, let's say, sometimes they are interested in anomaly, let's see, industrial MLOps. So what I have to do, so for instance here, I have this repo here, and I would like, the goal is to use the AnomaVision. Let's see, let's see here, AnomaVision, I would like to use this inside here. So there are two different methods, let's see, scenarios. Either to copy AnomaVision from here and put it in this one, which is, this method is really bad. And the second one is to add this AnomaVision as a sub module in this repo here. So what is the advantage of the second scenario? Is that in case you have updated anything in AnomaVision, it will be reflected directly, not directly, you have to pull directly to this, and you have to, in this repo here, I will use the new, let's see, the new version, the new updated, the new anything anything is let's see, branches, changes, bug fix, what will be pushed to this repo here, it will be directly to the applied to this. So you, in this case, you will use the latest changes is of Anoma. And the second advantage of this, sometimes you don't need to use, let's see, Anomaly. You would like, let's see, to use your stuff, maybe classification, maybe LLM models, and whatever you want. So what you have to do is just add as a sub module here, and that should work. So let's see here, I have prepared the command get submodule. You have to add the directory uh, to the repo you would like to add as a submodule, and here's the destination. Let's see, I would like to put it in this source. So when I click OK, did I click? So now you can see it will be cloning the whole repo inside this anomaly, MLOps. So you can see if I go to source, and you can see here is AnomaVision. And one more stuff here, if you go to get modules, open this one here. Let's see with this, and you can see here the submodule source, and this is the direct link to the AnomaVision. And of course you can add as many as you want, but I would like just to keep it simple. And one more hint is, if you go to get this hidden folder here, and you go to Hawk, not Hawk, sorry, and the modules, and you can see now the anomaly here. And for instance, now I'm using let's see, Anomaly, and next time I would like to use something different. And what I have to do is just adding the same stuff as I have done it here. Add a submodule. Also, you can remove it if you don't need it. Let's see, anymore. And I mean, this I'm just teaching you how to do stuff. Let's see, in a professional way, and also trying to teach you the MLOps, and also how to structure some things. That's it for today, and thanks for watching. Hi everyone, welcome back. So in today's video, I will try to show you how to, let's see, reduce, let's see, the amount of cost, let's see, for any resources, and uh, also how to create, let's see, an alarm. If the cost is already exceeded something, you have to get, let's see, a notification in your email, or and this will say, let's say, help you to let's say, to save money. For instance, if the amount of money exceed $100, let's see, you have to see which resource has to be, let's say, removed. And in this case, we have to see, go to the Azure, and here you can see, go to cost alert, and in here you have to select, of course, your directory. I mean, here we have to go to create alert, and let's see here, anomaly, we have to go to budget, and in budget we have to see here, add any filter. For instance, here, that billing, let's see, profile, and this one is our profile. Or let's see, without any filters. And here you see high cost, for instance, and this will be monthly checked. And if the amount is exceed $10, let's see, you will get a notification. And let's click, and here you need to select the email that you would like to receive. At least one alert method percentage is required. Please provide a valid, okay, actual, and it's 10. 100 euro. And here you need also to add, if you would like to add several emails. And for this, it will be language, it will be of course English. Now we can see create, and now if monthly, if the amount of money is exceed, let's see, 1,100 euro, let's see, this is the budget. Yeah, this is the budget, $10. And this is the actual, it's 0. And if it's already reached 10 euro or dollars, you will get a notification. That's it, and thanks for watching. If you are using a Docker, I'm quite sure that your CD drive is almost full, and the session today is I will show you how to move the Docker images, the Docker into, let's see, D drive or maybe an external drive. So I will just start with CMD, and in the beginning we have to shut down this. So let's shut down this Docker desktop. Now I would like to see WSL, no, exit WSL. So you can see I have only a Docker desktop, and in the previous versions of Docker they have Docker desktop and Docker desktop data where the images will be saved, but in the current version they, it seems they just merge it into one drive. So we will see in the beginning we need to shut down the WSL, shut down. So now we have shut down our service. Now I will just use this command here, which is export data desktop, I mean Docker desktop, which is this one here, and save it in the directory. Let's see, my directory. So this will take few minutes, depends on the stuff in your site, the images. Now I will have to register and unregister the Docker image, which is successfully. Now I will try to import this from this image that I have created, I mean from this zipped file or tar file that I have created into, let's see, this directory. Let me just check if I have this directory. WSL, no, it's only WSL. So I have to remove this one here. Now this will, let's see, have a look here. You can see it's extract the the images in here. So now let me just now delete this tar image, and the next step we have to do is go to the Docker image, go to Docker desktop. I will copy this directory. Now go to setting, resources, and you can see here the default one, the default directory is the C, and I will change it to Y with my image. Let's see. So it's D Docker WSL. I will choose this and apply and restart. So please careful that all the images will be moved into this directory, the new one. So now it will try to restart, and we will see. Perfect. So let me just make sure that it's already in D. Go to resource again, and now you can see this is now your the image is actually now, and from now on, if you build any Docker image, it will be saved directly in this directory. That's it for today, and it's almost it's saved my life indeed. This stuff. Thanks for watching, and see you next time. In the previous video, we have seen how to create Azure components. Let's say workspace, compute, data, how to load the data set, how to create, let's say, Kubernetes, and also a container registry. Now, if you already did this, make sure that you have to, let's see, remove it, or if you, because the cost it will be high. And now the next step is how to train our code, let's see, in the cloud. So I have also shown you last video in how to add a a sub module, let's see, in our code. For instance, this AnomaVision, I have added this as a sub module. So the latest version of the AnomaVision, it will be directly here, so accessible here. Now, before indeed doing this in the cloud, we would like to make sure that everything run perfectly here in our local machine. So instead of, let's say, because training it takes much time, not much time, but I would say making these resources and doing this training, and if you have an error you will do it again, and this will cost you, let's see, somehow money. So we can do this step previously in our local machine, which cost us, I would say, nothing. And when we see that everything is running perfectly, we can run, let's see, do the training uh, on the cloud. So as you can see here, this is our training, and this is the normal training as I have done it, as we have it in the AnomaVision here. For instance, we have here training. Let's see, train, yeah, for instance, stream file here, but it's somehow a little bit different from this. And as you can see here, it's just here a short file, but in our training that will be run on the cloud. It's somehow much, let's say, bigger. Why is that? Because I'm using MLflow. This will track our, let's see, experiments, and see, create, let's see, models, create the environment, create, I mean, tracking the result, and the parameters, and everything will be tracked. And this is, let's see, one benefit of the MLflow. So now if you have any bug or any error, you can go to the version you have, let's see, you got the error, and let's see, fix this error, and it also give you a reproducible result. And now you can see here I have imported this from, not from our anomaly flip, AnomaVision, but here, because I add it as a sub module, so now I need to import this stuff inside this. So as you can, but the let's see the disadvantage of this. I couldn't see it as a disadvantage, but it might be maybe for you, because we have a lot of files here in this area here. So sometimes we only need specific files from the Git repositories, but this is the case of the module. But if you would like, you can use a Git tree graph. And I'm also would like to track, I mean, convert the ONNX into the MLflow, and it will be tracked as well. And you can see here I have some parameters, data path, and let's say a modeled data path that will be saved in. And what is the data path here? So it's here in a locally it will be as a directory to the images that I would like. But when we run this in the cloud, we have to use a file, let's see, called let me just see, where's this file? It's pipelines, maybe job, yeah. So this, we will have our model, let's say our file. It will be trained on the cloud, and you can see here data path. It has an input directory, and inputs we can see it here. You can see data's path type is a folder, and here we have our data set. So that we have already uploaded from the previous. Sorry, someone is clicking the door. Okay, and let's back to this here. And maybe one question. So I would like to track, or let's say look our parameters and models. So because we wanted to, let's say, monitor what's happening during the training, evaluation, and also debugging, and see what's going on. Let's see if there's some any issue. This will help you to catch where's the error exactly. And these are the parameters, and as I said, these parameters will be taken in our cloud from this file here. And you can see sometimes it's somehow there are some let's say default stuff. And here, for instance, the default one is ONNX, and the data set we have also to use a data set, and also for the compute we have to identify what's the compute. Also, I think with the environment, yeah. So also this environment, it will be changed based on what we have already defined in our YAML file. I mean, last time, for instance, here you can see, I think it's end of the file. Yeah, this one here, for instance, it will create name MLOps AnomaVision. It should be indeed env, but yeah, this will be fixed in the next run. And yes, so also I need to evaluate the model. So why we need to evaluate the model? So I have all upload the whole data set with the training, testing, and evaluation. I mean the whole data set for only one let's see class, which is battle. And uh, here I'm trying to let's say training the model, and I have the model, the output models as ONNX or maybe as MLflow uh, files. And now I would like to see if the model is working perfectly. So I have to evaluate the data, the model on the data already uploaded, and I will show the result. Let's see as a in a dashboard that show me what is the accuracy, what is the uh, let's say the running time, even for the training and for the evaluation, and every mode, every parameters it's let's see needed. And you can see here I have this evaluation. Of course you can also add it see it in the eval here, and also I have the score. This will be everything will be logged in the metrics, and this metrics will be returning to the main function. Let's see. Let me just check if it's the main function, because evaluate, and we will see it will be returning to here. And see how many values we are tracking. Say for instance backbone, batch size, index, layer indices, feature let's see dimension, and these parameters are related to the PaDiM algorithm. And here also I'm saving the version of the torch, the CUDA, if it's available or not, and everything will be here tracked. And here I'm not saving this because the PyTorch model, it's a big, let's see, file. So I'm just exporting it to ONNX, then track this ONNX file. And you can see here the model information. These are the model information, and here the input shape is this is, let's say, the default training of the even of the publication. So that's I have just save it as it is, and the created at it will just give you the current time. And here let's see we need to run this. So Python, let's see, it's in a source train, I think train. So this will take somehow maybe minutes. So let me pause the video and let me just show you what are the results will be. And you see here, once training is done, we convert the model to ONNX, which is indeed perfect for deployment across platforms. You can run it in let's say any environment. And then we look this into the MLflow and its versioning and give it as a versions. As you can see here, I have a version created automatically when you run. So now if I run it next time, it will give it give this version as 3. It's accumulated. And also if the evaluation is enabled, it's because it's a parameterized, you can see here. And if it's enabled, we run it and look all the matrices, and we also look some JSON metadata about the model. Also, it's let's say it help us to understand what was trained and how. And let me now just see what are the data will be saved here. So MLflow UI. And now I need to open this link. So you can see here, this is our runs, and you can see here I have two runs. And if I click, this is the models, and if I click, let's see which one is this one here, and you can see the parameters of the models. I have used Resonant 18, number of, I mean batch size is 2, and CUDA available, no, it's false, and this is the data path, and you can see device, CPU, and etc. And here's the accuracy of the evaluation. You can see here model matrices, you can see the training time in seconds, and also system matrices. Let's see the artifacts. So this is the, let's say, the interesting for our for ourselves. Let's see here the model. It's ONNX model, and this is generated by, everything is generated by MLflow. And you can see here, for instance, what are the important packages that we would like to run. So if you now use this and just install this here, for instance, in your site, it will work without any issues. And this is the requirement. It's indeed created as a requirement text file and also Anaconda. And why I'm doing this, because if we understand correctly what is the training and do the training locally on our PC, this will save you much time. So if you just run it on the cloud and you have issues, you will be back, retrain the model, and also because for me it's also let's see, costly. So I just need to make sure that everything is running locally, and after that I will try to do it on the cloud. And this is the file that I will use when I, not this one with the job training, yes. So this is the file that I would like to use when I need to train the model on the cloud. And I think that's it. And if you have any question, just drop it down in the comment below. Thanks for watching and see you next time. In the last video, we explored model training and explained how PaDiM, or let's say anomaly detection, works. Today we are going to the next big step, deploying this model locally using FastAPI. So one question, as after the training, let's say I'm just assuming that we already on the cloud. So after the training, what is the next step? So the next step is to make, let's say, any, let's say, fast API or endpoint that we would like to consume this model and do it, let's say, to our training, or let's say in the production. So as every step, sorry. So why I do I'm doing this locally. I mean, each step has to be, let's see, be have to be done locally. So because this is the I will say diff loop for the MLOps. Prototype, test API endpoints, validate the result. Then we would like to containerize this. So as I said, after let's say, this is the fast API. This fast API, I would like to test it locally and see if everything is correct. It's starting with loading data, set the parameters, if I have some parameters, let's say, and also do the processing and returning the results that I would like to see in the another, let's say, Python code or any browser. So, and someone will ask why we are doing this. So I'm always start locally before going to the cloud. So because debugging is easier, performance testing is a fast, and we are you are in, let's say, in a full control. So once everything is running in your site, for instance, training, fast EBI, and the Docker, or next time we will try to create a Dockerized Docker file and to run this fast API. And after a while, we will try to just to combine all of these steps and create our pipeline that will run, let's see, on the cloud. Someone will ask why you just give us the code and we can do this ourselves in one video. First, preparing this stuff, it takes much time, Also, sometimes you are not working with anomaly detection, so you might be working with another system. And if you are not aware of how the system is structured, how the system is working, it would be, let's say, difficult for you, and you will try to change the files and many times, and you will maybe spend much time only how to understand such stuff. So now let's just go to the beginning of this file. And yeah, by the way, I'm not quite sure why this let's see videos are not, let's see, getting more engagement. Is it advanced? Is it not? Is it clear or maybe not clear? I'm not quite sure. So if you have any question, just drop it down in the comment below. And let's start with this. And here we have this is our fast ABI. And here you see I'm loading the model, which is let's see a global, and they have a session for the ONNX model, and they have some parameters here, which these parameters only a default if I have no parameters. So just imagine this is one application, and the other application I will have, which is let's say in our case it's Streamlit. And here, this is for instance, this fast API will, let's see, starting loading, it will run as a server, and you start to run to load the model, and let's see, listening for the to the to any input for specific port, and for the Streamlit or any application, it's not necessary to be Streamlit. And I will send from this application here an image, and the image will be sent directly to this fast API and do the processing we will see in a moment, and returning some results we will see also in a moment. And the Streamlit will try to, let's see, decode the images, the results, and to let's see, try to show the results. So here we try to load the model, and it might be ONNX model or might be PyTorch model. And after that, I have to clean everything here. So you can see I have the session will be none, uh, model will be none as well, and this just to make everything clean up. And now in the when we read the model, well, it will be using the lifespan, or in the previous versions it will be like on event, and we will try to load the model. And after a while, if it's working, we can, let's see, go to yield, this is the generator, and then we'll wait on the clean session. Now here I'm creating an app. This is the results what that I'm expected. I'm expecting some results. Let's see, anomaly score. The class label, let's see, class label, is it anomaly or not? And here's the my, so you can see here I have optional results, but these are most have to be provided. I will show you just in a minute. Now this is the boundary images. Let me just show you, for instance, what I mean by results. Sorry. So if you go here to Anomaly, yeah, but please start this repo here. I have did a great job here, and hopefully it will be let's see evaluated by you. So here you can see this is the image, and they have the defected image. I mean the localizing the images, and this is the heat map. And this, let's see, will be sent from the Streamlit, and these results will be received from the fast API. Now here I have a boundary image, I have the heat map, and you might have, let's see, needed highlighted image based. This will be based 64 images. So, and here's the configure file, the configure models. In the Streamlit, we will set some parameters if we would like to change. And the default one, let's see, is this one. And if we have any, let's see, if we set any parameters, it will be taken from the from the Streamlit. And here you can see this is the get, and this is the endpoint. I have healthy predict patch if you have several images. Let's see, and here's the model information. You can see what is the model information, config, docs, and redoc. And let's move focusing on the, this is if you see localhost 88,000, let's see, slash health, it will give you this information here. And for the config we will get this also information, what is the config file, the config parameters. And let me just go to this here for the predict, which is really interesting. And here this is because we, when we send an image from the Streamlit, we'll send it as a byte, and now we need to decode the image from this and use it as a, you can see here, B encoder, and we will get this image and return it to the, let's see, to the detection, to the maybe this is not this, sorry, this is numpy to base. So this is when we send, and we would like to send the image back to the Streamlit. We have to convert it to base 64. And let me just go to the predict. When you see predict, it will call this function here. And here we have seen this is process the image size. I mean the image, and process the image for upload. And you can see here from upload. I have one image, I have a file. Let's see, it's byte array, and here I will decode it using this function and return it as a, pillow image. Then we will try to convert it to numpy array. So this we can also use OpenCV to decode the image, and it's really fast. I mean, faster than the pale image, and you can also remove it from here. But I will do it, or you can, for instance, if it's interesting for you, you can do it. Now with anomaly detection, and here, with it, if we have a session which is created by ONNX, we will try to make it as a patch file, and then convert it to a numpy, and then this is detection. I think you know this stuff. And here it's anomaly detection, and the most interesting part for us, if we have visualization, if it's including a visualization, this visualization includes visualization, it's as a parameter, and which is will be I think sent from as a parameter. It's not as a parameter, though. It's as a parameter. And let's see here what we are returning. I have a score map, the anomaly class, and also boundary and hit map. This will be returned to the to the to any program that will call this fast API. And here I have patch predict. If you have many images, let's see, if you have, let's see, 3 or 4 images that you would like to detect, but normally in the production you have only one image, so that the camera will be triggered to take image, send directly to the algorithm, returning the result. And I haven't seen, let's see, in a production you have sent several images, unless you have let's see, collecting some images, let's see, in a buffer, and send it once, and you will expected result. This could be one let's see, one option. And now here we will see how to run the uh, fast API. So let's go back to the Streamlit. This Streamlit will be in your site, let's see, locally. For instance, after finishing this app, I mean fast API, the next step will be to Dockerize this, what's called Dockerize this fast API, and we will check, let's see, run this inside the Docker image, Docker container, and see how we get, for instance, results. And I don't want to make this video, let's see, big. Also, I have this here, so let me just go to maybe here to the directory, and you see here I have AnomaVision. This fast API will try to use functions from this anomaly, which is added as a sub module. Now, sometimes you would like to exclude any PyTorch stuff. So, for instance, I'm using here for just for example, and this example here, I'm trying to use only ONNX model, and I have delete this. We'll just give it. I have to delete anything related to PyTorch. Why I have to delete this? So I will show you next time when I have created when I dockerize this with the PyTorch, and if I remove it, the PyTorch, let's see, we will see this the image size, compare the image size, and this if you see here, I have only a PyTorch, but I mean ONNX and NumPy images, NumPy only NumPy. But here I have added here some static libraries, which is only it's the same. It's the same as we use here, but it's only NumPy. No Torch is supported in this version, but you can see this is the visualization, and here I have the utilities, which is only for instance two batch, and let's have a look on the two batch in the normal one. Let's see here, utilities, and I think it's the last function. No, I have seen it. Yeah, two batch. By the way, maybe one hint for you. So for instance, you are in this file and you be back to this, and you can just go to here. It will return you to the, it's like a list. uh, what are the latest, let's see, history you have done. So here the two batch in Torch, and here it's in a NumPy image. So this was working, let's see, perfectly, but we will see that the performance in the last time. Let me just now run this. I will try to run this without any Docker image, just pure Python. Let's see. And hopefully it should run without any issues. And I will also open another window, and I will run the Streamlit app. You can see cannot connect to the API. Why? I will tell you why. Because here the IP address is 8080. It has to be 8000. Because here you can see, where is it? Yeah, port is 8000. But now you can just refresh, and we can see the maybe the correctly connected. Now you can see it's connected to the API, and it's healthy. And that is, if you can just see, for instance, uh, what we have seen, health. Was it health? Or let's have a look. Streamlit. Yeah, health. Should give you this one here. Strange. Let's see config. Why is still 8? Yeah, it has to be 8000. Anyway, let's maybe it's not now working. You can see here the model type, it's ONNX, and this is the parameter that will be if you would like to sit in the fast API. But let's try now with one image. And let's have selected some images. Let's see, contamination, for instance, this one here. And now it will send the image directly to the FastAPI, and you can see now the result are here. So for instance, the image is anomaly, the the anomaly score is 42, the threshold we are using is 13, and the running time, the most important stuff, is this one here. It's 2 seconds. Let's say 3 seconds for this image, which is really bad. I would say it's too much. But you can see here it's detecting the defect, and you can see. And if I go now to show you the result, not another result. What was the name of this? It's contamination, and it has which name? 17, right? So let's go here. Go to this contamination 17, and you can see. So this is the class label, let's see. And if you see here, of course, it's not, let's see, the same because I'm using less features and but you can see here there is some similarity. Just only this part here it's not detected, but it depends on the parameters that I'm using for the detection. Anyway, this is only to show you what's going on. Now, this I will see this will be in your a new side. Let's see. I just would like to test the anomaly. And the fast API, next time I will try to Dockerize this and see first is it working or not, and also see how much time it will take for each image. And also you can see I have this image this numpy. I'm not quite sure if if you need this, but I will just give you this one here with the ONNX and numpy. And yeah, that's it, I think. And if you have any question, just drop comment below, and please react to my videos because I'm spending much time, and it means a lot for me. If I see more engagement, you can't imagine how much I'll be happy. Okay, then thanks for watching, and see you next time. We have seen how to create a fast API, and we have already tested directly with running the fast API file. So in today's video, we'll try to Dockerize this fast API and see how to run that. So as you can see here from the first line, it's the first line indeed, but the first line we start to with lightweight Python 3.11 image, and name this as a builder. This helps us compile and install dependency in a clean, isolated environment. And the next one is work directory. So all commands will run inside app directory in a container. And now we need to install some dependencies. So here's it's installing it's these Linux commands, and here we need to install GCC, and sometimes sorry, some let's say packages like numpy or scikit-learn. They might need let's say C compilation. And the next line here, we have to copy the requirement files. I mean the requirement file from, let's say I have added here requirement, and copy it to the main directory, for example, to app. And here we need to install with no cache, and because we need to minimize the image size. The goal is to minimize the image size. And as you can see here, I have started with stages, and this will try to make it the let's see make it a clean, and also minimize the image size. And of course, see, you can see here the Python itself. So we have also to use slim Python, and we have to run This we create non-root user to follow, let's say, Docker security practice, and the work directory, it will be the same as the previous one. And we need to copy some files to the local, and also most important stuff is copy the source FastAPI Python file, I mean this one here, and put it in the main directory of the Docker, which is will be app. Also, if you have some other dependencies, you have to copy this. You have to copy it here. And because I have here AnomaVision, and I have to use some files, let's say, or functions or classes from this repo, so I have to add it also as well. And maybe if sometime so why add this just to make a directory? Because in the beginning I was thinking if I would like to add the PyTorch model here, but after a while, I said maybe it's not needed to have this. We need only an ONNX model, which is, let's say, easy, and you can run it in any environment and any, let's say, system. Okay, and here we have some secure files. So we change the file ownership and switch to app user again let's say, for just for the security. And for the set path, we need to make sure that we install Python packages like Unicorn are available in the shell. And here we have to expose. I mean, this is the board that we will call this. Let's see, when we run the Docker, we will try to call this localhost, and we can see the let's see the fast API. And for that, we can run the Streamlit or any application, another application that will try to test. Let's say we'll just use this API. So the fast API will run as a server, and when we need somehow to detect the defects in images, we will send the images from any other application, and the fast API will receive the image, do the processing, pre-processing, and also the detection, post-processing, and return some results. And we have also seen the results last time. And that's it. And here we need to run Python unicorn fast API host 00 port and 8000. And here I have already started to run the Docker image. What if you would like to run the Docker image? Let's say I'm here in the root directory. So here, this is the Docker. You can see. Let me just show you here. Here's the Docker. Here's the Docker image. Just remove and to collapse this. This is the main directory here, which is this MLOps, and the Docker file is inside Docker. And here I have said Docker build, then the file which is in a Docker file Docker. I will use this one here because you can define, for instance, here I have Docker file dot inference dot train dot. So it's let's see, possible to use this. And here the tag we have the name. It's FastAPI Anomaly AnomaVision latest version. So this is the tag I would like to add. When it's completed, it will show you the latest version. And you can see I just run the images here. So once it's finished, I will be back and show you the image, and we can test it together. It's already built, so let's see. Open the Docker image. See, I mean the Docker itself, Docker desktop. Okay, so you can see here I have what's already built 10 minutes ago, and here this is the size of this image here. So let's just somehow minimize this. So you can see this is the size, and here we have the image. Now, if we would like to run, we can run it from here, or we can use the command line indeed. So, but let's just try to investigate, run, and I will show you also how to run it in the from the command line. Now this is still running, still not showing anything here. So let's see. This is our files. You can see here app, and we have AnomaVision. It has also this distribution we have created, and also it has the FastAPI, the model, ONNX model. I think these are the most important stuff. And let's go to logs. Now we have, you can see here we can also run this edge localhost 8000. So now because it started reading, oh, yeah, no idea why it's not running from here. So let's see it run it from the command line. And here to run this, we need to add this, for instance, run FastAPI. The port is 8000, restart and stopped, and here the latest version. You can see here we have the tag is the latest. So we can run it now. Hope it should work now. Or it will complain about it's not, yeah, it's running now. So let's refresh this. Hey, let me remove this and do it again. So now we can run. It's strange indeed. So let's see what's going on here. There's also some commands to let's see investigate, and for instance you can see with logs, so you can see logs. Sometimes there's any libraries is missing, so it won't work. Ah, but it's running 8000. Okay, now it's running. So you can see now it's our let's see FastAPI is running. This is let's see the health, and it's if you see here for instance slash health, you can get this one here, and you can see for instance docs. So you can we have a predict, and also we have predict batch. So now let's see how to use this FastAPI, and let's see, utilize this FastAPI. So let's go to our code, and I will go to source and Streamlit app. So I will just open the terminal here, and let's see, I have built it, Streamlit. Okay, so Streamlit is using 8000. So I have to restart this. I mean, it was using 8080. Now I think it should work. Let's just refresh. it's not connected. Maybe I need to stop this, do it again. I just to make sure that it used 8,000. Without 8,000, it won't work because our server is listening key. Oops. Yeah, now as you can see, ABI is healthy. Now, if you remember last time when we run some images, so we have input some images from here, battle, let's see, test, contamination, for instance. And you can, if you remember, was the running time was 2 or almost 3 seconds. But for the first time, I think it will be decreased. Let's see, select another image. I can see it's minimized. So the when you try to load the model, it will take much time. But now, for instance, for 600 milliseconds for one image for using FastAPI, it's too much indeed. And to just to detect the anomalies. So let's see here, 40 millisecond, 400. And you can see this is the image, this is the heat map, and this is the defected image. And here you have the anomaly of this image, the classification, and also the analysis time. So let's do that again for instance, this image here, 50. And also it depends on the load of your system indeed. So let's see this one here. So you can see at least it's detecting some I mean the defect, the real defect of this image. But at as we have seen here, the image size is about is about 9 gigs, 9 gigabytes, which is really huge. I will say when you try to run this on the cloud, and for that for the space you need maybe to pay um, maybe more money or much money for this. And next time I will try to show you how to reduce the size of this image till maybe less than one gigabyte, and we will see how to do this. Thanks for watching and see you next time. As we have seen in the last video, our Docker image was about 9 gigabytes. So now my plan is to reduce this image with the same, let's see, running with me with the same environment, with the same, let's say, running environment and everything, the same system, let's say. And as you can see here, this is my requirements numpy image, and this is the last, let's say, the previous one. So what I have done, I just removed the torch vision and also torch, and I have also removed the I mean matplotlib lib and tqdm. This was removed. I mean, this was we removed from the, let's say, the requirement. This is the new requirement, but it's not only about removing the torch and torch vision. You have to update also the code itself, so that if you have any file that see import torch, this won't work. You have to remove it and modify your code to accept only a numpy image. That's what I have done. And as you can see here in the static, let's say just to move to the numpy, let's see fast API only numpy. You can see here there is no max. Let's see matplotlib. It's already commented out. I will remove it indeed. It's not needed. And also the torch and torch vision was reduced, is removed. So you can see here you have only runtime. I mean no, just only ONNX. You can see compare just these two files. Only these two. You can see here I have ONNX and also the PyTorch. So I have removed the PyTorch because PyTorch is also heavy, and also the model itself it's about 100 megabytes, which is I would say it's okay for normal devices. But if you move to edge devices, will be huge. And yeah, so I'm just using ONNX, and everything was removed for, let's see, anything related to the PyTorch is removed. And I have also updated, let me just show you some samples here. Uh, this was also used Torch, and I have removed this. I have removed only just use the the PyTorch, the NumPy. So you have just seen this. Yeah, see. So for instance, to to batch. So if you compare this with the two batch of the uh, Torch, it's a difference. So here I'm just using NB NumPy, only NumPy. So that's why it should work in my side. So let me just go to the Docker file, which is NumPy, and you can see Docker file dot NumPy. This would work, and it's the same as the previous one. But here I have also deleted some files. Sometimes we have this by C, and also this by cache by you. This will be delete. You need to delete this because let me just show you here. Sometimes it will be in, let's see, I don't know, maybe um, source. I can see this one here. It's not needed. Oops. So this one here is not needed, and you need to maybe to remove it or delete it. So what I have done is just delete these files, and it's not needed. The rest are the same, but I have just changed the directory to the static Anoma, and also I have, you can see here what I see. It's a static Anoma detect. Just use this. So I have used the files that haven't used, let's see, depends on the torch, and these are the same, and I have just changed the board, so it's just to make it different from the previous one. So let me just see, and also the building time, it's really fast. So I think few minutes and you will get the image itself. But for the previous one, I think it took mm, 30 minutes, maybe more, just to make the image. But I hope you already see the change. Let's see the difference between running the fast API as a standalone or inside Docker image. Inside Docker image, it was the running time was the inference time was about 400 milliseconds, which is it's quite, let's see, huge. And but if we compare it, when we run this fast API here as a run as standalone, it was 3 seconds. So just you keep in mind, and when you run something in a Docker image, it will be a better for the inference. So I will pause the video and we will see the image itself after finish. As you can see now, it's just finished, and its building time it was about 2 minutes. Let's see, and here you can see. Let me just open this Docker image. I have already deleted the previous one because my space, I have no, let's see, enough space, so I have to remove it. And next time I will show you how to. So most of you, let's say, use Docker desktop, but you have the problem of the C drive is full. So I will try to show you next time how to move this Docker into another drive. But let's just focus now on this. And here I have the image itself. I mean the image, and I can go here and run. We will see how to run it also in a command line. And let's see, just go to the files. The files is identical to the same as the previous one, but here we have NumPy NB, and here's the ONNX, only ONNX. And let's see if we can run that. Localhost, it should be 8080. I don't know. Let's say run it from the C. So as you can see, fast API, you can see the image itself. And here the bot was 8080, and the image, the image name, it was fast AnomaVision, and the tag is numpy. So you can see, I'll just copy this, do this again, run it only here. It's fine. Unable to find an image with the latest. Which is the latest? It's not copied, everything. Noma Vision NB. So let's refresh this page. No idea why it's not working, but let's just see here. Now, fine. So let's delete this. This is a container, so you can delete it. So run, you can see it will give you this. Now let's run our Streamlit, called Streamlit. So this will give us, can't connect to EBI. Okay, yeah, I got it. Because I will try to parameterize this, because every time we need to change this. I mean, this is only, it came to my mind when I got 9 gigabytes, which is too much, and I said I need to let's see, minimize this. So now I will run it again, and it will listening to this, to port 8080. Now you can see it's healthy. Go to the data sets, maybe here, bottom images, contamination, this for instance. Because for the first run, it was 90, let's see, 1 second. And you can see this is the heat map, and this is the boundary visualization, or let's see, localization. Let's do it again. And with this image, as you can see, it's 34, 94. Yeah, it's like almost the same as the previous one, right? So, but when I tested yesterday, it was 19 and 20 millisecond, or let's see, 200 millisecond. Okay, let's change the images. Yeah, anyway, this is the how to let's see, minimize the image. You can see here, this is the image size. It's less than 1 gigabyte, as I have promised. That's it for today, and yeah, see you next time, and thanks for watching. After implement your, let's say, fast API and made this Dockerization, and you have to ask yourself some questions. Is your fast API apps really ready for production? How many users can it handle before it crash? And are, let's see, your endpoints optimized? And in today's video, we will go, let's see, to do some, it's real test, and we are loading test our fast API app running inside a Docker using the power, let's see, of Locust. I have also mentioned it last time, this one here. And it's a modern, scalable Python-based performance testing tool. It's really ready to simulate real users and also expose real bottleneck in your end fast API. So let's see, we have already our fast API. We have already an image of our fast API. Now let's try to run our fast API. Let's just open a terminal. Before this, let's go to the low cost. So we have to also to install this. Uh, before you need before you run this, you have to add, let's say, to install Locust, which is, if you have, let's say, cloning my repo, it's already installed, so it should be here, Locust, yeah. So if you just cloning this, it should work in your side. And by end of this video, you will know how to set up your Locust for Dockerizing fast API, simulate maybe thousands of users hitting your endpoints, but I will try with 10, let's say 10 endpoints, maybe 100, because my notebook, it's not that powerful, I will say. And I have no GPU here. Everything is running on CPU. And also read live metrics and discover performance issues, both maybe your backend reliability with real data. So as you can see here, this is our locust file. And in this case, I will try to call this. This is a task test interference. And here I have, because I'm using images, I will just add generate random image here and save it as image and send now the buffer with the client. Here you can see here, send post predict and the file and also the parameters. Now we will see how to do so. So let's see, I have this image here. Now I need to run the Docker image. So then we need to run the locust file. So you can just maybe, I think it's fine here, like, so you need even without this, I think, but we need to copy this for the next time. Let's see. So you can just run this without, and it will open browser. Let's see. I mean this one here, link. Oh, it. So now I can see here how many users would you like to test. I will just take 10 for that. Let's see, every 2 seconds, and you need to identify the host. Our host is localhost, and if we now click start, let's before clicking start, let me just do this to check the Docker statistic. So you can see here, this is our fast API. It's used 20% of the CPU, 125 from the let's see memory. And when I start now, it should be, let's see, jump to, I don't know, maybe 100. And you can see now, let's see, just resize this. And you can see here, this is our host. This is the status. It's running. Number of users is 10. Frame per second, rate frame per second is 31, 33. And there's no failure, let's say, in endpoints, because we are just testing only one endpoint. And now if I just go to the chart, so you can see this is the total request per second. And here, for instance, it's testing already 30 per second, and it is going down. Now the most important stuff for us is number of users, which you can see here is starting with 0, 2, 2, 3, I mean till 10. And you can see it's fixed now. It's 10 users for each request. And this is the response time for this 50%. I mean 50% of the time it was, let's see, 300 millisecond, 400 millisecond, which is, I know it's bad, but I'm not using the GPU, and also everything is running here in my PC in notebook, which is, I will say, it's not that high performance. And I mean the 95th percent, it's let's see, more than 600 milliseconds. And here you can see it's going up and down, and it depends on the test. I mean the number of users we have. Here we have only 10. And if your PC is, let's see, powerful PC, it will, you can see, for instance, number of users is fixed, and response time, it might be just a little bit down and up, but not like this. And you can see here it's 900 milliseconds. It's almost 1 second per, let's see, per image. As I said, it's not that good, but it's uh, it's good. I see, you can see here, this is the output of this printing. And yeah, let's see the CPU, it's not 700%. So you can see it's jumped, and it means everything is running okay. Maybe the running time it's not perfect, and this because I think it's related to the resources of the PC that I'm using. Now, next time when we, let's say, train our model on the cloud, and we will Dockerize this and save it as a registry in the registry. Now we will try to run this fast API on the cloud, and try to test it from here. Let's see, using Locust, and we will see what is the performance, and we can see, let's see, we need to improve on it. And by the way, I'm using now, let's see, the fast API with only NumPy. So if I'm using now the Tosh as well, so this will increase the time too much. So that's why I like this. It's fine for me, and I mean, of course, I have no GPU, but Atlas is working with no issues, and this time here is expected. The running time is expected because the resources. Let's see. Now here, so after testing this, let's see, as you can see, are certain endpoints slower than others, because here I have only one endpoint. If you see here, I have only testing one endpoint, which is predict. You can also test the other endpoints, which is, let's see, if you see it here, if you see, we have predict, health, config, model information. You can test all of these endpoints, and for this you can get a separated, let's see, graph. And what about, let's see, the time, the CPU and RAM? You can see it here from the Docker image, from this. And now, because I'm not using a powerful PC, I'm not quite sure is it fine or not. But I will say it's not fine, because the running time, it's taking too much. Let's say the latest one, it's 200 milliseconds. With CPU, I will say it's fine. I mean, 200 milliseconds. Let's see, even half a second, it might be okay. So yeah, I mean, once we have testing the Kubernetes, we will see many, let's say, graphs, and we will see the CPU, GPUs, and everything. I will test everything in the Kubernetes. And stick around. I mean, see you next time. Hi everyone. Last time we have seen how to create the Azure components using the Bootstrap pipeline. So you can see here, this is our pipeline. So I would like today to show you something, let's see, uh, which is interesting. Uh, as you can see here, I have created this workspace. Now let's go to the workspace and see what's inside. So let's check our data here. So we have our data images is here, and let's see, explore, and we can see some images here. So it's just taking 50 samples, but the others are here. Let's see, in data store, and let's see, browse. You can see it should be, no, in a default, sorry, data store, browse, and you can see this is the upload. This is the environment. And here's the images and I mean the training, testing, and evaluation. And I will show you, of course, how to get access to this. Now let's see. This is our data, and this is the environment here. And in today's, I would like to show you that the 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 the, the best way, let's say, to create an environment is to use the Docker image, a Docker file. So you can see I have the Docker file, the Docker image, and here I have the let's say the dependency or Conda environments. Now to create this, you have to use this command here. You can see Azure ML environment create, the name of the environment, the version because it's now at version 1, and the build context. We have to use the environment folder here, which is Docker file, and you can see Docker path is a Docker file and the rest. Now it will try to, let's see, build, because now it's still running, and when it's finished we can see it should be successfully, and we will be use it to, let's see, in our training. Now last time I have shown you that we can use this method here with directly using the environment itself. I mean using the Anaconda itself, Conda file, and without any Docker file. But I have just detected that some packages like NumPy or maybe scikit-learn, they depends on some other, let's say, let's say, dependencies, which is, for instance, you have to download this, install this in the Docker in the machine. But to install this in the machine, I have to use this uh, Docker file. Now let me just show you this. If you see, this is the environments that created by Microsoft. And if we see anyone here, anyone like, for instance, this one here, and you can see the context should be context here, still loading, and you can see they use Docker file, which is, I will see, it's a it's a new, let's not it's a new it's new, but it's more efficient to use the Docker file. And yeah, this is just to show you how to create an environment with a Docker file. That's it for today, and see you next time. One, last time I have shown you how to let's see, add another, let's see, repo in one repo, for instance, to make it easy. So I have this repo here, industrial anom annotated, let's say, MLOps. This is the one repo, and in this repo I would like to use this repo here, AnomaVision. So now what I have done, I have, let's see, git add sub module and give the link, and this will add, let's see, our stuff to. I have also shown you this, so you can see it in this cloud here, in this. So now when I click this, it will directly move to the original, let's see, repo. So now, but when we try to build the pipeline, this won't work. So we have to add a small trick. Otherwise, the source and AnomaVision will be empty. So we need to catch, let's see, to get this repo here, submodule. And in this one here, I have added this. So what you have to do is use to add only these two lines. I mean, these few lines. So here's a check out, which is self, which is checking out the repo, this one here. I mean, this repo here. And submodules, we also need to check this. We need to use submodule as well. We have to use the credential. We don't need to use the credential because it's all both, I mean, in the same DevOps. And here we need to ensure that it fetch the depth 0. And here we add only this one here, this command. This will save our, let's say, life. So this get submodule update initial and recursive. And if I show you now the repo, what I mean by this. So this I have the build agent in my side. So you can see now I have the source and here the vision, AnomaVision. Without these lines, AnomaVision, this folder here will be empty. So this will be empty without these few lines here. So please keep in mind that if you have submodule, you have to add this in each pipeline. That's it for today and thanks for watching. Hi everyone. In the last video, let's see, we have learned how to create the Azure components. And after creating the Azure components, what is the next step indeed? So in the next step, after creating the Azure components, let's see, environment, workspace, and etc. Now, I'm assuming here I would like in this pipeline in this pipeline CI/CD pipeline, I would like to create a complete end-to-end pipeline that will let's see, starting from validating the data, unit tests, deployment, and etc. Deployment in the Kubernetes. Now, let's just imagine you have your code. Now you'd like to push these changes to the Git. Now, the first step to do is unit test. So you have to test your code. Is it is everything is fine? Is let's see, you have to test every function with by test. So this package is by test. I will show you how to do tests. Let's see, using Pytest. And if your code is working perfectly, we have to go to the run data validation. Before the training, we have to check, do we have the data? Do we have the structure of the data? Do we have the right data? Let's say the images or maybe the CSV files or maybe text files. So we have to check, do we have the right data to the training? If so, yes, we will go to the training. And if you see here, this stage here, it depends on the run data validation. If the run data validation is failed, so the training model won't be let's say triggered. The pipeline will be stopped here in the run data. So it will save, let's say, time and also resources. Now, assume that the training or the data validation is fine. Now we have the training. Now we have to train the model, right? And we need to validate the model. We have to test the model, and let's see, we have, let's see, some to save some test data that the model has to give us this result, and this we need to validate the validate model. And you can see validate model, it depends on train model, and every step it depends on the previous one. So as I said, just to avoid mistake, let's say not mistake, but let's say resources and also time. Now, after validating the model, we have, let's see, I train the model and I test the model and I get the expected result. So now I said everything is fine. I have to test now. I would like to now to test the model itself. So I have what I mean by testing the model, by using the data, for example, validation. Let's say using the images and also the class label or the mask, and I will see to calculate the performance of this. After this, if the test model is succeeded or passed, so we now have to go to the deploy model. So deploy model, this one, it will try to deploy the fast API in the Kubernetes, and this step will try to do step by step. I will try to make everything clear and easy, let's see, to catch. Thanks for watching and see you next time. Before merging anything to the main branch, you have to add some build and test. So this way here you will be assured that the code is 100% is working, because the whole code will be running or compiled in the build agent, which is in my case it's a self build agent, and if everything is running perfectly, it will be merged to the main branch. Then your colleagues can use the main branch, cloning the main branch, working on this let's say main branch without any issues. And the main branch has to be protected. But in this case, I will just keep it, let's see, simple. So as I said in the last time, we have to begin with the stage. It's not, it's like stages, and I have divided the pipeline. If you can see, the pipeline will be, let's see, a huge pipeline. But if you see here, I have divided the pipeline into several pipelines, and this is the main pipeline. And the templates pipeline, hopefully you already know this stuff. And you can see here, I have, please don't forget this, uh, the checkout. So these are, let's see, really needed. Otherwise, because I'm using the Git submodule. If in case in your case it's not using, but I recommend you to use it because industrial MLOps is a different from AnomaVision. So I have to add the AnomaVision inside this industrial MLOps. So you can see here I'm just getting sure that I have to get the latest version of the submodule. Then I would like to check, let's see, to use the Python 3.11, and he installed dependency. Then I will go to the template, install dependency, and I have tried this, let's see, for the Beauty to install the dependencies of the Beauty. Now, what is the advantage of splitting this into several pipelines, or let's see, templates? So imagine you have several pipelines here, and you would like, let's see, to either to use this in a different pipeline, which is super easy to use. You have to add this line, and you might have maybe to disable this. You don't need to test anything, so could be a solution. And it's, let's see, more efficient, easy to handle, and if you change something, it won't affect the whole pipelines. Now let's see, I have here installed the dependencies, and here I have to test. So I have to test, let's see, the test pipeline. Here you can see Beauty run PyTest and run this test AnomaVision.python file. So this I have created to test the AnomaVision itself. So I can see here I have the tests, and this test, it will try to use the AnomaVision and importing the PaDiM. And this PaDiM here, here I have down. I mean, let's see, data loader. It's random data loader. It will try to, let's see, create images, labels, masks, data sets, and etc. And this, it's randomly with it's not real. Let's see, the real data. And here you can see. Hopefully, if you have let's say an idea about this. If you have no idea about the Pytest parameterized, please let me know. I can let's see make another video. And here you can see I have ResNet with this some parameters, and this is a wide ResNet with these some parameters. And here the parameters, it will try to use this. Then I mean this function will be used for the first ResNet 18. Then it will be used another time for this one here. And as you can see here, I have also where is that? With the parameter here, hey, this one, where is it? Maybe I delete this. Okay, anyway, so this one will be will try to use ResNet and also wide ResNet. So it is just calculating the distance, seeing, for instance, what I do the prediction and see the score map, and let's see the checking the input and output of this of the algorithm. And here we need to evaluate. We can see, for instance, I have image, labels, data, and we have to check the inputs and the outputs. I mean, there is no real data here. You're only testing the structure, let's see, or the behavior of the AnomaVision. And once I have this, I will try to publish. You can see not publish, but you can see here any changes in the main branch. So this is the main branch, and here's the main branch. Any changes here, the pipeline will be triggered automatically. And as I said in the beginning, main has to be protected. And if you need to add any code to the main, it has to be through the pull request. So I have discussed this in some videos in the DevOps. But for now, I'll just keep it simple. And let's see, let me just show you the pipeline when it's running. It can show you here some test cases. And you can see here number of test cases is 6 test cases. You can see, so for instance, 1, 2, and 3, right? This is the 3 test cases, but each one has parameters. So it will, this function here, or this test case, it will run 2 times, and this as well 2 times, and this as well 2 times. So it means in total 6 test cases. Now you can see his past. You can see, for instance, what are the test cases you can see, and also how much time this, for instance, test cases was taken. And you can see if there's any error or something like that. So this is how to show you how to write the efficient pipeline. And in the next videos, we will try to add the different stages in this, and we will try to build the whole pipeline in a YAML file. That's it for today, and thanks for watching. So we are now in the stage 2. So the first stage is set up, let's see, stage, which is, let's see, install the Python, updating the submodule, install the dependency, and then I mean the third stage. And the next stage is run test. We have already seen it last time. Now we need to validate our data. So what I mean by validation, so here we already uploading some data. You can see maybe in this one here, here's bottle. Now before the training, we need to make sure that the data itself is already exist in this format. Let's see. And here I have already update. Let's say this is the validation YAML file. And if I go now to the YAML file, so you can see, let's say this is just to remove this, it's not needed, or maybe just keep it, because if I now submit, it will trigger the pipeline. Now you can see I have the job, and the it's called data validation job, and here's a display. Here's this our important. We have the subscription. It's MLOps anomaly detection, which is the connection between DevOps and Azure pipeline. And this is the command to create a job. And in this one here, you can see data validation job. We can go to the data validation job, which is the same. It's like a training, but here is we are using the data validation. So you can see here it has a command, and the command, it's activating the environment, which we have already defined it here. So you can see this is our environment, which is version 1, I think. Yeah, version 1. Now you can see I have used AnomaVision version 1, and this is validation. And validation has input, I mean the directly to the data, and also the awesome outputs if it's succeeded or not. And here you can see this is the compute. We have to define the which compute, let's say, to run this experiment. And here we have input, and this is the output. And now if you go to the data validation, let's see which is in a source. Where's the source data validation? You can see it, yeah, here. Now you can see I have, let's see, starting from the mean. So I have the input data, which is it's required, this parameter is required. And now we need to validate the structure of this data. So the structure of this is data has to contain train this ground truth. And let's just check if this already exists. Let's see, check the directory if okay. And the next one is to check if there's any let's see, images in the directories. And now we need to see if the result is just saving valid or not, succeeded or not. And let me just show you the output should be like passed like this. Now, now to run this, we have to, let's see, run this pipeline here. And this pipeline, when if there's any changes in the main branch, this will be triggered automatically. It's wrong, but because main branch has to be protected and we have to make a pull request. But let's just make it like this. So now if you see here, when I run the job, this job here, you can see it's completed. And let's go to the output. You can see that the name is data validation for empty dataset. And you can see validating the data structure is data validation is passed. So everything now is successfully. Now this this step here is already done. Now what is the next step? The next step is to train the dataset, let's say train the model on this dataset. Now we say everything is fine, we can start our training. So we can see it, we can see do it next time. And yeah. Hi everyone, welcome back. So as you can see in this pipeline here, it's like set up the environment, run the unit test, and data validation. We have seen it last time. I mean, all of these processes we have seen it last time. And in today's video, we'll focus on training process. So after validating the data, so we have, let's see, uploading a data set, images data set, and now we need, before the going to the training phase, before the, let's see, crashing the training, we need to test if the data is valid. So let me just go to the data validation for the training. Before that, and here's this is the pipeline. I'm adding every stage. Yeah, by the way, it's stages here, and you can see if anyone is broken, so you can fix and just run the let's see, the broken one. So you don't need to rerun everything from scratch. What you already, let's see, has a problem, you just fix and you can run if it's not triggered automatically. And here, for instance, we are focusing now on the training model. So as you can see, I have add a template, and just to make the pipeline is short and let's say more clean. And they have create pipeline template pipelines, and we can see now in the pipeline, the training pipeline, and here this is our pipeline. It's a command, CLI command, and you have here the subscription variable. I mean the Azure subscription, and also we have the variables. It's already defined in the main pipeline here. Now let me just close this. Now you can see here I have this file is job and training job, and here the resource group. I mean resource group and workspace. And this is let's see, more interesting. Why is that? Because let's say you are training the model, and after training the model you need to validate the model, and without this stream it will just let's see, how's it working, this command? It's just creating a job, let's see, preparing the job, and it will be running in the background. And if you without this stream, it will exit. I mean, if it will prepare let's see, the environment, and exit the stuff, and the job creation will be running on the background. And if you use this model after this, after before, let's see, generating the model, it will give you error. Now we force the system to stop, not to stop, let's see, to be in this process until it's finished, and after that we can, let's see, use it somewhere else. Now let's just see the training, the jobs, and we have to find to see the training jobs. Let's see here. This is our job, and let's go step by step. I would also to show you let's see after that. So here, this is the name of the training. So unfortunately, it has to be unique. So if you rerun this, you have to give another name. And by default, the Azure ML, it generates a random name, and it will save you maybe time. Sometimes it, let's see, it's crashed and we need to rerun this. And now this is a description display name. It will be displaying. I will show you now. And this is the experiment name now. Experiment. It has the a job inside. So, and the source code, the code it's inside the source, which is in our case this one here, source. And I'm activating the environment. What is the environment here? The environment I have already uploaded. Let's generated or created. You can see here I have, this is the environment, and this is generated by Microsoft, and this is generated by me. And you can see this is succeeded, and you can see the context is Docker file and Anaconda file or YAML file. Now let's be back to this. Now I will run this training. I have already shown you last time when I run it. I train it. I mean, run it in my PC, local PC. So you can see now this is the train file, which is I can also show you. So this is the same file I have trained last time in my PC, just to make sure that everything is running correctly. And with the train, no, I need a job. Let's see, this is job. And here, this is the environment. And where's the data here? The data is taken from the data I have uploaded the images, which is like in this data here, you can see this is our data, anomaly images. And this is the anomaly images and version 1. You can just copy this file, this name, and it will have access to everything. Now the compute, of course, we need to run this in a computer, or let's say a machine. We have defined it as this one here. Everything, I mean, everything is already defined, let's see, in the previous videos. And here, this is the most important stuff. This command or this lines here, it took me, this error here, it took me 3 hours. So because Microsoft is always changing the updating, making the updating, making changes in the code. And when I use CLI version 2, it's already in, let's see which version now. If you see now, which is, I just to show you what is the latest the latest version. So you can see it's CLI 75. So everything now is they change some many things here. And when you see here, yeah, I would like also to show you the YAML file, which is this is a version 2, and also here something the same, I think, but I don't know why. So you can see this is the YAML file that we have created our job. This one here. Why it's closed? This file here, it has to be identical, not identical, but you can see here this schema, type, the name, display name, experiments name, and environment code, everything. I mean, I have included what I really need. And after the training, we will see what's happening. So let me just see now the pipeline. Hopefully it's running without any issues. Yeah, so this what yeah, so now it's finishing the validation. Now it will do the training. So once the training is finished, I can just show you the result. So instead of wasting time, So let me just pause the video. Okay, so as you can see here, the training process is already completed and it took 14 minutes. And why it took 14 minutes? Because I have added this with the training here. The training was using the stream, and without a stream, it will, of course, it will show you the 14 minutes, but it won't stay in this job without a stream. And let's see what is the output here. And you can see, let me just go to the jobs. I have, this is for the environment, this is for the validation, and this is for the training. And if you go to the training pipeline, it was completed. You can see completed, and it has created on this time 5 minutes. Okay, why it's 5 minutes and compute duration is 5 minutes. Yeah, this is the name of the this job. Why it's this here? Because I have identified in this file here in the training job. I have can see training AnomaVision. And okay, so you can see here now I have the, but if you see here the model is not registered in the models here. So now we need to register either from here. You can just see from the output of the job. If you can see here, and you can see this is the data that we have. I mean, this is the job that we have created for the training, but I need to do it in the CLI pipeline. I mean CI/CD pipeline, and you can see. Let's go to the jobs again, and this is complete. You can see here now the output of this, but now we need to. This is the output of the model. You can see it's ONNX model. It has to be ONNX. If you go to the data workspace, and it should be in Azure training model output, and you can see PaDiM model, ONNX model. But I mean, see, it's a long journey just to get the model right. So we need to register our model in this models here, and after that we can use endpoint, or maybe you can download it and create, let's see, use I mean use fast API with the Docker image and register it in a registry, and we will see all of this. But in the next step, we will see how to register our model in this models. Thanks for watching and see you next time. Please, if you like this video, please subscribe, like, and also add comments if you have any question. Thanks for watching. Hi everyone. So after the training, we need to register our model in this region here. So what we have to do is running this pipeline, and I will show you in a minute, in a second. So let me just see if it's running. Hopefully there is no issue, but we will see. So now this is the pipeline. Let me just close these pipelines. So this is our pipeline. I just commented this because when I run this several times, it took times, and one more issue, which not issue, which is the training here, as you can see in the training, no, in the job, where's the job? I can see it. In the job, I have defined this name here, which is uh, let's see, unique, and if I run it will say it's already exist. So I have just commented these lines. Now I'm just trying to upload, let's see, register the model in the models. Let's see if this will appear here, so I can explain what is inside that. But yeah, it's fine. I mean, hopefully it's working now. After the training, we have seen where the model is saved. It's saved in somewhere else in a data store, and it's hard to, let's see, go to this or download it or maybe use it. So the idea is to register this model in the models area. So this will after registering, it will be used, for instance, for as an endpoint. And but in our case, we will try to download this model and run it via Docker and FastAPI. But this is in case if you would like to use it as a score. So if you remember, if you see here, when I started this, I have I have added I don't know, is it deployment? I think, yeah, here's the deployment. And you can see this is the score. If you would like to use the model directly, you have to write the code here, as we have did it in the first API, and just use it and return the result. But in my case, I will not use the score. I will use fast API. But let's say just let's have okay, it took. So I mean, if if the time is, let's see, okay, let's need XML extension, but we will see. Now you can see here I have in the training I have this name here, the the job name, and this is the ML model create, which is register the model in the registers and the models, and here's the name, and this is the version, and the path safe the path of the model. It was in the job name output and model output, and type it's a custom model, which is ONNX. It's not, let's see, ML or MLflow or something like this. And this is the description, resource group, and workspace. And let's see if it's, I don't know why it's talk time, but let me just pause the video and let's see, wait until finishing. Okay, so our pipeline is now working, and or the model, it should be already registered in the models area. This is our model, and you can see here this. If you see here, this is was the job, and this is now our models, and you can see our model is here, and you can see the model, the versions. It was only version 1 artifact. You can see it has PaDiM model ONNX, and you can see if you already use it in a endpoints. Here's the jobs. There's no jobs. There's no data. There's no feature set, and etc. So now this is our model is here, right? And in the next, I mean, in the next, let's see, logic is to use this model for the prediction. So what's that mean? We need to create endpoints, and if you see, we can create, for instance, endpoint from this model here. So, but I don't like to have this. Our task or our goal, let's see, is to use uh, Docker and FastAPI. And we will see now this is model, and we would like to download this model and put it in the directory so the Docker file can read this. So for instance, if you go here, this is the projects and Anomaly, Anomaly, and you can see now source. The models should be, let's see, where's the fast API. This is the fast API, and it's load the model, and I think the model should be okay. It should be in the root directory. Alles klar. So the model should be, let's see here, and I think I have one. Yeah, this one here. So now I need to replace this, but we need to download the fresh model. Why we need to use the fresh model? Because we have trained the model in the cloud, and we would like to use the trained model on the fast API using the Docker file, the Docker images. So we will see this in the next video, and uh, yeah, I think this is enough. Thanks for watching, and see you next time. So after training the model, after registering the model in the models area here, you can see, now I would like to download this model and For the next, for the further steps, I would like to use this model to build a Docker image. But let me now show you how to download the model. So as you see, the model is already in this register here. Now here's the command Azure ML model download. So this is will download the model in this directory. Let's see here, models. Now because I'm using stages, as you can see here, this the pipeline is consists of several stages. Now, if you uh, uh, I download now the model, and let's see the download model will be in a directory, right? In a models directory. Now, when the with the next with the next stage, everything will be deleted, and we'll start to get the pull, let's see, pull the repo from scratch. So that means I can't use the model. What is the good step? Let's see, I have to register the model, or let's see, publish the model as artifacts. And to download the model as artifacts, you can see I can, let me just show you the model. Where's the model? And you can see the artifacts is here. No, this is the artifacts is different in this in Azure ML is different from the Azure DevOps. Please focus on this. Now you can see the model is here, model output, and this is the ONNX model. Now with so I would like now to register the model. To publish after downloading the model, it will download it in a directory. Let's see. Let me just show it. Maybe in a models, it's already removed, but it will be like this. It will be like let's see, similar to this. For example, models and ONNX models, if it's called this, and model output, and now this one here. So, but because as I said, with each stage, it will be everything clean and pull the new repository repo. Let's see. So the idea is to publish this as artifacts. Then, when I would like to use it, I will just get this artifacts again. It will be easy. Let's see, to get this instead of two times of downloads. So if you have a pipeline with the whole stuff only one stage, it would work without any publishing. Keep in mind. But my idea is to make the pipeline, let's say, more organized, efficient, and let's say I don't need, let's say, maybe this one here, this registering. So I just commented these lines. But imagine if I add these files here. See see how many files. If I put them in only one single pipeline, it will be I don't know. It won't be let's see, easy to maintain. So let me now run the command, the download command, and we will see the result. So here's the down run. Okay, then let me pause the video, and once it's finished, I will show you the result. And also, if I have any issue, I will let you know. Okay, as you can see, it's already downloaded the model, and let me just show the directory. Let's see if it's, we just refresh, and I think, yeah, we can see now the models is here. But as I said in the beginning, if now the next stage will be run, everything will be clean. So that's why I have uploaded here in this artifact, as you can see, publish artifacts, and it's now here. For the next time, I will try to download, I mean, just fetch this uh, in the directory, and now after that I can use, let's see, the Docker image to build the Docker image. So yeah, that's it, and see you next time. Hi everyone, welcome back. So after, let's see, publishing the model as artifact, now the next step is to use this model and build our Docker image. And to build your Docker image, and let's see if you are using let's see, a self agent, you have to run your Docker desktop like this. It has to be running. It's like it's the same as when you try to run your Docker commands. It has to be running. So because I'm using the same machine, also this one has to be running. But if you use Linux, it might be another issue. I mean, different stuff. Okay, so we see it now. Let's see, just close this. We have said we have published the artifacts. Now let's have a look on the Docker image. So I will just use this Docker image which is already discussed, but you can see now I just changed the wizard model. Yeah. So now from this model, just copy PaDiM model. So this one here. So it will try to copy the model from here. Okay. So let's have a look on the pipeline build. So you can use, of course, you can use Docker task, but for me, it's not indeed working because the image it's not tagged, and I have tried several times, but it's not working. So the first step now, after let's see publishing the artifacts, now I would like to download this build artifact. You can see this is task. So I will download it in the directory, and then I will run this command here. It's a normal command. Let's say docker command. This is, for instance, no cache, just to save memory. This is the tag and the file with the file, and this is the same directory. Let's see the other stuff. Now, after building this, I will you will see now the image in this let's see Docker desktop. So if now I run this, let me just move this, and let me now run this command, I mean this, and I will show you the result. And of course, if I have any issue, I will let you know, of course, as usual. So as you can see here, that the artifacts this is already downloaded. Now the command of building the Docker image, it's running right now. So a few seconds, let's see, we can see the output of this building a command. By the way, before I let's see recording a video, I have to do all of these steps uh, uh, before recording, and just to make sure that everything it will run, let's see, smoothly. And I don't want you to, let's see, be in a, let's see, hard, let's see, situation. So I have to prepare everything from scratch and solve the issues before the recording, and just record the best, let's see, stuff. Now, yeah, please like the videos and subscribe into my channel. So I will post the video again, and we can see the result. Okay, as you can see here, if you see now the logs, it's like when you build your Docker image. As you can see here, it's downloading everything, and mm, let's see, have a look on the Docker. As you can see here, the Docker image is already generated in 35 seconds. Now this is now our image, and what is the next step? Indeed, the next step is to, let's see, go to this one here. And if you remember last time, we have created container registry, and now we need to publish our image, a Docker image, in this container registry. And why we need this? Because next time we would like to deploy this in the Kubernetes, And we will see this in the next couple of videos. Thanks for watching and see you next time. After building our Docker image, now we would like now to push this image into the container registry. Now, but do we have the permission to do this? No. I will say in the beginning, no. We have to add, we have to look in to push something to this, we have to look into this. So, but how to log in this let's say Azure container registry. So now you can see I have added also this step, which is really important. How to register in this. In the beginning, you have to get the credential of the container itself, which is username and password. When you have to do this, if you have create your container, let's say container, you say as and enable admin enabled true. So in this case, you can use username and password. Let's see credential. Make it. Where is this? Here. And after that, we have to let's see log in with Docker. Log in the name of the container registry, and you can see we have added this. It's Azure container. Let's Azure stuff and username and password. But now, if you haven't used this, you have to let's see use another step, which is I have added here because but I just use true. But if it's not enabled, it's true. It's not enabled. You have to get this. Let's see response Azure login. I mean, of course, the name of the registry. I mean registry, and here you have to add expose token and then convert to the registry. Now I can see here it's access token, but in the other side it's when you have a login, it's you can just get a credential. And let me just show you. Okay, because I have no repository here, I can't. Maybe let's see. Go to the no, because you need to enable this username and password if you have already. But let me now. Token. No. So we have to use a credential if it's true, and if it's not, we have to add this command here to run this command and get the access token. And what I mean by this, if like let's see, you have created your registry with enable false, for instance, like this. Now for this, you have to run this command here, and after that, you will have to add token and username. It's the similar to this, but here it's a token and here's a credential. Okay, and let me pause the video, and once I have access to the Docker, I mean, just check if this one here, this part is really working to have access to look into the registry. So as you can see here, it's working using password. Login succeeded. So now the next step is just push this image here, this image into the registry, and I will show you, of course. I think that's it for today, and thanks for watching, and see you next time. Now it's time to push, or let's say publish our, or let's just push our image, Docker image, this image here, into the container registry like here. So let me just show the pipeline. The pipeline has to do with publish, Docker, tag, and push. So you can see here I have the image, this image in my Docker desktop here. You can see it. but here I just give it another, let's see, tag. So this is the new tag latest, and the command, it's easy, just docker push to this registry, registry here. So now let me now just run this and see how to. So it's now working. As you can see, as I said, with each stage, it check out the branches. So it means it will delete everything and start from scratch. So now you can see here. So to start in a while, but let me just close this. And yeah, so what is the benefit of, let's see, pushing this image into the registry? So we can now, I mean, after a while, after that, we can use the. It's finished. Okay. So we can use this image, I mean, deploy this image into Kubernetes. Let me just see if everything is pushed. Yeah, everything is pushed. Now let me have a look here. Just refresh. Yeah, now with our image, let's have a look in the surfaces, repos, and now we can see our FastAPI AnomaVision image. So this image here will be deployed in the let's see in the Kubernetes, but this will be next time. I haven't prepared this till now, and I think that's enough for today. And thanks for watching. So we have trained our model, register, download, also building Docker image, push it also to the container registry. Now we would like to deploy this image into Kubernetes. But wait, our workspace can't pull this image from the ACR. So let's fix this in 2 minutes. So today I will show you how to give machine learning workspace, let's see, a permission to pull Docker images from your Azure Container Registry. So with just few lines of Azure, let's see, CLI and DevOps pipeline. So let's first go to this is our pipeline. So it's a stage, and I was, let's see, move to assign pull request. So in the beginning, you have to go to the workspace, get the identity, and we need the principal ID. So with this one here, we will get the identity, and from the identity we will extract the principal ID. Now for that we will just for the we need the scope to give a permission, and here we have assigned this is the container registry, and here we have created A0 assignment create assignee, which has to be the principal of the workspace. Then a role is ACR poll. So without this, we will not be able to pull the images indeed. And this is the scope we would like to give this role. Let's see. And we one note here. It's let me just copy this and search who is this, because so now you can see it's trying to get the workspace, which is the workspace I the principal. ID. Can't see it, but let me just copy the other one. It's identity. So I prepare the commands here, and if everything is running perfectly, so I just now sometimes you have no identity type as a system assigned. So let's say you have already created workspace with the default setting, and you have no permission. Let's say this is not by default. So now you will check if your workspace has identity and principal ID, then this should work here, for instance. So these. And if not, you have to update the workspace with set identity type system assigned. So with this, start with this and following with these steps here. So this will give the a permission to the workspace to pull the image from the registry. I think that's it for today, and thanks for watching. Hi everyone, welcome back to my channel. So in today's video it will be let's see, interesting. So as you can see, this is our pipeline. Let's see, I have different stages and also different jobs, of course, and you can see every stage it has to be depends on the previous one. So if something, for instance, happen in this data validation job, it has, I mean, the next one, the next jobs have to be stopped because the previous one is already, let's say, cancelled or has error. And you can see here I have validation, training, downloading building the Docker images, and also push it, this is one, push it into the registry. And now we have get, let's say, put some permission to pull the images. And let me just show you here. What's this is running? Yeah, it is already completed. And let me just show you here. This is our, let's see, registry, container registry. Now I have, if you see here, repos, I have this fast API, and this image here will be used inside the Kubernetes itself. But bec- because I would like to test this locally in my PC before, let's see, creating Kubernetes and everything, because also the Kubernetes is already defined here. You can see in this one here, but it's still commented out. So indeed I need the code itself. So this one here, infrastructure, post, bootstrap, and you can see this, for instance, starting to creating, yeah, starting to create AKS or Kubernetes cluster. And this, for instance, 3 commands or 3 tasks has to be created if we would like to deploy the images inside the Kubernetes. But as I said, here we have all our images here, and now I would like to test this locally in my PC and see if everything is working correctly. So here you can see there's no boots. Let's see, boots. And this I'm using now Minikube. And if you already use Minikube, so this you have this is locally. And let me just in the beginning you need to access easy access login login and name, or maybe you can use even n, and we need the name of our repo. So the name of our repo is this one here, and see if we can get access to this one here. Okay, because I have already did that in the beginning, so I mean in after before minutes. So let me delete this so we can see we start from scratch. And there's no container, of course. Now you can see login is successfully built. Now what is the next step to work with this image here? with this fast API Anoma, we need to get this image. I mean, pull this image locally, right? This is makes sense, right? And we have how to do this. We can see docker pull, and I think the name dot. We can see you can just copy it from here. Latest, and we can copy. Yeah, just copy it from here and just replace it. Pull, and you can see we have already access to this, and we need to get this image from here. So if you see now, we trying to pull images from this, and after a while we will see it will be stacked here. So without access, let's see, if you filled into log in, you will not be able to pull this image. You have to pull this image in the beginning. So this might take a while, but and if you see here, I have the where is it? Go back. Now the tokens, and I have, for instance, generated some password. We will see how to get these passwords. Okay, so now you can see. Let's see. I have it here. So the images or the images. Just let me. Why is this like this? So as you can see here, this is our image, which is pulled from the Azure container registry. Now, how to run this? So the easiest way is to run that with let's see with just run you use the cube ctl run, and we can see AnomaVision, just the name of this, and image. We can identify this image here. We can use this image, and the image now is, let me just use this because it's you can see this is the whole name here. This is the image name. If you can just take this copy. Yeah, you can copy it from here. Just copy the whole name, and we can see restart never 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 kubectl. What's this? It's not recognized. Cool. Okay, so the wrong here is in the command itself. So oh okay, I got it. It's CTL, not CLT. CTL. And let me just clear this. And if we get boots, we can see we have our boot here, our boot. Now, how to run indeed this? I mean, yeah, of course, I have forgot. Sorry for this because I already applied this. Otherwise, it won't work indeed. So let me just try, because you need. Let me just copy some commands from here, and of course I explain it. Now I have easy. I mean easy for the registry. Show the credential for this let's see container, and I have the resource group is this, and in a JSON file. So you can see I will get the credential in this variable here. I can just show you, but I will delete it in a while. after that. So you can see this is the password 1 and this is the password 2. So now we need to give a access, let's see, to give a credential for the Kubernetes. Let me just, because we have already this one here. Now if you see the password, the value of the password will contain something. As I said, I will delete everything here from after this lesson, so no worries. So now we need to create a secret. Let me just copy. Because it's already exists. Yeah, So because it's already exists, so I have created this before the lesson. But you can do it as with this. So you can say create a secret, Docker registry, AC secret, and the Docker server, which is the Azure ML. I mean this one here, and the Docker username. It's this the page. I mean the name. Here's the password. We just get it from the last one, and this is my email that you have to access the the Docker image, the Docker itself. So you can see, for instance, you are logged in here. Yeah, for instance, here. This is your. You have to be logged in. So because I already this is needed indeed. This you have to do it. So let me now get kubectl get boots. Now we have our boots. This one here, right? So how to run this? I mean, of course, there's several ways how to create boots, and we will see some advanced topics. But now we see kubectl and bot forward, and I need to get this image here and 8080. Where to get this 80 bot forward post? Yeah, this is right. Port, yeah, port. It's port, niche post. Unable to be forward from pending. Why is that? Okay. I forgot, for instance, this one here. It has to be boards. Now, this board is not running. Okay, yeah. Sorry. I have to run this. So let me just copy this command. It's already running. It's created. And we can get, let's see, cube. Let's see, yes. Cube get boards. I have to now. And with that is there's error here. So let me just delete it. kubectl delete boards. It has to be deleted. Now if we get boards, we have only one, and it's not ready here. Okay. Clear. Okay, let me create. Let me just delete this. Get boards and delete. I will run that with the with the file kubectl c deploy. So I will show you the file, and you can see this file here. It's API version v1, and the most important thing is container name and not container name. I mean the image which is taken from the, of course from the Docker image because we already pulled this, and this is the bot. And if I see now, I would like to use this file here, this one here. So let me copy path, then kubectl create file, then get ports. Now it's ready. You can see it's 1.1. And to run this, let me just go to the inside this, or we can we run this? It's AnomaVision. Let me just, now you can see now if I open this localhost, it should be running, right? And if I just kill this process and refresh, there is no localhost. You can see it took time. Now I will just run it again, and you can see it's starting. Now if you see, I can see the docs. And for instance, I need to predict. You can see here. So we can try it, for instance, from here. Try, and you can see choose the file, and let's see here, and we can see the output should give us the output. Yeah, execute, sorry. And you can see the anomaly score is 29. Anomaly is true, and this is the image. It's what is returned from. It was 2 or 3 images was returned from the API. But let me just do it with another. Let's see, with a Streamlit. We have already done that last time. So let's see Streamlit. Okay, I have it here. Or maybe you can start from scratch. It's the same indeed. So let's see, upload the image, and you can see this is the result, and this is the anomaly detected. And as I said many times, 1 second it's too much indeed. And if I see without no with no visualization, it will take, let's see, less time. You can see. But without visualization, it doesn't make any sense. But yeah, let me just see this. And you can see this is working from the container, the Docker image. And the Docker image was pulled from the Azure GitHub, from the Azure. Now let's see, let's see here. I will just kill this process, clear, and let's see if you would like to go to the image itself or container itself. So you can see kubectl, or maybe logs. Let me just get puts and logs AnomaVision. You can see the logs of the AnomaVision. And now let's see clear. If you would like to go inside this image, with execute, and this is input, input, and this is terminal. I input and T is a terminal. And now I need AnomaVision, then bash. So you can see I can access the file. See how many files do you have? We have this one here, the model, and also static. And you can see ls, for instance, static, ls static. So you can see the files that we have, for instance, visualization, the files that we have. And of course, you can run it from here if you want. But let me exit. Now, this is, let's see, only one board. If we see get one boards, and if I delete this, let's see kubectl instead of get, we can see delete boards AnomaVision is deleted. Now we can see get boards, no resources. And this is, let's see, bad. Why? If imagine that you are working, let's see, Amazon, for instance, if someone is deleting one board, that means the system should be down, right? But with this definition, it's not, let's say, the optimal one. How to do this? How to do so? So you can see here with deploy, and you can see here the kind is deployment, and here the kind was boot. The kind is deployment, and the most interesting part is the replica. For instance, you need 10 version of this AnomaVision, let's see, 10 time, I mean 10 boots, and it will run on the same time. And you can see if I now run, let me just copy the path, cube cube kubectl create file, then we need to paste this file here, and let's see git boards, and you can see how many boards we have 10 boards right here. So imagine if I just would like to delete this. Let's say I would like to delete this one here. So delete boards, maybe let's just try to delete 2 or 3 or 4, and maybe this one here. Hopefully this is right. Now boards, what's this? Not found. Clear get boards. You can see 1 2 3 4 5, and get, let's say for instance, get deployment, and this is the deployment that we have here, which is from this 10 times. And of course you can reduce it to 5 with, and now you can see instead of create, you can see replace get boards. Now it's 5, and this is just to check if everything is working correctly. And let's see, I mean, in the next step, I will try to push everything to the Kubernetes, and all of these commands will be done, let's see, automatically with every push and with every step. And maybe one hint, I mean, I just did that in purpose, because you can see here is it pipelines. With every run, with every changes, even small change, this pipeline will be running, and you can see here several stages. And this has to be only for the release. When you have, for instance, in the DevOps, you have several branches, right? Main branch, develop branch, feature branch, let's say, release branch. And this pipeline has to be run only on the main, or let's say release branch. So what I mean by this, imagine you have changed, for instance, one line of code. This pipeline will take much time just to run. And the problem here is it will try to generate uh, AnomaVision, for instance, let's say container registry, another image. And for this image, it will be replaced with the original one. So the last one, maybe it might be not working perfectly. So this we will see how to control of this. I think that's enough for today, and I will see you, let's see, next time. Thanks for watching. So after pushing the image into the container registry in Azure ML, now we need to deploy this image into the Kubernetes. So in today's video, I will try to show you, or let's see, go through the two critical stages on ML pipeline. Attach your Azure container registry to the Kubernetes service cluster and deploy your containerized machine learning, let's say, model from Azure container registry to AKS or Azure Kubernetes Service. It's AKS. It's easy to see. You can see it's Azure Kubernetes Service, and we will try to we will explore how and why we need this, and what is the advantage of this. Let's see this step. Let's see attach container registry into the Kubernetes. And one, I mean, because we will not go, let's see, further with this let's say pipeline, or let's say this row way. Why? What is the disadvantage of this? So the disadvantage of connecting or attaching the image itself to the Kubernetes, it's no built-in machine learning monitoring, so no model drift, data drift, performance matrices, and no EB testing capabilities, and also manual scaling management. But I will show you how is this working, and in the next time I will try to use creating online endpoint and deploy endpoint. But let's just sometimes some guys are, let's say, interesting in such stuff and might be interesting for someone else. So so now our journey now, it's begin with attach, let's see, Azure Container Registry to AKS stage. So before your cluster, let's see, a Kubernetes cluster can pull a Docker image from the registry, a critical connection need to be established. This is, stage ensure that a cluster has the necessary, let's say, permission to authenticate with the container registry and retrieve your containerized application. Yeah, sorry. So let's break this down. So this pipeline definition. So the YAML file, let's see, go to the pipeline here, the YAML, which is yeah, this one. So you can see in the first step involve updating the KS to attach the container registry, as you can see here. So we already create this key Kubernetes cluster. So if you have seen this bootstrap, it's, I think it's commented in my side because it take much time, let's see, to do. I mean to and also it's expensive indeed. So I mean, but I will provide everything to you, so you can you have to uncomment this. So this, for instance, creating the cluster, and here to install some extensions, and here you need to attach to the workspace. So this is attaching to the workspace. Now we need to deploy, let's see, the registry into this one here, attach. Let's go to the attach, And wait a minute, please. So as you can see here, this this update we already created this. We have already created. We need the name of the cluster, and it's in a resource group. This resource group, and attach ACR or Azure Container Registry with this name here, and this name it's already provided in the pipeline. For instance, in here, no, in library we have defined all of these variables here. So if we see here, we need to attach this. I mean, once the attachment command is executed, it's verify that the connection has been successfully established to this prevent, let's say, potential download. So after this, we need to check if everything is the verifying the connection is let's see, is successfully. Otherwise, it will break down here. It will be if something, let's see. Maybe happened. And finally, before moving to deployment, we need to ensure that our pipeline has the necessary credential to interact with the Azure cluster using kubectl. And this is a common, let's say, prerequisite for any Kubernetes operations. And as you can see, asked we have asked for get easy AKS get credential. This command will fetch the credential of your Kubernetes cluster and merge them into your Kubernetes into kubectl configuration. And the override if exists flag ensure that any previous configuration will be updated. And this step is crucial for subsequent kubectl commands for functions and within, let's say, this pipeline, and also allow us to deploy our application. And you can see here I have after the getting the credential, we can see CTL cluster information, get nodes, get pods, and I mean get pods is still not created. It will give you an empty. And let's be back to the second stage. The second stage is deploy this, I mean, container to the Kubernetes cluster. And with sorry, with after we let's see attach this, and now we need to deploy this image into the cluster itself. This is where the containerized machine learning, let's say, model, or let's say fast API in our case, and are packaged as a Docker image. We have already built a Docker image and push it to the container registry, and it's deployed. And we need to expose it as a service within the cluster, the Kubernetes cluster. And if we see here, for example, deploy, yeah, what's this? Deploy. As you see here, we need also to get the credential. Why it might be seems redundant if, for example, from the previous stage it's already did, but it's just to ensure that a specific job has the most up-to-date access to the cluster, especially in independent, let's say, pipeline runs. And the heart, yeah, let's see the next one here. Yeah. So the heart of our deployment lies in the Kubernetes manifest files. First, let's have a look into deployment YAML file. This file defines the Kubernetes deployment, which manage a set of identical pods. In our case, it defines how our first API based on anomaly detection, let's say AnomaVision, should be run. So let's see with the deployment. And you can see deployment. Let's just focus on on the most important stuff. And I have already, let's say, last last video explained some basic commands, and we have also run the image, the Docker image inside the Kubernetes, inside the mini cube. And you can see here the image is pointed to our registry, our ACR, and the image pull secret, the image pull secret is should be here, yeah. And the image pull secret is critical here. So it's also we attach when we attach the container registry to the Kubernetes of course, because it's a private registries, Kubernetes still need to, let's see, a way to authenticate. And this is generated during when we attach the Kubernetes, the registry to the container to the cluster. And the bot we have seen here, we can see bot, container bot, it's 8080. Where did we get this 8080? It's defined in the Docker image you can see here, expose in 8080. If you run, for instance, this here, it should be 8000. If you run something different, it depends on what you have defined in this one here. Where is it? Yeah. Okay. Now when we see kubectl apply, and this it will try to create. Well, let me just go back to this file here, and it will try to create only one. Let's see, boot, because we have a replica 1, and if you need 1 2 3 5, it just you can directly change it here, and it will try to it will create, I mean, as you defined here. And why we need why we apply use apply, not create? Because apply, it will use, if it's already created, it will just let's see replace. If not, it will be created. And that we have here, we will somehow print something if it's already created. And where's the surface? Yeah, the surface, also we need to run the surface itself, and the surface, it's somehow the same. We need now to expose our deployment application to the outside, let's see what, and this is handled by service. Let's go to the surface, and you can, the surface is named as, let's see, AnomaVision service, and use load balancer. This means Azure will provision an external load balancer with the public API address. And after we running this, we will get IP, let's see, external IP address, and we can use it. Let's see, for instance, to run it, from example, from the Streamlit. Just you need to define the host, the host and port, and it should work. So for instance, the default one we have tried several times, it's a local host. But in the next couple of, I mean, if you run the application, if you follow this path, let's see, you will need to change, for instance, you don't need to change indeed. You just give it as a parameter, the IP address, and it will be used. For instance, see the argument host. For instance, this is your IP address, and this is the port. That's it. I think it's not that, let's see, hard. And here, of course, we have the same tag IP address as we have it in the deployment. And once you have, let's see, finished this and run the pipeline, so what you have to do in the indeed just exactly the same is that you have to run the bootstrap pipeline with, you have to uncomment these two, I mean, these three tasks. So for instance, this one, 1 2 3, I think 2 3, yeah, it's only 3. This one is not needed. And if you run this, this already explained in the previous in the first, not first video, but in the previous video you can see it. It's about 40 minutes, I think, video of 40 minutes. And run in the beginning this one here, and please keep in mind that this task here will take let's see, at least 30 minutes just to build the image and push it to the register to the environment. So you don't need to please keep make sure that you see the succeeded, let's see, environment is already succeeded register created just successfully. Then you need to run this pipeline here. So this pipeline is starting from updating the modules, because we have this for instance repo here, it depends on another module. I just would like to make it, let's see, more professional and let's see more organized. And you can see I have created several stages here. And why we need several stages, the first point here is, if assume that you already run till maybe till this point here, and it's crashed in this stage here. And if you fix, let's see, you define the error and fix the error. And by the way, I'm trying to do everything from scratch before I recording the video, so I'm quite sure that this will work in your side. But of course, if you have any question, just drop it out in the comment. And let's see, assume that you have several stages, and the stage, this one here, was broken. Now, the advantage of stages, let's say you fix this, the what happened here, and you don't need now to rerun the stages here. You just need to start from here. And it depends on its need. Let's see, it's more important because, for instance, this data validation, it depends on the run test. And if this failed, so this will be stopped. I mean, nothing will be run. And this is, let's see, to keep to save your time and also save resources. Now back to this. So this I have already explained in the previous videos. Now you need to just attach, run attach, and this one here. No, we still not finished the pipeline. With deploy. Yeah, and after the services will run, you can see, and we will try to get the IP address, external IP address. And if we have already the IP address, we will, for instance, type it here as use this IP address, use the health and doc, and you can use the predict you with you for example with CURL. But of course, you can use the only the Streamlit. Just use the IP address in the host, and it should work in your site. And I think this, let's see, the most important stuff in in this area. Let's see, if you would like to use the the register image, the register image in the container, and attach it to the Kubernetes cluster. But in I will just follow the another path, which is I will try to deploy the model that I already created and create another file. Let's see, a score file. You can see here is a score file, and still empty. And I will try to create endpoint, deploy endpoint, and see. And what is the advantage of using this step here is that sometimes you have to make A/B testing. So you have two models, and you would like to test the performance of each model, and you can, let's see, decide which model you have to use, for example, in the customer side or something like this. I think that's it for today. And if you like the video, please subscribe to my channel, like the video, and if you have any question, of course, drop it down in the comment below. Thanks for watching, and see you next time. Hi everyone. So sometimes you would like to use GPU, and in my case here, I'm just using a CPU. And as you can see here, this is running on my PC in a notebook, let's see. And if you can see here, I have somehow optimized, so I don't know why it's increasing the time when I would like to show you. No idea why. maybe because the recording stuff is taking the memory or maybe the CPU. That could be. Anyway, so as you can see, this is CPU. And if you would like to use a GPU, I already provide something for you. So as you can see, let me just close this here. I will start from the pipeline with pipeline is here. So as you can see, when we create a compute, we have created Azure ML compute, but here this is for the CPU. And now if you would like to use a GPU, you need to use, for instance, this standard. This is a virtual machine with this standard size. And to just have a look on how much you would like to pay, let's say, for instance, I'm just sorting this. This is the latest, the let's say the cheaper one you would like to use. For instance, you can just use v NVAO C. You can just see. Let me. Okay. So you can see with the pipeline, and here you can just see replace this. So now standard, then plus this one here, and it's almost the same for all of these GPUs. And you can see it has, for instance, this one. If you focus only on this one here, it has one GPU M60, and number of CPUs is 6, RAM is 56, which I will say it's more than enough for our stuff here. For instance, for the anomaly detection. And plus I have, let's see, you focus now, you just uncomment this, and you have to remove this or comment these lines here, because this one is CPU and this one is GPU. So you need to run both, unless you need, let's say, CPU and GPU, two clusters. But if you just need GPU, you can use this. If you need a CPU, you can use this one here. Now let me just go to the code. I also somehow improved the code. Okay, this is just only to run the image. So now it will removed. So let me just show you the GPU requirements. So you can see here I have the already, let's see, built the image, and you can see in the last time it was, let's see, about 1 gigabytes. It's 900 megabytes, but now it's almost 2 gigabytes. Why? Because I have used GPU libs, which is only ONNX. And this ONNX here is, instead of CPU, I would like to use, let's see, a GPU. Now, this one here, I already optimized the, let's see, the code. And here, let me just, oh, we can see the difference. It would be better here. So now you can see after installing the ONNX GPU, you can just use it no as normal as the CPU. And here we would like to check if we have, I mean, the available, let's say, providers. Sometimes it might be a CPU or GPU. And you can see here, let me just move this a bit. No, I can't, right? Okay, then let's just go back to this one here. So you can see here, this is a CPU. It might be a CPU or GPU or CUDA. And in here, if it's not, if it's, let's say, not a GPU, we need to, let's say, optimize the memory here. And that's why I have seen the difference when I run the the anomaly on this device. So believe me, it was 20 and 25, 26, but now it's 40. Anyway, and you can see it still have the same result. Uh, Let me just close this. Now you have this providers, and the providers might be CUDA or CPU, and we just need to upload creating the session with the model. Let's see, the, uh, What was this here? Yeah. Okay, it's just the model name, the providers, which is CUDA or CPU, and this is the session we have created here. This is the differences. Let's see, just have a look here. You can see there is no any difference. Of course, this one here, and the rest of the code it should be the same, and that's it for the GPU. Now, what is here? Also just to copy to run how to run this, but I will just run this inside from the side from the Docker image. So I have built the image and now I run the only the fast API inside the Docker image. Okay, one more point. Okay, so now if you would like to use a GPU here as a compute GPU, you would like also to install something relevant to this to this device. So what I have done here, I have already optimized. Let's see, create a new file which is environment GPU, and you can see the difference is only ONNX runtime GPU, and this should be the same. And there's no torch here, nothing. It's only a NumPy and let's see, only ONNX, and everything is NumPy. And for here we need also to remove this, which is not needed, but I will just keep it like this. So because maybe this is not needed for the GPU. As you can see here, for instance, there's no the dependency is only Python pip, and the default channel was this one here. So it will be installed, but let's just keep it like this. And as I said, again, if you would like to use the GPU, you have to go here to uncomment these lines. Now, this pipeline will create if the required, let's see, resources, and in here what will create GPU. Now, if we would like to create the environment, we have to change this here, the Docker file, which is, oh, sorry, I changed the Docker file. What is the requirements? Requirements. Yeah, it's already changed here to a GPU if it's there. So one point, some it's not needed to have a GPU in your PC to install this. The device will see if you have a GPU, this is fine. If not, it will just use the CPU. So you don't need to install both runtime for a CPU and for GPU. Only one is enough. For instance, keep it as a GPU and it will install CPU and GPU if you don't have, let's see, a GPU. And with the pipeline here, it should be the same. And for the Docker, let's see, for the Docker environment, and environment we have, let's see, to define, is it, I have changed it as well. Okay, no, so we need to use this GPU. GPU. Now this should work. So this will create GPU, let's see, an environment including ONNX GPU. I think that's it for today, and if you like the video, please subscribe to my channel, like the video, and if you have, of course, any question, just drop a comment in the comment below. Hi everyone. So let's assume that you already upload, let's say, create a Kubernetes services and also upload images to the container registry, and you would like to get access through the what's that terminal, and it's not needed to do it in your PC, so you can do it from here. So you can just open this one here, and you can see it will open a terminal. And after installing no, after you created a Kubernetes, it will install the kubectl for you. For instance, I have no cluster here, but let's see kubectl git boots, and you can see here there's no Docker, there's no everything. So this you can look, for instance, use the terminal here instead of the stuff. So let me just show you now here. If I copy this, create resource group, and let's paste it here, and we can see it will create now our group. And you can see here, this is my subscription. This is the resource group name. I mean, the subscription is not, let's say, sensitive, but yeah, you can try to keep it secret. And if I go to now to resource group, it should, yeah, so you can see it's already created and with empty. For instance, if I would like now to create, let's see, a workspace, just copy this, and it will be maybe faster than the UPC because it's here in the cloud itself. And this is just to show you how to use the, the terminal. And you can see here, if you are using, let's see, Linux, you can just switch to bash, and you can restart, manage, and whatever you want. So you can upload also files and downloads. So that's, I just would like to show you how to do stuff in the portal Azure. Thanks for watching, and see you next time. In this file here, I'm trying to create AKS, or Azure Kubernetes Services, using CPUs. And if you are interested, let's say, to use the GPUs, you have to use you have to run let's see, this command here, create Azure, and you can see here the node size has to be let's see, depends on the GPU you would like to use. Let's see, and this is let's see, the most important one. And the next step is that you have to use I mean, run this command, kubernetes kubectl apply, and this will try to install, let's see, or add the NVIDIA device plugin. And plus, the next point is you have to have, let's see here. In the last video, I have shown you deployment and also services, and you can also use it in one file. For instance, just add this 3 hyphens, and it will consider as new file. And now if you see kubectl create or apply this file here, and it will create the deployment and how many replica, for instance, replicas here we have one, and also it will create the services. But here it's in the GPU, we have, this is our image, and this is the resources, use NVIDIA, and and yeah, this is only the, let's see, the point that you would like to add. And if you are interested, this, again, this one here, it's only CPU. And if you are interested in a GPU, you have to use this one here. I mean, just replace these lines from here and replace it with this one here. And of course, you have the ability, the possibility to use mini and max, and but it depends also on the code, because the GPUs is costly, is so try to avoid, maybe just use mini count is one, and node one count, for instance, one, and the maximum one is 3, and or maybe you can just use it maximum one is 2, or and this one here is also is required. I think that's it for today, and thanks for watching, and see you next time. Hi everyone. So last time we have seen how to deploy a container registry into a Kubernetes service. So in today's video, we'll try to let's see, to go to the endpoint path, as I said last time. So to do the deployment using the creating the endpoint and deploy the endpoint, we have to create a score file. And the score file, as you can see here, it's identical as the yeah, so as the FastAPI. So everything is, let's see, similar to what I mean the behavior of this. And as you can see here, it's similar. I have also just added logs, and this will help us, let's say, to figure out what's going on when we run our experiments, and also sometimes we would like to use this for the for the A/B testing, and this also let's see, might be needed, but it's needed indeed. And as you can see here, this is the file, and sometimes if you have, let's say, a parameters for the anomaly detection and anomaly threshold image size, otherwise it will use the default one. And in here, of course, it support ONNX, CPU or GPU, only ONNX. And here it's pre-processed image from byte image, and this one here from using the payload, and this is OpenCV. And you can just see what is the difference, which one is performing better. But I just figured out that I know that OpenCV is more faster than the pill, but I just put everything here to for you to see. And the next one here, what I have added here is analyze the image matrices. And as you can see here, I would like to look the image dimension, the pixels, let's see, statistic, mean, standard deviation, max, and etc. And let me just select this, and we will see what we are. Let's see, look. And the next one here is the important the metrics, performance metrics, which is, I will say, it's relevant to add it. As you can see here, the total processing time, the total latency, and pre-processing time. It will just show you what is the time of only the pre-processing. Also, only the inference time, and also for the creating the visualization. Creating the visualization, it takes, let's say, obviously much time, but this could be, let's say, improved by removing non required, non necessarily, let's say, jobs, stuff. And the last one is here, we need to look anomaly detection matrices, which is anomaly score. Is it anomaly? And here the score, let's see, the score threshold, and also the score map statistic. This also you could add what if you want that you will try to track, let's see the critical stuff in your side. And let me just show you the log file here. And the log file, I prepared this to log into a file, log file for instance. And this will rotation handler. It's if you, let's see, if you are logging, let's see, too much data. So in this, you need to, let's see, rotate the file. After, let's see, reaching 10 megabytes, just for instance, the file will be created as a backup. Then it will create a new file uh, and to look the data into that file. And as you can see, I think it's a log file here. As you can see here, for instance, I will log data like this, and of course, there's in the score the stuff in the score. It will be, let's see, for instance, this one or this one. Anything will be, let's see, it's critical. It will be looked in this one here. It's info, and I just this is the important one, and you can see. Let me go to the application, and you can see now this one here. It's already backup. So you can see this one here, it's 1 giga. I just have changed it to 1 gigabyte just to make sure that everything is running correctly as expected. And it's created, let's see, a backlog. So let me now, for the training, for the training, I just add the log. So it's the same as the score. And one important stuff here. So this is our, let's see, score. Now, in the beginning, I would like to test if this is working as the fast API or not. So I have created this, might be interesting for you. Of course, you can ignore this. For instance, I have uh, read the images, read the images and convert it to a base64. And as let's see, as the score or fast API will expect it as an input. Let's see, it will expect image, include visualization, and also the threshold. This is, for instance, just dump it into the JSON file and run. It will send the data for the prediction. And you can see, for instance, if I run now, let's see, not for 2000, let's see for 2. And this code here, this score, I mean, without this, so this won't, let's say, be used in the cloud, or let's say Kubernetes, only the score. And the Azure itself, it will try to create an image including this score, and will try to publish the endpoint, deploy during the deployment. And we can use, let's say, the only the URI or URL. It's called URI for the endpoint, and we will see how to do this deployment in the next videos. But for now, it's just to show you that everything should be running as expected. And you might, let's see, in this score, you don't need, let's see, the Streamlit. But if you are using FastAPI, you need this. You need the Streamlit just to show you the result. Of course, you can create whatever you want, but this is just to show you the stuff how it's working. And I think that's it for today. But let me just check. The config is here. The config, for instance, for the images, let's say for the uh, threshold, and you might, for instance, need to change this. So I just added as a config. And this is the score, this is the test, and this is the training. And yeah, I think this is what we need. And next time I will try to show you how to create endpoint and deploy the endpoint. And deploying the endpoint, we have already, let's see how to register the model, and the endpoint will try to use this registered model. We will see how to prepare the YAML file, and it will use also this code to give you the expected result. That's it for today, and thanks for watching. After registering the model, we now need to use this model. We'll consume this model via endpoints. And for endpoints, there are two, let's see, main steps. One is to create endpoint and then deploy the models inside this endpoints. And you can see here, so this is, I'm following the end file configs. So the file name, let's see, config, or maybe you can call it not my, as we have said, let's say AnomaVision endpoint. And this is the target. We would like to create, let's see, to attach this workspace, or let's say this is the compute or the target. And the target, you can see it is from here. And let's see, with that, we have here created a cluster, Kubernetes cluster, and this is the name of the Kubernetes cluster. And now we have attached this to the workspace with this name here. And we would like to use this name. And it's also defined in the config. And we will try to, let's say, to make it in the, maybe after this course, we will try to make this automatically, let's say, to create the YAML file, for instance, for, using the inside the, let's say, the YAML file, the pipeline. And the next step, let's see, is to endpoint, and this create endpoints. Let's see. Now we have this YAML file, which will try to create it to use the YAML file to create the endpoints. And you can see this is the command. I mean, this is the command, uh, AZML online endpoint create. And if you go here, let's see, have a look and such command. So, so you can also upload this documentation if it's if you for sometimes the Microsoft they change some, let's say the APIs, or maybe they change some, add some parameters or removing some parameters. This makes maybe since you can see here, this is the file, and you can see here which should be contained. So you can see schema, name, string, I mean description, and also the, so we need also to add the schema. I will add it here. It's in this file here. Uh, Sorry for that. I just forgot the. And you can see here it's Kubernetes online deployment. It's for the Kubernetes. And let's see traffic. We will see this is endpoint. This we will see it in the deployment. And there's a compute version 1. Did I check this one? Create endpoint. Yeah. Yeah, you can see it's a compute. Now I need to change it to compute, not target. Is target? No, it's compute. I just copy, then add it here. And this should be the using the authentication, which is already when we have added this attach, it will be used automatically with. You see it in this. We have attached the YAML file, the Kubernetes to the workspace. And this is the description, and the command, the pipeline itself, it's create endpoint, and you can see he's creating the endpoint, create the use the file from the deployment, use the endpoint config YAML, resource group, and the workspace. And after that, we would like, let's say, to make sure that everything is created as we expected. We just need to use this command, show the endpoint, which for instance name, it should be AnomaVision instead of this one. And after that it will try, if it's there, it will show you some outputs. And that's it. I mean, next time we will see how to deploy the models and everything. Thanks for watching, and see you next time. Yeah, maybe by the way, maybe I need just to add this. So let's see here with Kobe relative path, and in the main pipeline here, I will just try to add it here. Let's see, just add stage. Sometimes copy paste is not the best idea, but we need somehow create end point, and this will depend on attach, not this one, deploy this out, this as well not needed. This one is not needed, and it depends on this one maybe. But for the depends, I'm sometimes I'm just let's see, remove it. Now here we have create. Now once the pipeline will be running, let's see, from scratch, it after, if everything, let's say, successfully created, now it will came to here. What's this? I need this one. and it will try to go to this pipeline here and create pipeline create, and it will try to create, let's say, the endpoints. And as I said, next time we'll see how to deploy the the models. Thanks for watching and see you next time. After creating the endpoint, now we would like to deploy our model into this endpoint. And let's see, this is the file that we would like to deploy our stuff here. So the schema here you can see is still the Azure ML to validate that this ML is using the correct schema. So if you open this, it's just JSON file you can see here. And you can see it contain all of these, let's see, components, or let's see, inputs. And the name of the deployment, it's blue. Why it's blue? You can name it whatever you want, but it's like if you would like to use the A/B testing, it's this is, let's see, common to call the current model, it's blue, and the new one is let's see, green, for instance. And you can set the traffic 50 50, 80 20, and etc., just to compare the between two models. But we will see this in the next videos. And you can see here the endpoint, it's already defined. The endpoint is already defined in this file here, which we have seen it last time. And by the way, I have changed this schema because it was wrong, and it has to be a Kubernetes online endpoint. And also I have updated the names, so it should be, let's see, reflect what's going on. Now we would like to use this model we have already trained last time, and also the environment. This is clear, and this is the compute, which is already attached to the workspace. We have also see the workspace. Wait. And as you can see here in the, if you just remember when we have created the deployment Kubernetes files, let me just show you this one here, for instance, deployment and services deployment, for instance. And you can see here we have replica. It's just to let's see, scaling, how many scaling we need. Let's see, for instance, 10, 10, 20, and etc. Now here it's the same, but let's see, make it more, let's see, let's say save to save money, because it's really expensive to use this. And you can see here minimum instance is 1, and max instance is, let's see, 2, because this is. And when to use, let's see, to extend this, it when you have the CPU utilization, it's 70%, and also the frequency in second, 10%, for instance. And pulse, let's see, this one, pulse, let's see, if every, let's see, 10 minutes, to check the CPU, if it's let's see, to check the CPU load. And the request setting here control how requests are handled. Each instance handle one request at a time, and it's wait up 90 seconds, which is it's in the milliseconds, which is in the 90 seconds for request to complete, and request can wait in a queue up to 500 milliseconds. Let's see, to being let's see, dropped or rejected. And the resources here we have allocate container level, request minimum. For instance, the minimum is 1 CPU, memory is 2 gigabytes, and limited maximum is 2 CPUs, and memory is 4 gigabytes. And for the score here, we have already discussed it last time, and I have, let's see, validate the concept of our example. And here we have seen, we see the core, we need the score script. It's in the score file. And where is it? Is it to, let's see, back in the, let's see, in the parent, let's see, directory, and then rows, and then source. You can see it, for instance. Let me just close this pipelines, many pipelines. But you can see it might be, let's see, confused to have several pipelines, let's see, many pipelines, but it's really well structured. And let me just go to the score. Now here we have the score. And they also add the logging, so you can have a look. You can see the logs inside the terminal and also in the file. Oh no, I don't need to change anything here. Just keep it like this. And yeah, let me just go to the config now, and you can see here I have using the score, and this score will be used inside the Azure ML. Now here we have variables environment. I have log level info because I have the logs inside a score. I need the log level is, let's say, info to log everything we have, and also for the logs I have already provide a log that will be, let's see, rotated when you have, let's see, if you log many datas and it exceed, let's see, 2 GB, it will try to back up and generate, or let's say create a new log file. We have already discussed this. And now the code, yeah, the code configuration we have already see the environment, and here this is now the liveness group. So the Kubernetes is use this to check if the container is still alive, and if failed 3 times in a row, the pod will be restarted, or let's say created. And so you can see here initialize 30, so for instance 30 seconds, and if there's no, let's say, reply or connection, it will try to reply. And the readiness is check if the app is really ready to serve the traffic. Ensure that Azure ML only send the traffic to containers that are, let's say, ready. And the description is anomaly detection, or you can see it with AnomaVision, Anoma, AnomaVision model with auto scaling. And if you have, let's see, and this is the tags that might be, for instance, for search, or maybe it's cost tracking or filtering. And one point here, if you are working in a company and they are, let's say, offering you unlimited, let's say, costs, or maybe it's they have the subscription, so you can just change this to whatever you want. And let me now jump to the pipeline itself, which is deploy. It's not deploy. Let me just see it here, and ignore file, and it's here, create, and we also need to remove it from the file. And you can see now create deployment. To create deployment, you need this. Let me just go back to, because it was. So now we see how to configure the deployment. Now I would like to use this file to run the code with the code. Yeah, to run the code, use this environment, use this model, use this entries, and deploy the model inside a Kubernetes. To do so, we need to use easy ML online deployment create. We need the file which is inside. Yeah, I have changed the name. So let's see, just copy, rename, and that's it. And here we see all traffic. So why I have added this to all traffic, because in the beginning when I have one model, I would like to deploy one model, I have to put all the traffic to only this model. And if you have two models, you can set the traffic into 50 50 20 20, I mean 80 20 and 70 30. It depends on what you would like to add. And here we need to add to check if to get, let's say, the endpoints, and just output some maybe maybe it's like look file, for instance. What is the name? What is the score I? And the score I here, you can use it to run uh, to use the Streamlit app. And once you have this, you will try to run Streamlit app, for instance, the host and also the bot. And I have also in the previous, let's see, project that I have done such stuff, which is, let's see, what is the deployment, integration, production here. You can see I have created this file here, and this will try to test the score URI. Or it's URI or URL. It should be the same. And you can just run this file, and we will do it. I will do the same example. Let's see, just to have everything is in hand. Let's see. So now let's go back to here. Where's the file? Not this one. This one here. Okay, so I have now created this. Now I would like to go to the pipeline, the original pipeline, or let's say the main pipeline, and add here one stage. So I'm adding several stages. Why? It might be, let's say, confused, but it's really help you. So for instance, to just to figure out where is the problem and what is the, you can figure out what is the problem, let's see, efficiently deploy endpoint, and it should be depends on this one. And here we have create deployment, create deployment. So now if I run this pipeline, it will try in the beginning to, I mean, this should be end-to-end pipeline indeed. So I have this here, unable to load from schema, blah, blah, blah. Never mind. Yeah, this is, let's see, end-to-end pipeline. So it's starting with update the submodule because they have integrate, let's see, add a submodule here, AnomaVision. Use the Python 3, 3.11, install the dependencies, run the test, data validation if the data is really valid that we have already uploaded to the cloud. Train the model, register the model and put it, let's see, in the registered model. Yeah, download the model, and if, let's say, someone is interested in build images, build Docker images, and use, for instance, save it in the container registry, he can also follow this. Otherwise, for instance, this from here until this one here, it's not needed. Let's see. Oops. Because I have said there's two paths, or yeah, let's call this two paths. One is to use container registry. We have a Docker image and push it into the container registry, and this attach this container registry into the Kubernetes AKS. And the second one is to use a score file, which we have already, let's see, did now. And if you are using this, you need to comment this one from download. You don't need to download because we are just downloading the model and use it for the FastAPI, inside the FastAPI, to build the image. And let me just see, comment this out, and yes, I think now it should work without any issues. Now after creating this, you will have created endpoints, and this endpoint you can use it with using the this scoring URI. And with that here, you can, let's see, you can open the terminal, and let's see, not the terminal. Yeah, you can open the terminal inside the Azure itself. And after, of course, after doing everything. And by the way, please don't forget to run this pipeline here first. Bootstrap. This will try to create all the components you need. And as you can see here, I have commented this. For instance, these are, let's see, really needed to work with Kubernetes. And this is for GPU if you have already interested in. And let me just comment this. Now, if you see now the pipeline, it will try to create a resource group. This is an installation, the machine learning extension, creating resource group, creating the workspace, and creating the container. You say it's not, let's see, needed right now. I will see. And here, if you would like, with the cluster itself for the training, it's needed. Yeah, let's see, it's down. Yeah, it should be up. But this is the order. Let's see, it doesn't make any difference. Of course, if you have to create in the beginning the resource group, then the workspace. This order is important. Now let's see here. I have created a cluster for only for the inference, and you can see when I see here the enable inference, only the inference. It should be working for the inference. If you use Kubernetes for training, it might be, let's see, much money or costing. And after creating the AKS, we need to attach it to the workspace, and with a different name, or you could use the name that you maybe the same, but I'm trying to use different name. And yeah, because the cluster itself, the Kubernetes, it has one name, and if you attach it to the workspace, it should have a name. It might be the same name or might be a different name, but I have using a different name. And this, of course, did already defined in the pipeline itself. And this is to creating the cluster for the training. And if you would like to use a GPU, it's also up to you. But I will see that for the training, it's super fast. I mean, it will take 1 or 2 minutes in my local PC, which is not that powerful. And on the cloud, it might take, let's see, several minutes. But even if you have a GPU, it will be, let's see, minus, let's see, 3 or 4 minutes. Then I will upload the dataset I would like to upload. Now creating the environment. I would like, for instance, the environment that I would like to use, Anaconda or Docker or anything. But here I'm using the Docker. So please keep in mind, when you run this pipeline and tells you that it's successfully created, or let's see, finished, creating the environment is taking much time. Maybe at least, let's see, 10 or 15 minutes in this range, let's see. But yeah, just to make sure that not, for instance, after, if you have seen, let me just show you. For instance, this here, when you see the pipeline is running successfully, you see, okay, I will try now to trigger the second pipeline, which is the training. And let me just show you this one here. No, I don't need this. You can see, for instance, this is the pipeline creating the Azure ML and container. If you would like to you create container, uploading the images, registering, check out. This this might take 9 minutes, right? But inside the Docker, it's inside the Azure itself, it will take several minutes. And if you can just also imagine, sometimes you would like to create a resource group. For instance, if you go here and create a resource group, it will see, it tells you that in the command line, or let's say CLI, your workspace or resource group is already created, but in the background it's still working. So this is what I mean by now after running this pipeline here, you have to run, or let's see, by the way, one hand here, this component here, it's not needed, let's see, to be created at once. But if you are following this stuff here, you have to run this as it is. But for instance, let me just assume that I have in the beginning creating everything, but for the images I still need maybe to, let's say, clean the data. So I don't need to let's say upload the images. I will just comment this out and just use this after, for example, finishing the cleaning. You can run this command, only this command. It's not needed to be in the same pipeline. Now, after the components are already exist, and to make sure the environment is already succeeded, you can run the pipeline. No, not this one. You can run the pipeline here. So this is really end-to-end pipeline. And in the next lessons, I'm not quite sure if I will cover this, but it should be, for instance, the how to monitor, let's say, monitoring data drifts and also API testing. And we can use also for the monitoring for the Kubernetes, it's Grafana, which is really interesting interesting tool, and we can also use it. But this is, let's say, to create end-to-end pipeline from creating the resources until creating the endpoint and also deploying the endpoint. That's it for today, and thanks for watching. And if you like this, please subscribe into my channel, like the video. Of course, if you have any question, just drop it like in the comment below. Thanks for watching and see you next time. Hi everyone, welcome back to my channel. So in the last video, we have seen how to create let's see endpoint and also deploy the endpoint, deploy the trained model. Now, as you can see here, as last time I said, if you would like to comment, let's see, some tasks, which is I have said, I mean, I haven't used this approach indeed before. So what I have learned today is that sometimes you have some, let's say, stages that you would like to skip, and for instance, let's see, build Docker image, and sometimes I don't need it, but where's the Docker? Yeah. So this is the Docker image, and here you can see the condition is if the parameter deployed is true, and you can see here in the beginning it's false. So this means the pipeline will start running from the beginning until seeing this condition here from here. And if the deploy a container registry to Kubernetes, it's true. If, for instance, this one as well, and you can see till this point here, and if not, it will try to create a usual, let's say, normal endpoint. Then it will try to deploy as we have seen last time. And now there's somehow important step after the deployment. After creating your endpoint and deployed endpoint, you would like to test this endpoint if is it working as expected or not. So for that we have to add a post deployment test, and for this deployment post deployment test, we can see the pipeline. Oh, it's the pipeline here, deploy, post-deployment test. And you can see here, I have created a post file that can, let's say, consume this endpoint. And but to consume endpoint or to use the endpoint, we have to get, let's say, to have the score the score URI or URL and the score key. To get the score key, the score URI, you have to run this command here. To get the score key, you have to run this. And after finishing this, let's see, running this, we will have seen this file here. And if now it's running successfully, it will try to publish the result in the DevOps. If not, it will of course skip. I mean, not skip. It will stop the pipeline. And the file is in integration. Where is the integration? I can't see it. Sorry. Yeah, let's see. Also, the time is also late. You can see it's 2. Now the production test is it has this one here. Let's see, test loading the images. I have to update the image itself. This one here. I have to also to push it in the registry into the uh, DevOps, and also from the DevOps it will be to the system, to the Azure ML. Now when I see test, when I run test, it will get the score URI and also score key and loading the image. If everything is fine, you can see send the post the data to the list endpoint, and for this you will get the response. And the response, if it's 200, it means everything is fine. And we will have the result as well, and you can see the result anomaly score is anomaly, and if there's a visualization, it will be included as well. And also for let's say a good test, you have, for instance, I have a model, right? And I'm expecting from this model, when I send image, to have anomaly score is, let's say, 25. And I know this in advance, so you have to update, for instance, this one here, and see asset anomaly score is, I mean, result dot anomaly score is blah 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 25, for instance. And in this case, you will make sure that the expected result, the endpoint is detecting, let's see, or giving you what you are expected. And this is one point. And the last point, which is might be interesting also for you, it's the approval. So after you did all of these steps, now what do you think about after the deployment is finishing? Now the endpoint, it will be, let's see, published. So assume that you are, let's say, working in a project that consumed by any user. Now the user, let's say, is using version 1, and after this, till this point here, they are still use version 1. And if you approve, they will use now the version, let's see, sorry, they will use also version, let's see, 2. And but here you have to add this approval here. And approval, as you can see, this you have to give it as a pull, because this is not, let's see, an agent, let's say, job to be running in an agent. It's just, let's see, agentless job, which is it will try to send emails to your boss, or let's say to the group or the reviewers, and he has to, let's say, approve. And for that, of course, I have also published, let's see, a course on a DevOps, how to give a permission, how to make a reviewer, how to make a required reviewer, or let's say optional, and everything. Now, there might be also two, let's say, approve. In the beginning, before you are trying to do the experiments, for instance, running this pipeline, creating the resources, and because the cost will be high, in case of the Kubernetes, that you might be also need to someone to approve. And the last one is should be he as approve. It has to be, of course, he. And the next step, indeed, for this pipeline to be, let's see, coherent and efficient, is to add the data drift, maybe retraining, and also let's say A/B testing. But these steps, let's see, I will not do it in this course until I get, let's see, a feedback that some guys are need, for example, are looking for this stuff. I will do this, and also I have a vacation in a few days. So after that, I will try to. I mean, from the beginning of from August, I think I will start with. I mean, I will be back to the computer vision course and Python. Thanks for watching, and see you next time.
Everyone, we have gone deep into many critical areas of MLOps, from automated pipelines to cloud deployment and model life cycle, let's see, management. But there are still few important topics that they are, let's see, still open and might be, let's see, interesting for someone. Is A/B testing. It's already covered in somehow, not in a direct way, but it's already covered, which is a technique for comparing models versions in a production. So if you have, let's see, two models and you would like to test whether model A or B is which one is performing one, and if let's for instance, if let's assume that model A is performing better than model B, so this will we will set the traffic to 100% to this, for instance, model. And this, for instance, traffic, it will be managed by Azure itself. So you just need to select or choose the percent of traffic for each model, and this will be managed by the Azure itself. And also monitoring, we all know monitoring is essential for stability and performance, especially for machine learning. And for this, for instance, monitoring, I have added some, I mean, let's see, many logs, and you can, let's see, figure out which how is the model is performing, how is the model is working, where is the, let's say, the bottleneck, and let's say you can improve, for instance, the inference time by using the GPU, or maybe the visualization by just use simple visualization methods, or maybe let's say the pre-processing you can use, maybe you need to maybe reduce this number of pre-processing steps, but this, of course, keep in mind this will affect the model itself, of course. And Grafana for Kubernetes Service, it's a powerful tool with a let's see, in one lesson, in one video, I have covered the Locust, which is to test the the load of of the let's see, fast API, or a program, or maybe a system. And in that locust, it just tests how many, let's see, what is the latency of each users, and how many times it takes for each request. But here in this Grafana, it's used for instance, to choose, let's say, showing the CPU, GPU, memory, and many others, let's see, visualization. And I think this already not covered, but it's let's see, I prepare the environment so you can add whatever, let's see, you want. And that these topics might be not covered in this course, due to the short time. I mean, I'm really busy for some other stuffs, and yeah, that's it, I think. But otherwise, the course is, let's see, end-to-end project. Thanks for watching, and see you next time. Congratulations, you did it. So we have just completed the most, let's say, hand-on industrial grade MLOps course out there. So let's take a quick recap, and recap everything we have achieved step by step. So we have started with a vision. So this project is real with the computer vision and also DevOps and Azure Cloud. And we built a full end-to-end anomaly detection pipeline from raw data to real-time prediction. And you know exactly how the industrial AI systems comes to life. And every challenge, every concept broken down in a crystal, let's see, clear video lessons. You didn't just read about MLOps, you saw it in action and follow along with real world deployment from zero to hero. And you can see that the project structure, so your master project organization, no more messy code bases. Now you know how to structure every folder, script, and assets for clarity, teamwork, and easy scaling. You can walk into any company and feel at home with, let's see, prolific repos. And the technology used, look at your toolbox now: PyTorch, ONNX, FastAPI, Docker, Kubernetes, Azure ML, DevOps, MLflow, and more. And we have, let's see, gone from the tech stack confusion to hands-on confidence with every major MLOps tool used in the industry today. I mean, we are focusing now on Azure DevOps, Azure, let's say, cloud. And remember that first is set up, cloning, installing, running your first model, and the second and its second nature now. So you can bootstrap powerful ML project in minutes, not days. So if you have this, I mean, I will of course give you. I think I have already give you an access to this. If not, I will push it in the coming days. It's still not updated. So yeah, and this one here you can start just to run. If you follow the videos, you can start without any issues, because before the recording any video, I had make sure I have to make sure that it's running in my side, so it has to be running in your side. So no bugs, no issues. And of in case you have, let's say, working with somehow different environment and you found some bugs, or you let's say face any issues, just drop a comment below. I will try to solve it, and if not, I will try to solve it. And if it's not clear, I will try to make a video also for you, just to follow up. And for the testing, and so you can see it's easy. You have to clone the repo, this repo here, because I have added the git, yeah, cool, the GitHub. And this one is strong, yeah. I have to make it like this, but yeah, it's somehow I need to update this repo. But and you have to install the Beauty. I have used the Beauty in every step. You have to just go to the directory. When you clone this, go to the directory and run this Beauty install, and it will run everything. And you can run any code, for Python code. I mean, for instance, you can run this. Just add the data to your add the back to your data set. This is the options that you would like to might be need to run. And also, by the way, this repo here, it's used is use this AnomaVision, and they have made it in two different repos just to make it, let's see, more organized. And I was thinking maybe in the future, or maybe one of you that is not need, let's say, to use anomaly detection, and he might be, let's say, use YOLO classification, or even any different field, and they just need to get the sub module in this project, and it should, and of course he need some modification in this code base, but it should work in his side. And you can see you can run the fast API, you can run the Streamlit, which is let's see, need to send images to the fast API and also received the output from the fast API. This you can see it in the videos. For the test, I have this is core map. This is core map. It's let's say needed for the deployment for the endpoints and online endpoints deployment. But before let's say pushing to the cloud, you need to make sure that this score is running and give the expected result. So I have added also a test, so you can try to test this PaDiM, or it's called PaDiM. I mean the original algorithm on it's called PaDiM. And also you can build the Docker image, which is I will see it's really easier for you. You can just need to run the Docker image. I have a false, it's wrong, indeed it's NB, but I will update this. Let's see, we can update it now, why not? mm, which is this file here, in Docker, is a Docker, this one here, Docker file.nb. So this I will just split, or let's see, separate Torch from everything. I just need the related, let's see, ONNX and the other libraries. And for the Docker, you can deploy the endpoint into the Kubernetes service, or also you can, if you have an image and published as a private in a container registry, you can also deploy it in AKS. So this already explained in a more details. And for the test and validation, I have for the integration test, I have added the short, let's see, short testing, just to make sure that the code base is running without any issues. And for the load testing, I have been using Locust, and for the data validation, it's written a data validation code, that just to make sure that the structure of the data is what the, let's see, the train or the prediction is expected. For the monitoring and logging, I have added the application logs. It will log many, let's see, data that you would like to have. And for instance, let's just, for instance, this I have deleted some data, and it will show you this. For instance, this is for hrun image analysis matrix, and you can see, for instance, what is the dimension image that I got. Is it if, for instance, if it's different, so you might be see maybe the protocol is not working perfectly or something like this. And this is the latency of each pre-processing, inference, and also visualization. And this is show you the result of the anomaly score, and also the threshold. And also it's an end-to-end pipeline and CI/CD pipeline, and you don't need to make sure that, I mean, nothing here is, let's say, you have to do manually, and everything here it will be automatically. If you just run the pipeline, it has to be running without any let's say interference. So you don't need to add something or copy something manually. Everything will be automatically. I mean, if you follow the steps, of course. And the models that we have ONNX, we have PyTorch, if you would like to use a PyTorch. And also your models are not, let's say, lost in the, it will be tracked phases and always ready for using, or let's say consuming. And how you know now exactly every, let's say, artifact's life, making for instance upgrade efforts. Not only can you build, and you also can contribute like a professional, and just make a fork from the repo, and branching, create your branch, add your changes, then pull requests, issues tracking, and you are ready, let's say, to let's say participate or let's say contribute in this open source. So it's let's say more than welcome. And if you love what you learn, please don't forget to start the repos that I have here that I'm using, and also share your experience and keep the let's say the MLOps let's say going. So your support help us build even better course for the entire AI community. And I mean you can feel free to use this without any restrictions. And I will say thanks for watching and see you next time. We have seen how to create Azure environment with of course CLI and Docker plus the Anaconda file. Now there's also a possibility to use to build an image, let's say environment with Beauty file, for instance, because we are using the Beauty, we can use toml file and beauty.look and make it, let's see, just use it directly without any Anaconda and everything. And you can just use run this Docker inside the C. For instance, you just need to replace Docker.beauty with this one here. I think that's it for today, and thanks for watching.